All right. Hello, everyone, and welcome to my stream today. I wasn't sure if I was going to stream it first because it's been one of those 2 weeks where I've just been doing a lot of work, a lot of bug fixing, a lot of refinement, finishing little pieces up, and I don't know if I had a really exciting headline for this one. That's probably the hardest part, coming up with the stream covers and the stream titles. I don't need an excuse to talk for several hours straight, but actually coming up with the materials is probably the hardest part of doing the stream, which is good because it means I don't waste that much time worrying about streams, unlike videos, which take absolutely forever to make. So yeah, I started half an hour earlier or later just because I was like, I had to make the cover, and I was like, I need a moment. I thought I might get another solid release out if there's another bug to fix, but it turns out it was just I think well, there was one feature refinement I had to do, but it was just some adjustments coming up with a mental model, and I still have more work to do on Solid Start specifically. But Solid 2.0 core is in a pretty nice place. The I had a list of features I wanted to get to, and I think we've really hit them all. Sorry, just let me move my camera slightly. So yeah, pretty excited about that. Yeah. Anyways, yeah, people should come and say hi in the chat before we get going. Hyped. I'm glad you're hyped. Let's go. Yeah. Hello. The key thing about being feature complete is the docs team finally feels comfortable to actually go in and start working on the docs. The last thing people want is to do the work and then for me to like keep on adjusting and tinkering. I think we're outside a really good place. Okay, so like some people, we got a little criticism when I went straight from experimental to beta, because I want some people to work on stuff. I want TanStack libraries to be able to go and people feel confident and stuff. I would more likely say that like we were still missing some stuff at the beginning of beta when we went in, and now we're not. There might be bugs, obviously, still, but like it might have been a little bit premature to go beta right at the beginning. But I needed to push things forward, which it did. So no regrets. But yeah, beta 7 came out yesterday. As I said, still working on some downstream issues, but I can now make demos of every single feature that I want as core Solid 2.0. So I'm pretty excited about that. Hey, hello. Get Optimus better in the shot. Yeah, no, exactly, right. Sorry, just grabbing a little food here. I do eat sometimes. You would be surprised, being on 6-hour streams, but okay. But we should get started here. Let me get Twitch going in the background too. Also, if you haven't yet, this is probably a good time to like, comment, subscribe, the whole deal. I never say that enough. The channel suffers for it. It just is what it is. Yeah, Twitch is actually pretty dead. Seems like most of you all are on YouTube or on X. Hey Brandon, how's it going? Video dead? Not that I can tell, but if you guys see something different, let me know. Stream froze. Uh-oh. Weird. Yeah. One big change is what I moved the signals repo internal into the mono repo, which before signals were getting updates like at a rapid rate, much faster than the repo was. I was just like doing tons and tons of releases. Signals are in a pretty good place, so I brought them in internally. Okay, let's see here. I hope it wasn't my internet connection. All right. Well, let's see here. What did I want to... Yeah, Twitch is back too. Okay. So let's see here. Where do I want to get started? Probably we take this a couple ways. Probably let's just demo some of the... It freezes when he checks Twitch. Is that what's going on? It's funny though, because I'm not even sharing my screen yet. That's really odd. I wonder if it's like having trouble having two videos, because I have like I can obviously see what I'm presenting through StreamYard, but I wonder when I go to Twitch if that's where the problem happens. All right. Cool. All right, so no more freezing, hopefully. Okay, sorry. I just had X open. All right, let's get... Weird. Like VS Code, I haven't opened that for ages. Cursor. Nothing freezing on YouTube. Well, there you go. All right. Oh, yeah, this was fun. The AI actually finished regenerating the signals library from scratch, passing all the tests past week. So yeah, I mean it's doable. I actually got a different agent to check it. I didn't get any further on this one, the GSAI benchmark, but yeah, signals from scratch. And then I got to do some further refinement from missing goals. But what did I do? Repo comparison on performance. This is kind of interesting. It's a little off topic though. Maybe we'll talk about it later. Okay, let me open the solid 2.0 repo. It's a little out of date, so let's but oh, weird. Why is it still showing Google? Sorry, let me see what's going on here. Should be the entire window. Let me share my screen again. Oh, it's entire window. That's why my problem was. Okay, let's go here. There we go. Sorry, I got like stuck on Chrome while I was talking. Okay, cool. We're back. All right. Yeah, last time on here from like 12 versions. Okay, let's npm. Oh, v plugin solid is out of date too. I mean, it's not a huge deal, but v plugin solid should be like net 4. Sorry, not a huge deal though. I'd like to know how you use AI. I covered that a couple streams back. Honestly, I can't say that my workflow is particularly optimal. I was having trouble with overlapping. I was gonna like reach out to Theo like a month ago and be like, I need a workflow where I can like cross-sectionalize workspaces so that I can work on features independently and they can just like take like multiple repos and just build them into these virtual workspaces so that I can work on each feature independently. I never got around to because he wanted feedback because he was working on something. I found out later that it was actually him. I think he was working on T3 code or something, but this was like before it was public. But I never got around to reaching out to him because yeah, the biggest challenge for me is parallelization of a lot of the like the different ideas because eventually the stuff starts overlapping. Actually, having signals in a separate repo actually helped a bit for a while there. So mono repo is kind of awkward, but of course you could just make copies of the mono repo, so maybe that will make it easier. It's just it's interesting because AI has been such a huge productivity boost for me because as I said, my problem was never the concepts or the ideas. I just didn't have enough. I people just building the stuff, right? Like uh, the bottleneck is often me communicating ideas to other people. So like AI has been incredibly helpful for me. Still, I still think about the blessed way to bundle solid JS. To be fair, they have a reasonably fair point. The challenge is, and I think this is something you see in the solid ecosystem you got a little bit is, I did stuff the way I wanted to initially, but kept it deliberately very open so people could do whatever the hell they wanted. So sometimes my recommendations made into the docs. Sometimes though, people would just go build their other thing because a new tool X came out and they wanted to do it better, but they didn't follow my recommendations, right? So like a perfect example is like TS up or TS down or whatever. I have no clue what that is, but apparently that's like the last couple of years has been like the way to do TypeScript, right? I'm a roll up guy, right? Um, and then people come in and like report issues about like TS up down, and it's like, well, what the hell are you guys doing? Like the roll up preset is exactly how the output needs to be, right? Um, but whoever went and did whatever, like there's like a missing gap, and that's docs because we probably didn't explain why we made the decision of why the roll-up plugin's the way it is. So yeah, I do get it. The ironic thing is for the guy, and for people who are wondering what the hell I'm talking about, is someone was on X and they were like, I it's fine, I don't need to find it right now, and I don't need to call them out, but they were trying to figure out how to just bundle a solid library. And the truth is, at a baseline, if you just want to ship a solid library, just ship the .jsx file, or I mean, do compile from TypeScript down to JSX, but just ship the JSX. So you could just use TSC. Ship the JSX file and the types and put it on a solid export condition. That at the baseline will get you where you need to be. Then we'll find it and we'll compile it for you into each app the way you want. What's weird, the difference between solid and React on bundling is that, I mean, I feel like this hurts it long term too, because React actually changed its JSX transform at some point. Is that people pre-compile everything and then you get the final source, the React libraries. And we do recommend that for the no build people to also like make a pre-compiled thing. But because of all the different like permutations of like CJS, ESM, client, server, hydratable, not hydratable, like whatever variation, like at a baseline, you're making 8 different bundles. So it's like, just ship the source code, right? But again, that guidance probably needs to be harder, harder established in the docs. See, something like Svelte, people don't worry about that because no one expects the code to just work. So like they're like, okay, we're shipping the source. Same with Vue, but for React was pre-compiling it and shipping the compiled output, which is a little bit different. Get workspaces. This is my answer. Work trees. Yeah, I mean, Cursor keeps on making work trees for me. Hey, Anthony. Every framework is just a giant config file exit page in the day. Yeah, TS up and TS down. Yeah. Yeah. Well, at least meta frameworks are. I don't know about the actual core frameworks. He's not wrong, but he's also wrong in that React doesn't have a best way to bundle. In fact, React docs went out of the way to avoid mentioning B despite it being the best method. That's true. React is just popular enough that yeah, exactly. This is the core constraint here. JSX does not have a prescribed compiled output, but every tool builds React's old output in. Some might use the React's new output and update it, but literally the state of things is React would compile JSX a certain way, and every tool just copied it themselves, like TypeScript did, and all these things, Bun, whatever. They're just like, look, we have React compiler built in, and then React went and changed their compiler. I don't know if they all updated right away. I think they might have by now, but it's like kind of unfair to everyone else, right? Especially when like React like themselves are like, look, like JSX spec, there's no prescribed compiled output, right? But this is an old topic. Yeah, Redwood. That's what I mean kind of by the meta framework level, I think is where this really comes in. When the bugs are fixed. Sorry, I know this is terrible. When should we expect all 2.0? I'm gathering that's why a lot of you guys are here, because you want to know where we are at. And the answer is when the bugs are fixed. And the bugs don't get fixed unless people use it, and people don't use it unless the docs are present, and people don't write the docs unless the APIs are stable. So there's still a little bit to go, but at least we're getting to actual point when people can use it. Yeah, I'm just here for the release date, of course. Yeah, okay. Sorry. Let's continue so we actually can get into where I wanted to get into. So do. That's kind of interesting. I haven't actually installed this for a while. That I didn't actually notice that. Like I installed on my local machine, but not on yeah, solid signals is in the local repo. Okay, let's try. Let's just go npm build. This is a good test because obviously when you do all the changes, yeah, exactly. Okay, so what's going on here? Because obviously when you do all the tests on like in one machine, you set everything up to work on one machine and you don't like pull it from scratch, you're gonna miss stuff. So cannot copy. So this is so even though the repo works for me on my computer, when I switch to another computer, the repo's having an issue because the bundling time. Okay, this is the perfect kind of thing that AI can help me with. Can't seem to build the repo. I think I think turbo depths might be in the wrong order, or some of the package linking. I noticed an issue with peer depths with a fresh install. Okay, let's get that going. It's like this is the stuff I suck at. Just on a side note, like I spend all I can like figuring out why the repo doesn't build is the most painful thing, right? I don't care about like tricky concurrent rendering bugs and like working through those scenarios, but figuring out why turbo doesn't build completely cripples me. This is the biggest benefit of AI. I had this problem, this issue where we support CJS in Solid. A lot of libraries I've started dropping support for that, and basically the challenge is that actually this is related to that sync dual types. We need to generate two different TypeScript things. Apparently we need to generate both like an MJS and CTS version of the types, which we've never done in Solid 1.0, and it was a gap. So I had no clue how to change the build process to do that. So I like actually was just like, AI, can you fix this for me? God, I'm using auto right now, which is horrendous. Hopefully it can handle it. So I've been having weird feelings about agents recently. I was really stoked on Opus 4.5. Then I've switched to 4.6, which like slowed things down a little bit, but still seemed very smart. Then I switched to GPT 5.4, which seemed very smart and very quick. And then I decided that I don't really like GPT 5.4's attitude. Like, I don't know how to put it. It has a different personality. And then I was trying like some of Cursor's built-in models, and I in the end, I think Opus 4.6 is still the best. I have no empirical science behind that. It's just that like Opus is kind of like humble and smart. It reminds me of like a developer I'd like to work with, and GPT seems like it's a show off and gets a lot of things wrong and then like doesn't admit when it's wrong, which pisses me off. Yeah, 4.0. I don't seem to have access, at least in Cursor yet, to 4.7. Let's see what I can do. Not auto. Oh, it is out. Fucking hell. Like as of like yesterday or today. I want to try 4.7. I'm going to be curious about that. Not that it need it for this. I'm sure. Yeah, so what we've got here is Composer too. But yeah. 50% off during launch period. No arguments there. Yeah, it was funny. I literally looked yesterday and I didn't have 4.7. Maybe I hadn't updated Cursor, but here it is. Yeah, yeah. It's just to say, they say the best of weeks. I think the best of you so far. Yeah, I'm curious. 4.7 might be even better. So as I said, this is the kind of stuff that I love AI for, because like honestly, hunting down freaking why the repo isn't building or the tests. The only thing that I've been finding though that's been really painful, which unfortunately this is getting in the way of what I wanted to show off today, but we'll get there, is that sometimes the tests, like as the suite gets larger, will just fail intermittently, and again, classic GPT. Yeah, everything passed except for the 20 tests that failed, but that they were there before I did any work, and it's like, no, they weren't GPT. No, they weren't. Like every time, it's like it wasn't us. Like every time, it's like just put a release, completely clean slate, everything was working, 100%. GPT changes one thing, the test breaks, and it's like, no, it wasn't me. Um, all right. Anyway, no problem. I will just rewrite the tests. Yes. Yeah, that's the next step, right? Well, if you, yeah, well, if it was me, then the test must be wrong. Like, real accountability problem. I sometimes it's nice GPT. I like sometimes putting ideas with, because like it's so confident that it can solve stuff, and then you're like usually like the epiphany moment happens when you're like, GPT, you're completely wrong in basically everything you're saying, but you made me think of something. You know. Anyway, I haven't had this happen yet ever. Finds a failing test, then skips it and says it's fixed. Yeah. All right. So hopefully, but like even right now, I'm not confident that it's actually fixing my issue. Like it's fixing my issue in my local repo, but it's not fixing help future people who download the repo, and it does. It's such a weird way of asking. I'm not saying it right, but whatever. You know what I mean? My gut is that they're going to make this work and then like, but leave the repo broken. Oh, this is a node issue? Huh. What is the issue? What's the latest node LPS? I mean, you guys in chat might even know. Do I have MVM on here? Looks like it. Let's go up to 24. Yay. MVM alias default 24? I think that's right. Okay. That's it. Node. Okay. Looks like I'm on the right version. Whatever. npm npm build. There's like a formatting issue right now with these two files. It really doesn't matter. Yeah. All right. So build's working. Let's npm test, make sure we're not insane. Okay, cool. Sorry for the weird AI tangent. It seems like it starts every stream this way now. Yeah, I've been using plan mode slightly less recently. Only slightly though. Like I use plan mode when I'm like implementing features. If I'm like attacking PRs until I notice like something really weird, I can just be like, hey, what do you think about this PR? What would you do about this? And it's usually smart enough to not go and implement it right away now. Did I already push it up? No, I didn't. Okay, good. The package. All right. I would have never found that node was the issue. It would have taken me a lot of time to figure that out, for sure, yeah. Yes, which apparently is exactly what I need, having unlimited juniors at my disposal. Yeah, plan mode is my like go-to here. Formatting issue doesn't matter. Okay, cool. So now the repo working. Okay, pm build, pm filter, SSR example, stream, build. Yeah, okay, let's do it. Cool. I want to show you guys. Okay, I want to show you all an example piece of code that I've been using. I use this example probably more than people realize. This is like my smoke test before releases. It's been in the solid repo forever. Let's see, actually, can I make this all bigger? Yeah, there we go. Hopefully that helps people see it a little bit better. And essentially what this is so get the code window a little bit bigger here, is an SSR example. I do it both with render to stream and render to string just to keep back compat, and then they both share the same core thing. But basically, the entry point is an Express server on port 3000 that sends the static assets, and then everything else gets fed to a render to stream call, which takes the URL. And this is like the most simplistic SSR example ever. And then from our Beat plugin, we or actually not even Beat plugin, we don't have Beat here. This is just using a virtual asset manifest that got built, the built-in roll-up essentially, just as like to handle the thing that Beat would be doing. And the example is, it's not exactly what Beat would be doing here, but it's close enough so that the actual code itself is pretty clean. It's static. Oh yeah, payback and styles. So in the source folder, what we have is index, which is literally just hydrate app, which is the thing. So this is document level handling. And then inside components, we have a bunch of pages. We have a router, which is, I wrote this router before I even wrote solid router, because I literally was just like, okay, how do you write a reactive router? And it turns out fairly simplistically. I probably haven't gone over this example enough. I recently did update it to TypeScript, which was very much needed. But essentially, I wrote it as a hawk, higher level component for those who aren't familiar with it. And what it does is essentially creates a signal that represents the location, and then determines the match by if the location is equal to whatever you ask it. And then if it's in the browser, add some pop state logic. And then, which honestly, this could have just been like a unsettled, to be fair, whatever. I wrote this so long ago. And then I make a router context, which passes in the location signal. And then honestly, yeah, why is this even, this could just literally be set location and matches. It's funny. Over time this is actually reduced. So I think set location and matches. This is a pattern you'll see I use a lot, where the read is a signal or store, and then I use an object to express the options on it, like a tuple. I pretty much use this pattern a lot. And not any real router. This is like how you'd write a router if like, this is the core mechanics of it. What I like this from a learning standpoint is the fact that this is all a router is, from like at a base level. It does a million other things. So like if you want to make an actual router, you probably want to do path matching and all that stuff. This router does not do that. Like, its idea of match is equal. There's no like nested routing, no thing. This is just like, if I didn't want a router in my project and I just wanted to like have pages, like single pages, and like just switch through the pages, I could like skip having a router and just have this. So I didn't care about query params. I didn't, like, routers have a million other concerns. This is the most simple reactive router you could probably design that's still fully functional with SSR. So that's probably it. Yeah, values methods. Yeah, this is a great pattern. So yeah, router context, you'll see in 2.0 you don't need dot provider. It's a small quality of life change. And then use router, simple. Use context for the router context. If not router, throw router context not available. And then return router. So like literally, there's nothing here. And then link. This is before I even switch to the capital A anchor thing, maybe that might be fun to do, but whatever. The link is get the set location from our use router, history push state, the path, from the link props, and then set the location, which is that signal that we pass through, to the new path. And then this just wraps an anchor with class link with this href on click, right? Because we do prevent default. But this, I mean, what's cool about this obviously is you can, if there's no JavaScript on the page, like it fails, the link still technically works because you encoded the link here, and on click doesn't fire, which doesn't prevent default. So this is a link that works, and that's it. That's a 62 line router essentially. It's just a signal that stores the location. What's cool about this, and why I think this is kind of illustrative, is because the way Solid 2 is built, this router is fully suspense, fully transition capable. Like it basically does everything automatically. Like this has, because transitions are implicit now, like this is basically, this simple piece of code is actually like relatively, I won't say bulletproof, but like it does everything you'd expect it to do. This is kind of the power of the model here. But I just wanted to show so everyone could understand what the code was doing here. It's because then in my app TSX, it's like, there's a reason we have file-based routing, but my app TSX, I just use the router to get the location and the matches. It doesn't need to set the location. That's only handled by the links, though you could call set location yourself if you wanted to. And then all this does is there's a bunch of lazy loaded components. Profile's not lazy loaded. I'll explain why in a minute. But essentially, we just get our page here, which is HTML, head, title, blah, blah, blah. We put our hydration script. This is in Solid apps. We need to do this. So this way it can manage hydration before the framework even loads. We have a bit of an inline script that handles data serialization, streaming capability, event replay capture, like all the stuff. And then in the body, I don't even know if this ID app's needed because it literally hydrates from the head. So this is probably unnecessary, whatever. And then here's our nav bar, which is a UL. And, a lot of link tags have like active link and all that. I just put a class on it, selected, when it matches index, matches profile. I mean, this is redundant. A lot of people will build this into their link component. The challenge is, and if you've ever used something like Bootstrap, you know what I'm talking about, is it's often not the link itself, but it's the parent of the link that is handling this kind of thing. So yes, there is duplication here because I'm saying path 0 matches index, like this, but you like, this is all you need mechanically. Yes, well, no, not key presses. The events. Oh, actually, it does. Yeah, actually, on input. Yeah, it tracks key presses. Yeah, on input. On click. There's like 3 or 4. There's like 4 events that we do by default. The other ones you can also like add it to your render script and it'll generate it with other events. Yeah. So again, CSS people tells me that we could do it differently. This is the most simplistic router you will ever see. The funny thing is, if I wanted to make this even simpler, I'd get rid of the link tag, and then I would like use an anchor here, and then use event delegation over the whole thing, which is how Solid Router actually works. But you get the idea. Like mechanically, we need one signal location, and then we need a way to ask if, like, the matches here is only existing just so that we can like select the right tab, and then if we want to know that if we're in a transition, we just go is pending location. Again, we just get the signal here, and we're like, look, is if we're in the process of navigating or something and it's pending, then we just ask it. Is pending is just something from Solid. We don't need anything special here. We just go, hey, is this signal like still in flight? Can it commit? It's async. So pretty straightforward. And then we have a loading boundary where when the page is loading initially, because when you look at the router is just a big switch match. It's switch match when matches this, show home, show profile, show settings, show stream. And all of these are lazy loaded. So if you're on a different page, you don't load the code for the page you don't need yet. There's no router preloading or doing anything fancy here. This is just basic things. And then finally, we put our index.js script tag on the page, make sure it's async so it does not block when streaming. And that's kind of the gist of the top level app. Each of these, if you look, are the different pages, like home, which is just a signal with an onSettle call with proper cleanup. The it shows a counter, pretty straightforward. Profile is the fanciest page because this is how I originally came up with the strategy for data loaders, with file system routing. Again, this demo has been in the solid repo since like the beginning of time almost. I used this from like very early. This is how I tested initial SSR back in like 2019-ish time period. It's how I designed the data loaders, because I was like, okay, well, how do I want this to work mechanically? That's what thinking here. So I'm like, if instead of making the profile lazy, what I actually want is the index route to load the data and then call the actual profile component with that data. And the actual profile component, the nested one, is lazy. Ignore this stuff. This stuff you're seeing here is something that the Beat plugin actually injects for asset management pieces. If you look here, that you'll see them too. All this like second home and stuff is the Beat plugin automatically injects this stuff. That's the one dirtiness in this example. I don't have that, so it's and the file system router generates it and start and whatever. The reason it has these keys I showed in a previous stream is so that we can do smart stuff like hold on CSS, and we can coordinate asset preloads and all that stuff without doing any extra code. This example, I should check it here. I don't know if it's actually still doing, like, does it still use virtual manifest? Yeah, we don't use any special like file like analyze. We used to use something in this example for years, which analyze stuff for, I think, for preloads, but this actually handles all the preload tags in the head and all this stuff automatically. This piece here, like, you could pretend the solid manifest thing is the Beat and virtual manifest thing is something that the Beat plugin already does. So like, generally speaking, this is just like everything in this file is just like solid plugin Beat. So yeah, this is actually not, it's super simple. So anyways, moving back to our example here, my point is, instead of lazy loading the data fetching is part of the main bundle. So this is adding to the main bundle, but then we lazy load the code. And what this lets us do is fetch the code and do the data fetching in parallel at the same time. This is basically a loader, isomorphic loader, right? It's not like Remix's loader. I had this pattern way before that. It's an isomorphic piece of code that's in the bundle, the main bundle on both sides. And when you go to that route, it will load the data, whether it's on the client or the server, and then lazy load the component with that data. And the component itself is a little bit more interesting. But let's before we dig into the specifics of each route and how that works, let's start our streamed example on port 3000. And look at this. Okay, ta-da. This is our counter, right? And as I refresh the page, you don't see a flicker here because there's nothing async on this page. So the fact that the thing was wrapped in a loading boundary didn't really matter. The reason this page had, sorry, I guess the settings page is the next page I should show. Settings page. I use this as, this is proof that hydration works essentially. And if we check, there is no not sources, console. Why am I Let's look at console. Yeah, there's nothing in here. Okay, so hydration worked. There's no warnings, no messages, no nothing. Okay. Settings was like my next one, whereas like this is like the first Angular demo ever, which was like, and I type in the box, it adds it in the string, right? And obviously you want to make sure when you refresh the page, it also does that. And settings, unsurprisingly, is just a signal. There is a unique ID because I guess this is how I demoed the unique ID feature, because this is how you can set a label. Honestly, mechanically, all this does is when you click on write, it highlights, right? The funny thing is that, yeah, when you click on write, it highlights this. That's what all the label does when you need the label for. I think I might have also did this to shove it in React's face that you can just use for in solid back in the day. But this is the basic text input, ID, value, text, on input, update that text. Nothing really fancy here. But I'm working my way up. So what do we hear? I like Solid, but I don't get the incentive in learning it would be given the web dev is pretty much an AI wasteland now. Companies mapping protein lines instead of actual code quality. I mean, some things can't. There's certain. I'm not saying that certain trends aren't going to impact us forever in a certain sense, but there's also some things that are not sustainable. And measuring on lines of code is, I think everyone, you can kind of fundamentally understand that this is not something that could ever persist. You know what I mean? Like it's moronic. Like the best code I write is that has the least lines of code. So like these things are against each other to the point that anything that people think they know right now, they don't know. So I wouldn't worry about that. The real concern is whether people think that like frameworks aren't necessary, or I'll just use React or just use default option. Tanner wrote something actually really apt about that. Maybe we can find it. And I think he's 100% on this. Where is Mr. Lindsley? All right. Because he was talking, obviously, going from Next to TanStack starts. Ironically, I think the shift to AI should actually increase 100 times. I should bookmark this. The thought and care you put into framework and toolkit selection, even if it takes 1/100th the time to implement. Nice manual. It's doing a talk at a React Summit. Anyways, we'll talk about the React server component stuff with TanStack a little bit later. But it's just anything people think they've concluded about AI right now, they're probably wrong. Probably. Yes, you can have an individual loading wrapper, and one of the profile example will show that in a second. Wasn't that a joke in the 90s? Yeah. And that's the other thing. If you've been around long enough, you start seeing the same trends kind of wrap around again. The devaluing of popular languages, framework tool system going back to the 70s, there's always been a drive by good engineers to move away from commoditized option. Yeah. I mean, it is on us. So we have to be vigilant, but whatever. Like I'm not worried about that. Like this is just not something that fits into my reality of where things are at. Like people, there's a whole narrative of this stuff on X or whatever, but you learn just to kind of ignore it because it's noise. Anyways, I'm getting there because each example is going to build up, right? So obviously simple, right? I do love the little details here that Solid 2.0 makes like a little bit cleaner perhaps, but not a huge thing here. So profile was the original one here, because let's look at the profile page. Props.user, which is the first. Actually, let's look here. We load a user, and then we purposely cascade loading the info. Now, don't get me wrong. In a real app, if you have the user ID, you should be able to load these in parallel. This example I built purely to show how cascading data fetching works. It's something you want to avoid, but this is pretending like you can't grab the info until after you've loaded the user, right? So you see it, create memo, fetch it, right? That's what the new promise is. And then here for info, get the user. And this is basically a test case that I've been running for years because I wanted to show that the data waterfall. So user has to resolve before info can resolve or even be fetched. Inside the page, there's a separate loading boundary. See, out here, we're just reading user, so it can independently load from info, which is just a for loop over this in its own loading boundary. Now, let's go here back to profile, and you see it there. See when I navigated to the page? Well, actually, let's start here. Let's load the page. Loading, loading, double loading thing, loading, loading, right? But when I went from here to here, you didn't see the top level loading. The reason is the top level loading is an existing loading boundary, not a new one that came with the page. So it's part of the transition. So basically the thinking here is initially you don't have the user, you don't know the user, you're going to have to show some kind of UI loading schedule thing. At least that was the thinking. I'm going to show something different about that in a minute, right? But with the transition, we actually hold this page until we've loaded the user at least, and then we only but we're like, it's okay, like most of these pages they're not async, but as you move around you don't see the loading indicator. This one's like, look, we want to wait on this, but we don't want to wait on this, so we put a nested loading indicator to suggest that we want to be able to like we're fine when this is available. And all it does is hold the page a little bit. You barely see it. It goes gray for just like the tiniest bit, but it works. And I this is why this initial example is a counter, because you can see it still counting up while it's switching, which is very important because this, even though we've switched, our switch statement has gone to the next page, this counter is still active. Reactive updates are happening on the page in front of you. And if you look at the code, you're just like, how is that possible, right? See, because I mentioned transitions earlier. Solid has implicit transitions now. So you don't think in terms of transitions. I showed you what the router was. The router is just like setting a signal, right? The app is just a giant switch statement, right? That graying out that you're slightly seeing is this is pending setting a class on here briefly, right? So essentially, if I went into the profile page and said like, no, we want this to be longer. We want this to, now this example doesn't have HMR. So and it's cascading. So I just, let's make the first like even longer. Okay, let's go here. And then I'll go stream build. Obviously I could update this, the latest tools, but this is like my baseline with like nothing, no beat, no nothing. This is the most minimal example. When I switch here, you're going to see it's going to hold a little bit longer here, right? Hopefully you can see that where it's gray and still counting up, right? That's the pending coming in. And technically during that 800 milliseconds of time here where I have my simulated fetch, what's happening, let's go back. What's happening is, even though this is a switch statement, both this reality and this reality exist at the same time. And this is something built innately into the reactive system. It is not a compiler. It is not any like special like wired code that we built in the router or like something inside switch and match that like is special. Switch and match could literally be a bunch of ternaries, you know, like just simple memo. It's something core to the reactive system that when async is pending, we can have well, I'm calling it zombie. I don't have a good idea, but we can have a zombie reality on screen while a second new speculative reality lives off screen. And this is just a feature of the reactive system itself. So that's why I've used this demo forever, because of this feature, right? Now, there's some questions about managing the loading a moment ago, and I got this working now, which is kind of exciting. What happens if I remove this loading fallback around the whole switch statement? Generally speaking, this is not something you want to do. And to be fair, I've shown in previous demos on solid streams where I've just had like remove the loading and it works. The problem is, and I've changed this now in the rules in Solid 2.0, is if there's no loading boundary above, you can get what I call unpredictable tearing, which is this idea that like some stuff waits on async and doesn't come in, even though it's granular. You'll see some stuff and not other stuff, just because like some stuff's blocked and some stuff's not. So I made a rule in Solid 2 that I never had in Solid 1, which was like, if there is async read, like an example of an async read is reading this, in here, reading this user, right? Actually, you know what? Why is this? It's not possibly undefined. Why do you think it's possibly undefined? I haven't actually updated the types here. User is not possibly undefined. Info is not possibly undefined. Sorry, this thing's out of date. Now you're like, am I lying? Will this cause this to error? Well, it won't, because user is not possibly undefined. User is an accessor of user, even though it's async. Sorry, it's funny. I forgot to update that. Way better. My point is, this user is potentially async. This is the first async read. It is above this loading boundary. So if I went in here and removed this loading boundary like I just showed here, it's possible that if it could like block this but still show this, that's inconsistent. You know, you get there, we don't throw away the whole component. It would just like blanks profile and then this section could be for you, and then their name would like pop in later, which is weird as hell, right? So I like React, I took the tack that if you don't have a top level loading boundary, you know, like that's an error, right? You should have a loading boundary at least above the top async read, except during SSR. If we have SSR, this concern goes away. Kind of like in React server components, this concern goes away. And the reason for that is everything's implicitly a transition. See, React server components has that same kind of behavior, so it's fine. See, the problem in classic client-side apps is you can't just say, oh, we'll handle it in a transition, because you can't, like, if you noticed in our application, when we switched between pages here, there's this transition, right, that we're doing, and we never show this top level loading again, even though we can hold it. And the reason is because it's a transition, we don't have to worry about that tearing. We're fine. But you can't really transition effectively when there's nothing there to show in the first place. That's why the loading boundary should be there. But on SSR, when it's from the server, you do have that content, right? Assuming that if there's no loading boundary, you just hold flushing the whole stream, which honestly isn't great, but it's like old school React. Or SSR, if you wanted to send the page, people didn't stream. They just waited for all the async and then rendered everything. So if you could guarantee that the content was there on the server before you hydrate it, before you even send it to the client, then you don't have to worry about that weird, unpredictable tearing problem. And when you go back to that page or ever trigger it again, because it'll be client-side only navigation, you'll have a transition to guard you. So technically speaking, with SSR, we can remove that top-level loading boundary. And what ends up happening is we just wait if we're on this page for user and just don't wait for this. So if I start the stream with this update, actually, did I build? and then start. What should happen is this behaves the same, but now when I refresh the page, what you're going to see is there's no initial loading, just only this that's loading, because the page actually waits for John to load before it flushes, and then it shows this. Now, we have ways to do this already with specific like async things, say just first stream, but now we have a behavior that if people do async above the top level loading, we just like hold the page flush to manage this. So, you know, the funniest thing is, this is like the PPR thing, where everyone's like, PPR gets rid of loading spinners. I'm like, but PPR doesn't do it. What gets rid of loading spinners is strategic holding of the page. And obviously with PPR, you cache it so that it's synchronous, so it's not like, you know, putting in the extra, like waiting on anything. But it's just a structural thing. It has nothing to do with PPR. Yeah, sorry, I already did, but I'll do it one more time. Can we make it one more bigger? Yeah, okay, let's do that. I'll make the chat a little bit smaller. Maybe I can just collapse the AI. Not that way. Toggle agent. Yeah, let's do it that way. There we go. I just moved my face. That's lovely. Yeah, sorry. And actually, if I do this, because I'm just blocking my own terminal that you guys probably don't care about, the code will be even a little bigger. I don't think it blocks any of the example here. But do you get what I'm saying, the difference? Because there's no outer loading boundary now, when we load the page, it waits for John the same way this waits before it does this, right? If we put the loading boundary in on the outside, which, to be fair, if we're doing a CSR app, would be necessary because there's no page to show. We get that slightly different behavior. Sorry, not there. Where it loads and then loads and you get the double cascade. But as I said, this example, you can also design your code not to double cascade. This example is just purposely trying to show what the double cascade looks like. Right? So this removing the upper loading boundary trick is something that React does with server components, but we can get away with here because everything's automatically a transition, which is nice. So yeah, I love this example, as I said, because it shows parallel data fetching. And it also shows just like very subtly, like the await being up here essentially, because we could access our user, and that's passing down to this profile component that, like, let's go super aggressive. I'm not saying you should do this because obviously we don't want to wait forever, but let's say I don't really know what I'm doing with Solid. I haven't made any decisions on stuff. I'm doing SSR, and I'm gonna have no loading boundary. Like, screw it. Just get rid of all the loading boundaries. So profile doesn't have a loading boundary. And keep in mind, with no loading boundary here, this is the lazy component too. So like, even though there's data fetching, there's lazy component loading, and there's no loading boundary. It's not around the first data. It's not around the second data. We're just trying to show everything we can. This component is oblivious that async even exists. It's like I get an info and I get a user. Okay, not done, right? Let's do this. What's our base experience? I'm not going to say it's a great experience, but it is an experience. Because I think controlled loading is actually a very important thing. But our base experience, at least, is that when I load the page, it loads. And the funny thing is, because you don't even see the flicker. See, browsers paint hold. So like, if you don't want to stream, it's okay. You know what I mean? Like, just it shows the page when it's loaded. This is the classic SSR example, right? And then when you navigate away and come back, the transition just holds a little bit longer, right? But again, I didn't make a transition. I don't even know how to call it, because the challenge here is we don't have transitions. We just have good async default behavior. So it's like, do I even call this a transition? I don't even know. The challenge of not calling it a transition is Svelte has a very similar feature, but Svelte doesn't have the guarantees of transitions like React does. So it's like, how do you say it's just async like Svelte, but then be like, but we're doing like way more better stuff than Svelte? It's trickier from a language standpoint. You almost want to name the thing, but naming the thing makes it too heavy, too much. You don't need to. This is just like, wow, it works. And if you want a loading boundary, you're like, you know what, guys, I was looking at the UI today, and I don't like how long this page takes to load. Like really awkward, even when we're like switching. It's like, why are we waiting for this stuff when we don't need to? Like we can show the top of the page first. This area here we can just defer it. It shouldn't be blocking the navigation. It's just like extra information. You're like, okay, well, no problem, guys. I will just come in here and wrap this in its own individual loading boundary. That way it's not going to hold things up. And let's deploy that. And okay, guys, look, see, now you're not waiting for it anymore. Much faster navigation. Okay, solved. You know, like that's the goal here, right? You want these pieces to be movable. You want loading to be something you decide from a design standpoint, not from a mechanical. Like there might be a mechanical aspect here because you're like, this is taking particularly long to load, so I don't want to, block this. But it's also kind of like placeholders and affordances are a design issue. They're not a like there. It is where design meets technology. Like, but it's not like people should be able to just like move them wherever they want. We have stuff like that built into Solid Start, but it's not like something in the core of the framework, right? Solid Start, it's not. I don't know if I forget if we actually have like known bot thing, but we have a mechanism that if you know what bots use, and this could be like a plugin or something for Start, I suppose. You can just change the render mode. It's very easy to say like, just wait, hold. The biggest problem is, as mentioned, is out of order streaming requires JavaScript. Yeah, I mean, these are async transitions, but the thing is, the reason I don't, this is a great default. Oh, thanks. Yeah, this is okay. But the problem is, where are the transitions? You don't see the transitions in the code. Like that's the challenge. This is just, these are async transitions. It's just it's just not obvious from the code, which is what makes this a little bit awkward. Okay, let's go on to the next example. The only reason I keep on adding the loading back to the home, because I actually don't even really care to have the loading in the home here, is because the render to string example that I share, this repo, I showed at the beginning, I made it render to string, render to string. Render to string can't handle async that's outside of a loading boundary because it's literally in the signature, right? Stream returns either a stream or you can .then it, like promise it and wait for the whole thing. But the problem with string is, well, I mean, you can see it visually here. Render to string returns HTML. It returns a string itself, right? Render to string. Why are we not getting types here? It's being slow. Whatever, it doesn't matter. My point is, it can't await. It has to, on the very next line, give you your HTML, which means that there is no opportunity for it to wait. What if that lazy component hasn't loaded on the thing? This example works perfectly fine with all these. The reason I keep this around is this demo, even though it has all these async features, works perfectly fine with render to string. We just render what as much as we can, and if it hits loading, that's also just like fine. We'll just show the fallback, and then the client picks up after hydration and finishes out. It does the data fetching, because like we can't even serialize the data fetching with render to string because there's nothing to stream. Like it literally has to render what it can, so it will try to data fetch on the server and then go. Like basically you just shouldn't use async with this, but like in theory I have this whole test bed set up so that like render to string completely works. And what it'll do is it'll fetch on the server, detect that it's like fallback, and then when it gets to the client, hydrate the fallback while fetching on the client the data and actually finishing the loading boundaries traditionally. Whereas like in the streaming example, we don't fetch again on the client. The data just streams over the wire, essentially. So we fetch on the server. When we get to the client, we match up the serialization IDs and we just stream the data straight across. We don't actually ever refetch. But with render to string, we can't do that. I mean, for solids, like for solid start, the way that we do it is we actually like have a mode switch, which is like in the middle, like at the like the render level, like the render handler. You literally just go like, if this, change the mode to async instead of stream. For like, I don't know. I think that it is. I think there's an example which gives advice on how to do that. I think it's like in the docs, but yeah. So yeah, that's the only reason why I keep on going back here, like out of like to just keep on adding back the loading here, because we need the loading here. It's kind of funny because what it means is with render to string, the very first time the server starts up, it will hit the lazy component, unless you preload it, obviously, and it'll actually stop right here, like even on home. So it'll render the fallback even on home, and then the client will pick it up and go. But the second time you hit the server, where the server's already loaded the lazy component, and then it hits a sync page, it will actually just render the whole page, and then the client will hydrate that properly. So there's like this weird disconnect. Render string really shouldn't be used anymore, but obviously still support it. Render to stream, on the other hand, is smart enough that like in both cases it can manage things in a reasonable expected way. You still have that same wait for async on that initial load on the server, but like it doesn't change the mode that now something's running on the client on the server. It continues being server driven with the stream. When the lazy resolves, the server renders the content and that gets swapped in for the fallback. So anyways, I'm gonna just put this back in before I forget, because I'm just gonna leave it there, but the control is the key. Okay, let's look at the next example. In this, what's the next page that we have here? Stream. So what is stream? Stream is, oh yeah, async iterator. This is how I test async iterators. So picture your data on the server now is a list. Maybe it's coming from AI or something. Maybe it's like an LLM response where you're getting a stream of data. And then it gives you an update every second. And then the stream example does two things. It tests an async iterator memo that accumulates that value. It looks like it's actually diffing it each time. Is that the way I want to do this? Oh, I guess actually, so for memo you have no choice. Yeah, of course. It's literally accumulating and new list each time. And then a projection, which this is my favorite one. It's actually pushing the value each one. So it's actually doing a granular update of the each stream data. So instead of recreating the array every time and saying this is my memo value, the projection, which is a store, is just pushing the new value on the end, which is interesting because when you write this code, that's what you write. It makes sense. But what's odd about it is when you think about it is when you run the code on the server, yes, the server is getting the new value and sending it across the wire or it's pushing it on, but the client also hits this code. So the client has to go, okay, I'm hydrating an async iterable. How do I manage this, right? Because you don't want to be like, you want the server stream to come to the client. Now there's different modes. We have like a hybrid mode, which only takes the first promise from the server and then the client takes over. However, the default is actually that the server is the source of truth. And just like with promises, the server continues sending its values over the wire and the client continues receiving them. The funny thing is this is obvious. When you have a memo, you're actually sending the whole value. You're sending array, value 0, array length 2, 3, 4, 5, because you're just keeping on, it's a stream of what you're returning. What you're returning here is this accumulating array. Now, if you were doing this a little smarter, you might have the memo only read, not do the accumulation, and have something downstream of that memo doing the so basically the async thing here that's like managing this just gets the value and then you'll like accumulate outside, so you're not sending over the wire this duplication. But the reason I'm not worried about that is because we have the projection version, which is much nicer, because what the projection is doing is you might be going, okay, well, if it's not yielding anything and it's just pushing this into a value, how's the client getting the value across the wire? It's because built into Solid with projections, with async iterators, we actually created a patch format that streams over the wire. So we actually diff, like whatever change you make to the projection in each iteration gets sent over the wire. So we don't have to send a snapshot like we're doing here. We're actually only sending what changes, which is really cool because down here, each of these examples feeds into 2 different scenarios. Again, they have their separate loading, but we probably didn't even need this, to be fair. Whatever, it doesn't really matter. But the memo goes into a for loop, which shows the ID in the text. What that means that every time memo items updates, it has to re-render first the first item, then both items together, or 3 items. To be fair, this isn't that different than any other reactive update. If you're just using like signals, you just end up like doing the work here, because it first does 1 item, then it gets 2 items, and then it, like a different object makes 2 items, 3. This isn't very efficient. This side, though, I love because it's using the new repeat component. And what the repeat component does is it doesn't get the array. Like it just cares about the length. And because this is a store that's only getting the values pushed to it from the server. So the server is literally going each value, push it on, and then the client goes, okay, get the patch, push it on. It doesn't need to re-render or update any of the other rows. It literally just goes, okay, there's a new row, length is increased. Just add the new row with the new the new value. So there's no diffing. This is end-to-end zero diffing. Just add the item to the end of the list. So this is a great example of why projections are super powerful here. Because we built in the patch format, this just works automatically, that the server rendering, the original SSR that grabs your stream, will automatically send patch updates over the wire all the way to the UI, which also doesn't have to diff and can accept those patch updates. The renderer still diffs. Yes, the DOM level render still diffs, but if you've ever seen the internals of, which I've shown on stream previously, of like the reconciling, and it's so funny because it kind of React doesn't do this, is why it gets penalized a bit. But the JS framework benchmark, which has pushed everyone to be hyper on reconciling large, like 10,000 row tables. The trick to why the fastest frameworks are the fastest is not purely algorithmic. There's always the part that needs to be sorted, which the algorithm matters, and we do have a good algorithm there. Not the fastest that we've had. Actually, at one point, Solid had an algorithm that was like 3 times more code, but was slightly faster than our current algorithm. But, or sorry, slightly faster on the what I call the worst case scenario, which is like when you actually have to do the sorting. It does it in like a couple less moves or whatever. But the way that most frameworks get performance out of the DOM reconcile part is they shortcut. They use algorithms which attack the list from both sides, and when they see that it has the same thing, it just skips over them. So it's a very quick. It's basically minimizing the range in which the actual changes happen. So adding stuff to a list, it'll just go same. Oh, something. It's like it's very very cheap. It's not doing anything fancy. It's not like comparing the different row orders or something. It's essentially just like a very quick sweep of everything matching. So adding to the front or the beginning, either side, very very cheap. Even with swaps, like very very cheap, because it'll go from the beginning until it finds the things, and then if this one swapped with this one, it's cheap. It basically everything but a random sort can be trivialized from a performance standpoint, which is why stuff like the JS framework benchmark doesn't actually capture the cost of really complicated reconciliation. You have to use like UI diff or something. But my point is that for exactly these kind of cases, the diffing at the DOM level is dirt cheap, because it's literally just like it does scale with the number of elements, but so like the ideal solution would get away from the declarative diffing, definitely, but it is literally just a sweep of like same diff, like equal check, nothing deep, nothing like comparative. It's literally just like, does this div equal what we think's there? Yes. Do that even 10,000 times is dirt cheap. Behave. Repeat is not. Stack is not how it works. I mean, technically it is. Like if you make the length lower and higher, it does only drop off the last couple or add them on, like because the index don't work. So technically, yes, it is like a stack. It can also act like a queue too, because you can use a from on compete, so you can actually use windowed. So you can actually move it through a range, and then it'll only like add the ones that are on the end and drop off the ones on the other end without touching the ones in the middle. Obviously, 4 can handle this, but 4 is like your more typical diffing algorithm. What's cool about using only count and length here is repeat is not aware of the list. So when stuff changes or moves, it's literally the fact that this is a store, like that, like it's basically non-keyed, where 4 is keyed, where it's like, oh, it's like you reactively updated what's at items I. If you didn't update what's at that index, nothing's going to update. So it turns everything hyper granular in a non-keyed way, because you could also just like change the list, and instead of like basically if the length doesn't change, repeat doesn't run. So if you had 10 items in a list and you replace them with a completely 10 different items in the list, repeat doesn't do anything. It's just that this binding here, when it goes, oh, what's ever at index 1 is changed, will trigger. Oh, index 1 will change, will trigger. So these bindings will change, but there's no repeat does 0 work. That's the definition of non-keyed. It's something to keep into consideration here, that you can see it right from the arguments. Like essentially, keyed or repeat doesn't manage the reactivity for you. So if you have, as I said, items like this that don't change, chats are generally good things. They generally aren't that editable, and you're just adding stuff to an end or something. Repeat is incredible because essentially it doesn't do any extra work for stuff that's fixed. It doesn't do any diffing. It doesn't trigger. Like, to be fair, stores have that quality, like the old to-do app. If you hit done, undone, that doesn't change the list, doesn't add items. For doesn't trigger. Like if you're just like changing the text on this, for doesn't trigger. But repeat takes that further because the shape of the solution, unless length changes, doesn't trigger. Where for will change, will trigger if like indexes change. Okay. So anyway, this example's a little bit simple. Side note, just before I move on, last thing I want to show is if I refresh this quick and then navigate while it's thing, we can interrupt the streaming without it worrying about weird stuff happening. I just want to point that out. We've gotten very good at our hydration technique in 2.0, where it actually, when it goes to hydrate a part of the page, it actually snapshots what it expects from the server. So it's possible for it to hydrate with the expected value and then apply new changes on top, even though a lower section hasn't hydrated yet, because that lower section will still see the snapshotted values when it hydrates, and then it'll apply it on top, which means that we've completely isolated hydration from reactive change, which is amazing because it means premature cancellation that was happening while streaming, while people are like clicking buttons while things are streaming, doesn't happen anymore, which means handling stuff like interrupting streaming while navigating doesn't cause weirdness. Everything just works perfectly. We've kind of fixed streaming hydration. And it's important here because you have the same concern here when the stuff's streaming from the server. You want to make sure that it works. Now, this is the accumulated array and this is the push array. The demo is a lot less interesting than the code you needed to write. But as you can see, these just stream in one at a time. This isn't using loading or anything. This is just literally a streamed data source. The loading here was just so that when it shows the first item, it has a placeholder. If we got rid of the loading here on these, let me see what, haven't tried this yet, but you know, this is part of the game here. This should trigger the top level of loading. Never tried this, so we'll see if it works. But if I'm right, then what should happen is when we load the page, we'll see this loading until the first item shows up. Funny. Ooh, do we have a bug with our projection code? We do. Lovely. Okay, cool. This is something for me to dig into. Let's see what happens when we remove this loading too. Let's make the whole thing do that. All right. This is why we play with this. Now it should, yeah, okay, so it's just in general without the loading around, we have an issue. Sweet. But you see that? Now it waits for the whole page before it shows it. You don't even see the flicker because of that. And this one, yeah. So the client side works. See here now, this page with no loading anywhere just holds the transition until that first item shows up and then it streams it in. I just wanted to show because there is a slight difference between having streamed data sources and loading boundaries. Loading boundaries only care when it doesn't have a value. So essentially, once it gets its first value, we're considered loaded. The stream sources are kind of just like that, right? You go, I want a data stream. It's going to wait till that first item comes, but then it'll stream the rest in. So small detail, and this helped me find a bug. So that is very, very cool. Okay, to be fair, this example is, yeah, actually, you know what? I can show this. I can show the serialized format. It's just going to be a little noisy because both are streaming in at the same time. And actually, I'm going to have to, because see, after the fact, this example isn't like, I need to do it with the fallbacks back in, and let me explain why. Because if you look at this code, there's no server functions here. Like if this was a server function, what you would see is this, like let's pretend this is on the server, right? So this is a server function, right? Our server functions support async iterables. If this was a server function, and then you called it on the server, it would just call it natively, kind of like what we're seeing here. But on the client, it would make an RPC call, and then the stream would come through like that, and you'd see it over the wire format also on the request. Because there's no server functions in this example, this is literally creating a generator on the server that it streams over on SSR, and then after the fact on the client, it's literally just feeding this in from the client. It's not actually coming from the server. If it was a server function, it would. So the only way that I can actually show you this, the serialization format, is during that initial SSR, because in this example, that's the only time it's actually hitting the server. So that's why, because the bug, because it was broken, because it was broken, we just found that bug. I actually need to add the loading back because we want it to actually show the working serialization format. So let's do that. Let's do that. And load the page. Yeah, see, there's a hydration bug, but I think once I build start, once I add back the loading boundary, we will see no hydration error. Yeah, there's no hydration error. Okay, so let's look at the wire format. What do we want? Network. Should we look at stream.html response? Yeah, let's see if I can make this a little bigger for you all. So what are we doing here? We draw the page, then we set up our initial script tag, we set, this is all expanded out so you can read it. Then Seroval serializes async iterator because it recognizes it right off the beginning. Throw blah, blah, blah. So this is actually like the Seroval implementation of an async iterator. And then, so there's a little code there. This compresses incredibly tight. And then there we go. So this is the inline script. And then we render loading. So we render the fallback with a placeholder. Pieces. Actually, this is the fallback here. Template to comment. That's just the pattern we've been using. I'll explain the template element more. It's actually really cool when we get to reveal. And then what you're going to see here is as the chunks finish, first piece, there's the UL. And then there's the list with the first item in it. There's some comment separators. And then that's the memo. And this is for the projection. Same kind of thing, the list for the first item. And then what you're going to see here is because at that point, the server is like, I'm done with the HTML. I'm just sending the data across and the client's rendering it, even though the server did the data. This is the swapping stream logic that gets logged in. This is the asset management, blah, blah, blah. Don't worry too much about this stuff. And then we start getting, and this is the data serializing for the first item. And then what we're going to start see is the memo and the stream both serializing their thing. The difference is the memo sends the second item. See, oh, interesting. Maybe this one doesn't. Oh yeah. We have a this is actually really nice here. We have a deduplicator, Seroval dedupes. So even though the second item sends both items, we actually dedupe it, so we don't send it twice. Seroval actually, this is the first item again. If we go to like R17, you'll see that R17, wherever we actually serialized it first time, these are actually the same object. So R16 and then so this is funny. So the R17 here is actually the first item, and then it gets reused when we serialize the second item. Whereas for the projection, it's a little bit goofier because it's a patch. So we actually send, again, in this case, the memo is actually shorter probably, but because you can literally do any mutation you want on it, the patch format has to be a little bit more verbose. But the patch format here sends the second item, and then what it does is it also updates the length to 2. So 2 patches. Here's the item, and here's the length. And then third item comes in. If you notice, 1721 reuses the same 2 items from the previous one, so it doesn't actually have to serialize the data again, adds the third item. Here, the third item is also added for the projection, except, and it sets the length to 3. Fourth, length to 4, reuses the same 3 objects, adds it to 4. Yeah, this is awesome. I forgot that Seroval dedupes, which is amazing in this case because it means that the memo isn't actually like the for loop. When it sees what changes each time, it actually sees a stable reference, which means it's not actually recreating all the rows, even without the the even without the projection. It's actually not recreating all the rows because Seroval is actually using the exact same object reference. So when for sees it, for will be like, oh yeah, it's the same thing. Don't create new DOM nodes. So Seroval's deduping here. We have one of the probably the craziest serializer in the JS framework space, other than maybe Marco's. That's why TanStack picked it up too. This is Alexis's work here is amazing. It didn't even occur to me. Thanks for making me look at the wire format. This is awesome. TLC is how you age yourself. I had articles where I like reference TLC about waterfalls, but yeah, this is awesome actually. The fact that the patch format and the non-patch format in this example are basically the same length is amazing because essentially Seroval knows not to send the stuff multiple times because it dedupes it. So it actually only sends the new item each time, even though like it does create a new array with the existing items. As I said, this stuff compresses down significantly fine. Like it's, you know what I mean? Like, but yeah. Yeah, good point. Quick serializer. Yeah, quick serial. I don't know. It does data deduping, but quick serializer is just crazy. I don't even. Okay, fine. Quick and Marco. Yes. I don't even know how to turn that on. To be fair, the DSP was designed for our JSON requests, like the server functions. There was no security concern with the actual server rendered stuff like this because it's not actually like calling eval. It's literally the like when it's yeah. I don't actually know how to do that. I don't think solid start can turn that on. I don't think solid can because I think the actual SSR this doesn't apply to. But yeah, no, that means this works even better than I thought. Which is really cool because it means I mean we can kind of test our theory here. But I mean let's test our theory here. Let's go into this example inside the component here, inside the for, and just do a good old like console.log. I don't want to do top level read. I'm just going to do like I could do like index exactly, and then I can do like item I exactly. It's going to complain at me about a top level read, but there's no downside of doing it this way. If my theory is right, other than seeing one twice on the client because of the way we have to pick up. Actually, I don't even know if we'll see one twice. Let's actually. I don't know what this is going to do. I guess we're going to find out. This is the memo side. Keep that in mind. Yeah. It's warning me, but this is my point. Each component here, even in the memo, renders once 0, 1, 2, 3, 4. So that's awesome. Obviously, you shouldn't read in a reactive value directly because it won't update, which is what the warning's telling us here. But this confirms that even though technically like we're just like yielding an array that gets longer each time, each component only gets rendered once. God, that makes me happy. That's so cool. Obviously, the same is true on the projection side, but because it's just pushing it. But it's very, very cool to see that, like, just the different pieces work coming together to do exactly what they should be doing. Okay, that's awesome. Thanks for saying so, Fuzzy. Um, so yeah, I mean, even when we try and make things not granular, we're not particularly great at that. And actually, you can see here, index 0, only the first component gets rendered on the server. So this is the difference between having a stream of data and having a like loading boundary like thing. Stream of data means like you're not waiting on these separate things. You render the server up until you have something to render, which is in this case the first item, and then you continue streaming the data over as the client picks up and renders it. But the data is still come from the server. You don't have to like restart your connection. Now, obviously, if you want to restart your connection, you could use one of the different SSR hybrid modes. You can like if you use hybrid, what it'll do is it'll actually only do the first promise on the server and then pick up your subscription on the client. This is how you'd probably want to handle something real like a convex or like something that's actually like a persistent stream. This has a finite limit and you're just showing these 5 items or whatever. Like if it's something that's like just like a single response that will end, that you're not holding open forever, this is probably the way to go. If it's something that you go, hey, the client needs to subscribe forever, you don't want to keep the initial HTML page open forever, then I'd use hybrid mode instead of client mode on the specific projection. You can just go here and just be like SSR source server's the default, and you could just be like, no, I want hybrid. Sorry, why didn't that complete? I want hybrid. And with hybrid, it'll only do the first data on the server, and then the client will pick up and continue fetching the data or like reopen the stream on the client. So yeah, I mean, you have options, but this example is pretty good. I don't know, any questions before I move on to the next one? Because to be fair, I've probably shown this exact example before on a different stream. I think I had this last time. The next component that I want to show is error. This is something that we used to do, but I wanted to test it again. What you're asking? How do we handle error boundaries while streaming? So we have 2 scenarios: inner boundary, where the error is inside the loading boundary, and then outer boundary, where the error is outside the loading boundary. Why is this important? Well, both scenarios can exist, and loading has an interesting characteristic. It controls the stream, right? When you inside loading boundary is actually fairly trivial, because what happens is if you error inside here somewhere, like this item.title errors, then before loading can flush, error will handle it and go, okay, I'm errored. And then loading goes, okay, I'm not waiting anymore async. I'm just gonna show the error, right? Easy. But what happens when you have a scenario where the error escapes the loading boundary and gets up to here? And the challenge here is this is already flushed. You've already rendered your page. You've already sent it to the client. The errored boundaries on the client, but the server is still waiting on something. And then the server realizes it's errors. It gets to loading, and then loading's like, yeah, you gave me an error. I'll just send it to my parent, except the parent's not there anymore. It's already on the browser. This is something that 1.0 solved, but I wanted to make an explicit scenario test around this to make sure we kept that behavior. The answer is actually fairly simple. Obviously, if errors on the inside, you handle it as normal. The server is rendering, doing its stuff. It hits an error, and then the loading boundary can flush that error, and it hydrate the error on the client properly. When the error is on the outside, now, I should say before I go much further here, most people, this is why they're like, you should just make error and loading the same thing. And it's like, no, I think I've already showed how you can just move loading wherever you want it to make sense. I feel the same about error. I think these things are UI considerations. Marrying them or forcing them to be together is a mistake. It's a limitation. So how do we handle this? Well, when loading goes, hey, is there anyone above me? It's like, no, they've already gone. Loading goes, okay, fine. I will grab the error for you. I'm not going to show any UI because I don't know what to do with this. But when I get to hydration, so what'll happen is on the client, when it starts hydrating down, it'll get to error, and error will be like, yeah, I'm good. It doesn't know what's going to happen yet. And then it gets to loading, and loading pauses because on the client we haven't loaded that yet. We've hydrated the top part of the page. We haven't got the new chunk yet to hydrate the inside of the page, right? We start hydrating before the page finishes loading. We hydrate as we stream, right? That's why like there's a lot of challenges here. What happens is when loading finishes and loading goes, oh, actually I errored, it basically goes, okay, I'm going to go to hydrate loading now because I'm resolved, and it goes, oh, I've errored. So there's nothing for me to hydrate, essentially. I'm done. So it just goes, okay, I've got this error. I'm going to throw it. So, and then I'm going to throw it back up so that the client error that thought it succeeded before now fails and now shows its fallback. So essentially what we're doing is the artful way of describing this is the page renders up to the loading boundary, sends it to the client hydrates, sees that it's not errored, is just waiting on that loading, and then when that loading on the server finds that it errored, like something down here errors, it throws it on the server through the loading boundary, basically throws it to the client, and the client throws it all the way up to the client boundary that handles it. So you basically throw an error from the server and catch it in the client. That's the mechanism here. And that's what this test is designed to, or this page is designed to do. So let's start that up and look at that. These are just like the little kind of details you hit when you work on this stuff. And that's why this stream, I kind of view around refinement, right? Each of these has a reset button. So when you reset it, it passes the next time. But when you initially load the page, you can see that it has a successful item and then a failed item, both in the errored and loading state. So both of these are still resettable. The one that initially started the error boundary that's inside, that basically errored on the server, then serialized and was hydrated, is resettable, as is the one that succeeded on the client and then threw later and caught it and did that. The only thing you might be noticing, you're like, why is there an error in my console? I haven't been able to solve this. I don't know if this is solvable, but the problem is if it does actually error and I need to serialize that error to throw it to the client, like on the outer case, I can't easily get rid of this without patching Seroval, because Seroval actually like sees the uncaught error. Like we actually serialize the promise and Seroval's like, oh, it errored. I'm gonna think if there's something I can do here. This error doesn't actually matter that much because like it did error, but it is something worth pointing is that because this promise doesn't have listeners until it hydrates, Seroval serializes the promises and it basically views it unthrown, uncaught, even though technically speaking, it is caught and handled here. This is one of those weird ones. That being said, people are kind of used to seeing errors when they're errored. Like the important part here is not the person looking in the logs and seeing the error. The important part here is that the error is actually handled properly. This is just a kind of artifact of the fact of throwing an error where the listener doesn't exist yet. If you throw an error and no one's .thenning the promise yet, that's what you get in the console. If someone's listening, then they're like, oh, it's handled, or if there's a catch on it. But if there's no catch initially, are you supposed to serialize something that squashes the error? No, because then you can't listen to it. So it's like, it's kind of like there's no winning here, perhaps, unless we could attack it at the Seroval level. I'm not too worried though, because as I said, seeing an error in the console when something actually errors actually makes sense. So it's not the worst. But yeah, for all that explanation, this is one of those things where the details are complicated, but the end result is dirt simple. The end result is you just don't have to worry about what's first, the loading, the error. You just design the page the way that makes sense to show these affordances, and you're good to go. Streamer, you guys still alive? I got a new feature to show you. Yeah, see, this is where people go to, and It could, but why? Like now loading boundary has to like also carry the error stuff, and it's kind of like it basically these things can be independent. So there's like someone could go and make a wrapper. Like if you wanted a loading boundary that had error built into it, you can take these two primitives and make it. But if I'm going to make it, then like I'm kind of taking the choice out of here. So like this is a convenience feature. I don't care about convenience as much. Like it's kind of like the complexity that comes from like that compared to just like having two independent parts that work independently is I don't think worth it. Thanks to the support chat. Yeah, exactly. And don't get me wrong, syntax sugar can be worth it. It's just it's it's not where I start from. I feel like this is maybe like the fundamental difference between Solid and Svelte, and maybe because I think differently like this is why I'm sometimes like confused why people make a big deal about certain aspects of Svelte, because I'm just like, yeah, but then there's consequences to these things. I generally try and choose a like you could say that like if on error isn't present, then don't treat it like an error boundary, treat it like this. It's like an optional opt-in that like when you add this property, now it's responsible for catching it. That's like a bit more reasonable than saying that loading is always an error boundary. So like it's trying to decide whether like the forking code is worth doing just to add it as a prop. Yeah, I'm not sure. I struggle with this one a bit. Ooh, actually, before we go to reveal, there's actually one more feature I want to show. I forgot about this one. Yeah. How do I want to do this one? I had an idea. Okay. What if I think that's it for error unless you guys have a comment on that. To be fair, React's async system is this. There's just a whole bunch of like not all of it, like RCs are a bit different, but like essentially you have a bunch of APIs to basically do what we're doing. Like this is like what if you took React and saw Svelte and kind of like I think that undersells it though, because it's like most of this I was already doing before I saw the Svelte stuff. The implicit transition piece, like realizing that was possible from Svelte was key. But it's like, what if you could take those simplifications, but follow React's prescriptiveness completely? I think this is the thing that's lost with people. People see something and they're like, oh, this is easier, simple. That's good. Why the hell is React doing this stuff? And some solutions will just cut out what React's doing and go for that simple thing. This is doing everything React is doing. React solution I don't consider childish. I think React solution is actually very well thought out of. Some other framework solutions are not as well thought out of, in my opinion, and might even look like this. But React solution is actually very, very good. The problem is for them is that the API constraints are too big, and I don't mean in like a subtle ergonomic sense, like we were just talking about, like, oh, what if you use on error instead of error component, like not that level. It's like from a structural level, it makes it hard, and it's not their fault. It's because they're not fine grained. They don't have the same tools available to them. But I think it's very, very important. And the only reason I'm stopping on this is React solutions are like, or their theory behind their solutions are very, very good. People should not discredit React's, like discredit their implementation. Don't discredit the thinking, the design, the constraints that they like, the invariants. Like, don't. These are all real. We ignore them to our own peril. React understands the physics of things very, very well, better than pretty much anyone. And I think anyone who ignores the physics will find themselves, falling off a cliff. What we have that's really special here is we've been able to keep React's physics while offering this experience. That's the key. It's not just offering the experience, it's keeping React's physics. Right. Obviously there's other like details and stuff with React which don't agree on and stuff, but like at a generals thing, React has the best async solution out there right now that's like published, officially released. It's just impossible to use. Like that's the way I look at it. Like it's so hard to use that like even when the core team tries to demo it, they trip over themselves. Like, but the actual like mechanics of it, the physics of it is brilliant. I think people like they just like yeah, I think it's really important that people understand that like React doesn't make up the constraints just for their own thing. Like sometimes people go, oh, they're solving their own problem. And to a certain degree, there's elements of that when it comes to implementation details, but there is like a truth underlying behind all this. Yeah, I maybe interested to take a look at that at some time. I dropped my server component implementation because I thought at the time that there was holes. Like React wasn't wrong. Is essentially the thing. The implementation problem with React is hard to solve, but their biggest problem is that they serialize too much. But it's hard to avoid serializing so much. So it's like it's yeah, I don't know if it's simple. What gives me joy is when we find those intersections where we can actually find that thing where we can keep what React's doing, but actually find the true simplification. I think we've done it here. I'm very, very excited about this in a way that I haven't been excited about stuff in almost a decade. Because it's like this actually checks off the boxes. I'm actually kind of a little bit worried. I have to admit, because I've always been fairly even keeled. People respected the fact that when I talked about other, JavaScript frameworks, when I talk about like, stuff like that, I'm very kind of neutral and I'm pragmatic and realistic and I go to performance, and none of this has really changed. The problem is it's because in my head, when I looked at Solid, I was like, yeah, it's good. It's very good. It does a lot of right stuff, but there's gaps. There's things that aren't perfect, like, and every framework has this issue, and framework authors are going to be the most critical of this, right? I remember when, the first time I saw Next.js and people were like really excited about it. I'm like, yeah, no, this is a huge step forward, but like, people are like, well, why are you even working here? It's like the end game. I'm talking about like Pages router like 8 years ago, and I'm like, no, Next.js is like a 2 out of 10 right now, and people that blew. Like, actually, I'd step back and be like, do you guys, in the scale of where do you think these solutions need to be, where do you think Next.js is? And I hear a lot of 8s, and I'd be like for me, it was like a 2. I think the challenge is that upper range of where the numbers get always gets further. And obviously Next since then has raised the bar significantly. I just think like go back to like 2018. And I think that while the top, our ceiling, keeps on getting higher, so that kind of forces everything else down. And because our desire to dream is going to keep that going, we'll never reach the 10 out of 10. The challenge is, I think, where my perspective is, Solid is getting to a point where, no, we're not getting to 10 out of 10. But our comparative score is producing a gap from my perspective that it's becoming harder and harder for me to be as like, oh, just use whatever you want. That's a personal challenge for me because this is not a zone I'm very comfortable in. I'm worried that I'm coming off as like too much of a shill, which is weird, as I said, because I'm usually not a shill. For me, it's all about the technology. I just think what we're doing is that good. Anyway. No, that's the funny thing. We shifted some stuff around, made it more DOM. If anything, most of the 2.0 work is trying to make DOM expressions do less. Huge props to Tito. He's basically been removing all the edge cases. The goal of DOM expressions, longer term, hopefully, and we get there, is that we can simplify it enough. And I don't think we can get it there completely because I fight it at every turn, but maybe it could get simplified enough that it could be easier implemented almost like as a spec in a different thing. So you can move to OXC or whatever. Right now, that Babel plugin is it has too much special cases. It's too powerful. It does too much. So in a sense, I don't know if we can ever get there completely where it's not a lot of work to kind of port it, but like get down to simplicity that's like, say, React.jsx transform would be nice. I don't know how easy to get there without losing some of the optimizations we have built in. But generally, the direction has been to simplify and remove stuff. We're not about compilers. We're about like transparency. We're about what you see is what you get. So like, yes, templating can never live up to that expectation completely. But I think that like, we haven't been looking at how to like do more with compilation, all that stuff. That's like complete opposite direction. In fact, it's like, how can we rely on compilation less? And you might be like, that's weird. Well, all it means is that future optimizations or future capabilities that compilation can give us can help us get even further because we've made the runtime. Like compilation is a last step optimization. If you rely on it too early, you end up accepting things are like you basically compromise too early. You basically get to a point where like you could have solved something in a way that actually worked mechanically from the runtime stand, but then you decided I need a compiler. And then once you say I need the compiler, you can't get rid of the compiler. Like it becomes the thing, right? Like, which means like you might have cut off a whole design space where you could have actually come up with a better, different design because you didn't have a compiler. You basically use the compiler as a crutch. Now you could argue that with a compiler, now you open to have more possibilities, more things that you can do, right? Which is always true. But it's a layers thing. If you can get rid of the compiler and do more, then when you add the compiler, you can do that much more. That's just kind of the way I view things. So if anything, yes, we've tried to do less compilation. Solid's always been easy to write by hand, like relatively. That's what I demo in all my talks. If people who came on my stream like a year ago when I was first working on Solid 2.0, the demos didn't make much sense to a lot of people because I was handwriting them. I was literally like, I had the reactivity system and I was literally just going like create effect, update this DOM element. Like I built whole suspense demos like what I'm showing you today completely by hand without the compiler, because all the compiler does is like write a couple of effects. You just like write your normal code, and then with the DOM elements, it's like document.create element, create effect, some signal, element.set text, or you know what I mean? Like, so writing Solid by hand without a compiler is easy. Like not easy. Like you want the convenience of the declarative templates, but the data itself is already declarative. So like, it's not like a huge boundary because you're not like creating VDOM nodes or like there's no transform happening. You like the transform is literally the same primitives that you use to write your normal code. So it's like if you go, okay, create a DOM element, create an effect, like that's what the Solid compiler is doing. So like, I mean, I think most people now have seen. I wonder if I can actually, let's just do it in here. Network home.js. Here we go. What is the compiler outputting for this simple component? Welcome to this span. Beautiful. So this is the compiled output. First of all, this code here is exactly the same code as, let's go back to home. this code here, const signal on cell return clear interval. Okay, that's the same. Then we have a fragment with 3 elements in it. Okay, switch back. So this is hydration code. Keep in mind, this is not the basic code, but it goes, get me the first template, which is that, which is the first element. Get me the second template, which is this, the second row. And then finally, get me the third template, although it's an iffy. So get me the third template, which is a span. And then it goes, insert this signal. So basically its child is the signal and return. Now you might be going, okay, well, what's this insert? This insert is special. Like get next element is either clone this or match it on hydration. So don't worry too much about it. What's this insert? This insert, I mean, let's do it. This really drive home my point. Sorry, don't need Slack. My work Slack, sorry, quit. What I mean here is, I'm gonna do something even more obvious because it's easier to see, attributes than insert, because the insert has a little bit of logic because it has to handle both strings and DOM elements. But if we go stream build, an interesting warning. Use stream build, probably because it didn't. And then we set text content. And we look at our home again. Here I got rid of the insert now because it's just setting the text content. What you're going to see is the same thing as before, except this one actually steps in because anyone who knows a text node, it's a little bit faster to update the data than recreate the text node. So our template now has a space on our span. So this is the text node. We don't need closing tags. It's a DOM specific thing, but there's a space here. So basically what it does is get the first one, get the second one, and then the third one is get the third element, walk into that text node, and then create an effect based on whenever the signal changes, set the property data on that text node with the value you get. Like that's all the solid compiler is. And this is not the like DOM running code. This is the hydration code. Yeah. Oh, I'm not showing the code. Damn it. Sorry. Huh. Oh, right. Okay. Sorry. Okay. All right. Let me try that again. It's fine. It won't take very long. What I went in was I changed the span to text content to use an attribute so I could show. But what I was trying to show is that this component has signal, it has an onsettled for the interval, and then it has a fragment. In fact, if this wasn't a fragment, this would be even easier. But it's a fragment, so there's 3 templates essentially in the fragment, because the fragment's just an array. It has text, text, and then text with some text content. So how that maps in the compiler, template, template, template. 3 templates that can be cloned or can be found. And then our component, the top part is identical to what you wrote. And then our JSX becomes get the first one in an array, get the second one. Then the third one is an IFE where it gets the third element, which is that span, walks into the text node. You see here, there's a space here. We don't have closing tags on these because the browser can actually cure them, so we don't have to encode them. So walk into the space and then make an effect that says on the signal change, set the data property, which is faster than recreating the text node, on that existing text node to update it whenever that signal changes. That's what our compiler does. Yes, this is more complicated compilation than React's call H function, but the runtime, like there's no like H function like handle this, handle this, handle this. It's literally like we just created an effect and we set a property on this DOM element, which we walk to. So the compiler looks at the structure of the code and then figures out how to get the top level templates, in this case for matching hydration or how to clone them, and then it just walks to the nodes it needs to based on the shape, which is very apparent in here, and then it just creates an effect that updates them. So like there's almost, this effect is a render effect. It's just alias through the the compiler, but it's essentially the same. There isn't much to it, is all I'm trying to say. Yeah, we still have the H version. It's just kind of a waste of time. Like, I mean, it's fine. It just, you don't get the nice ergonomics of compiled getters in the JSX, which is the reason why the compiler, like, to be fair, if our heuristic, yeah, it's just kind of wasteful, because you could apply our heuristic to something almost like the standard JSX compiler and produce H functions, and then like compile away like the reason we have the H version is so that it works with the standard React compiler. But if we had an H version that didn't work with the standard React compiler, it would still be like slightly less efficient than what we're doing here. So there's like no point of it existing, except to work with the standard React compiler. Yeah, also, yeah, that's the ideal code I'd write just now. Yeah, I mean, they, the thing is, are they going back to VDOM in that case? Because the tricky part is you have to wrap, like, there's only two ways to go. You either use your own JSX compiler, and then you make like an H function that expects reactive functions, which will be less optimal than your direct like Vapor compiler, or you or they default back to the VDOM in that case. I use the standard JSX compiler, and yeah. I mean, it's, this is what I was talking about. This is why we've been trying to simplify it. There's a whole project. Let's look at the internals of the Babel plugin. Decide there is a version that was built on SWR. I think someone's built a version now in OXC. Neither of them are as capable as the Babel one, just because like there is logic in there. Theoretically, someone could do it. The thing is, it's just like there's some features that Babel has that the others don't have. It's really good at doing almost like pre-pack style pre-evaluation, so you can inline stuff. There's optimizations that Babel's good at, but I think that's probably achievable. I think the hardest thing is just been like, I think it might change with OXC. I don't know how much Rust is in there. I just didn't want to move off JavaScript. AI might make me okay with moving off JavaScript though. You know, I was just kind of worried that like I wanted something I could edit, I could make work. There's nothing. It's just, if you have a parser, you can rewrite the logic in the various things. It just, these options, even SWR and OXC, has only been something that's been available for us the last couple of years. Until that point, it was either write a custom compiler by hand or use Babel. And Babel, it's funny, Babel was considered great at one point, or you know, like when I made the choice back in like 2018, 19. Like I was actually working the Marco team, and they were moving to Babel too. You know, like they had their own custom compiler, and they're like, screw this, use Babel now. Everyone can use it. So it's kind of ironic. We've gone full circle now. We're like, people will prefer custom compilers, or obviously, ideally, stuff that works with like OXC or SWR or whatever. But like, there was a time period where using Babel over custom compilers was seen as actually really beneficial because of like maintenance and accessibility. So it's kind of interesting. Jared made a Bun transpiler for Solid the week before he released Bun the first time. He was like literally like 3-4 days before releasing. He's like, okay, I'm just gonna make a Solid thing, and then he kind of stopped because he realized how complicated it got. But he had a basic working JSX compiler in Bun. He put it together in like a day or so. But the you know, there's a lot more to it than that. So it's not like our compiler has a very limited scope, which makes it a lot simpler than React compiler, the Svelte compiler, the Quick compiler. We have like it is there's more like it's a little bit more complicated than the straight like you could make a JSX compiler almost with like a string replace setup without even parsing the AST. Like you literally like it's very like one for one the output. So ours is not like that. So yes, our compiler is more complicated than the standard JSX compiler. But in terms of solutions, it's always weird when people call, oh yeah, you know, those compiler frameworks like Solid and Svelte. Solid is not a compiler framework. Solid is a just JavaScript framework like React. Well, at least React was before the React compiler, which makes us a very much just JavaScript framework now. Yes, exactly. People don't need Babel anymore because they're not using it for transpiling. Problem is the first thing that replaced Babel was ESBuild, and ESBuild didn't support plugins, so there was no like it really wasn't for that time period when people were moving off Babel initially. There was nowhere for us to go. Yeah, I mean, how do you convince these large teams to invest in it? So far, our biggest mobile or type our biggest consumers on these like third party or like these off web things has been in television, like the Peacocks, NBC, Universal, even Netflix was looking at us. So I said that got abandoned, I'm pretty sure, because the migration reacted too hard. So we don't have the same push on mobile. I mean, if someone wants to do it, there's nothing technologically stopping them. We've had a universal mobile capability for 5 years now. It's funny. I wonder if like I think Svelte is getting it like very soon, right? Like imminently. But like we've had this for 5 years. It just there hasn't. I'm not going to be the one driving it, and there clearly hasn't been enough interest. But completely possible. Babel is I know since Vite these things have kind of disappeared and no one cares about the slow level stuff. Babel is just a compiler. It just like transpiler. It takes JavaScript capable code, including JSX, and spits out JavaScript capable code. It existed so that we could like migrate code, so you could write stuff in like the latest, like use async await or use the latest features, and then have them still work in like IE 11. That's just not a world we live in anymore, which is why it's dropped off. But essentially, it was very common. We had all our build processes because we literally couldn't write modern code because of the browsers we had to support. Yeah, the only thing is like today now Lynx is the solution this past year. Before it was native script. Before it's this these things seem to come and go over and over and over again. So it's very hard for people to invest unless you know that. If you know that Lynx is the future, then build Lynx solid and be successful. I think the challenge is that it's not the solid side. I know people are like, I don't know if solid's going to be successful. I mean, whatever. That's on you. I'm confident on that. I just that it takes a lot to invest on a specific third party side. Like so like the Lynx team it works both ways. The Lynx team is like, I don't know if Solid's gonna be successful, you know, so I'm gonna just make a React thing. And on my side, I'm like, I don't know if Lynx is gonna be successful. So like we're neither team's gonna be the one driving that, unless, you know, like someone spent the research to realize the solution is like really worth pursuing. Like I thought Tori was like for a while, although some people tell me Tori uses web views and that's why it's not good, and that's why open code switched from Tori using solid now to I think Electron with solid. I don't know. So uh like no, I'm streaming on YouTube and on Twitch. The link on my profile on X will link you to YouTube, but you can also find me on Twitch. So yeah, I mean, if someone wants to, we would be completely supportive of getting links, you know, going. It's just like it's tricky because like pretend we went all in on Tori and then Tori wasn't thing. This is not our area specialty. I'm building a UI framework. I know nothing about mobile development. That's just not. I can't make that judgment. If there's someone who's the intersection of good mobile development and good web development, I think they would, you know, presumably go like, yeah, Link's solid. That is the thing, and they push it. It's just not my place to do, and it's probably not the Links people because they maybe don't know what good web development looks like. So like, yeah. Um. Anyway, where were we? I got kind of crazily off topic talking about the Babel compiler. I think it was because I was trying to just show the compilation thing, which is fine. We can continue past this. My point is that compilation, Solid is not a compiler framework per se. Yeah, that's what it was. It was about wondering how much compilation kind of plays into it, and it's like not a ton. The truth of the matter, though, is I am interested in the capabilities of what compilers can do to a degree. Like Ripple is interesting because they've found ways to get incredible performance from their compiler approach. And similar to Marco, WYSIWYG editability. So I mean, there's an ergonomic win potentially and a performance win. The challenge is people don't care that much about performance wins these days. So it's like it's really hard to sell. And if the ergonomics win, you know, is subtle, I think the challenge is I feel for Dominic and Co on this is like the people who like JSX are fine with JSX as it is. Like even people using Solid who understand the compilation is different, they still kind of view it as like, oh, it's just JSX, it's just this thing I return, it's just a thing, right? Like this keeps clear JavaScript semantics, you know. The people who are willing to get past the JavaScript semantics, like the Sveltes and the views of the world, they have this like incredible weird hate of like irrational, I'd almost call hate of JSX. Like it's kind of crazy when you actually consider that from like JSX is almost actually technically it's more powerful and superior in a sense. And I'm not saying this from like a preference standpoint. It's like it's portable, right? I mean, don't get me wrong. Like limitations can be good. So like in a sense, like and there are JSX as it is today doesn't support certain features, and when you say like I'm not on spec, like you can just go add those features. In a sense, that's what Ripple kind of almost did. It's like I've got JSX, but I can like do whatever the hell I want with it. But like the people on that side for some reason just absolutely hate JSX. Like I go on Reddit occasionally and people are like, why did you choose SvelteKit over Solid or Solid start over SvelteKit? And it's literally JSX is what comes up. And it's like, I don't even know how to relate to those people. Like, it's really hard in my head. I'm like, I look at Svelte templating, I look at Solid templating, and I'm like, looks like markup, is a markup, walks like markup. Like, who, like, the only difference is it is kind of cool how portable it is, like how like that's a thing that you can return. I think that's but like most people aren't going to even care about that. But for some reason, it's like irksome for people JSX, and it's like I can't even picture a world where I could like hate JSX enough to. Yeah, it's very very difficult for me, right? Which is probably why I I'm like not as let's say like a Svelte or Vue user. Like I could see other reasons for picking to use the different frameworks. Definitely, those reasons shrinking rapidly over time for sure. But like JSX really like I I think there's like this like vibe thing, like this sort of like perspective experience thing that maybe it's because they've used JSX with React, where people are just like I can't I don't even know how they can justify it to themselves. Like it's confusing. All right, Dominic's right here. Ripple's syntax is breaking out to be TSRX, its own project that will be a framework agnostic. Well, you heard it here first, folks. Yeah, so yeah, I mean, wow. I mean, if you think about that, that's interesting. God, he's gonna sidetrack me right now to even think about it. Wow, that's interesting. See, that changes the equation completely. Like, because then it's like, what if you just wanted to use the syntax with solid because you like the ergonomic benefits, right? Because it's like, that's interesting, right? I mean, you guys in the chat decide, but like, what if you could use something like solid and get that, like, what I usually don't care that much about, like, boost on the Svelte side, but you get to keep kind of less of the magic. I think that could be compelling for a lot of people. Having an irrational hate for custom templates felt. I see. I don't. I'm gonna get back to Ripple in a second here, or to what Dominic just said, but I don't. I don't. Yeah, I don't have an irrational hate of it. For me, it's just a matter of like, I'd make a pros and cons list and talk about it from a technical aspect. I think one of the cool benefits of it is when you can define the syntax. Like, the problem with JSX is just because that spec is out there, you can't really change it. Like, if you can define the syntax, then you have the ability to define more behavior, right? You can bend the rules more. It is a slippery slope, so I don't know where it sits. This is going to be my biggest question of where this ends up sitting. But if Dominic can create a tight spec here, it's interesting. You know, I wrote that thing a while ago. I was like, what would the successor of JSX look like? If Dominic can answer that question, that's really interesting, isn't it? Especially if it's something that could work for React as well. You know, like, this is a very interesting question, like, very, very interesting. I was one of these guys who originally, well, I mean, none of it is HTML. That's the thing everyone's going to realize. None of it is actually HTML. It's a new format. Look at Ripple. Actually, no, let me post Ripple here. So you guys check it out, because as a framework in its own right, it is very cool. Ripple JS. Let me see if I can find it. Or TS, right? Ripple TS. I love that. Like, just everything was JS. Now it's like, why haven't we made the move to TS? Because everything is TS right now. It's a special syntax around components and templating. Is what he's saying. Export it out, but it's actually a full JavaScript framework that uses a different sort of reactivity. It's like somewhere between React's, like, component owns the state and solid signals, but at the same time being neither. It can get rid of the re-render problem React, but also simplify some of the overhead of signals structurally by using the fact that it's component based. Want to write HTML, CSS, and JS in their own sense, write function all the time. Yeah, the problem is, like, you write that, but it's, Bear was talking about transparency before. There's nothing real about any of this. Like, part of the thing that I think that makes what TSRX is interesting is, if you look at Ripple, I think they support, like Svelte, they have, like, style. Like, if I go here and I go, like, find me something with style, I think there's, yeah, see, you can do this in Ripple. You can do style components. If that was something that any framework could leverage, that's interesting, right? Again, like, Ripple's not solving your want to put these in separate files, but the reality is these stopped being separate over a decade ago. You can pretend, but I don't like pretending. Right? Like, that's what it comes down to. You're like, do you pretend or do you not pretend? I'm not a pretender. That And the thing is, I don't think other framework authors are either. Like Rich might let the like it's just HTML, CSS, JS travel like a little bit out there because it benefits Svelte, but he knows it's not. Like Dominic knows it's not. What's cool is what this little component wrapper does is it goes, okay, now this doesn't have to be a separate file. This is just a module. You start looking at these things as modular, and then this makes a lot of sense. You know, this was a separate file, now it's a module. You know, I think there's other features. I think they have something like server functions in here. Same idea. Inline modules. That's all we're seeing here. Like if this sorry, I want to go back to the component thing. But if this was instead like import like an inline module as component or as Ripple or whatever, and you just put the code in here, then like that's essentially what it is. It's just another like little language chunk with inline modules. I think it's interesting. I mean, at that point, could you just go like import blank as Svelte and then like have like a Svelte component in here? Ultimately, are you going to pretend that everything like it's not even pretend? Well, actually, it is pretend because ultimately JavaScript's on the outside. You could say that HTML is on the outside because JavaScript lives in a script tag, but unless the outer HTML is actually real HTML and not getting converted into JavaScript again, it's kind of like, because now we're living in weird inception mode where you have actual HTML that inserts a script tag that has JavaScript, which fakes HTML on the inside, which is fine. Like I accept that, but like the authoring experience makes you think that it's on the outside. So like this is just it's just smoke and mirrors. It's not, you know what I mean? Not Ripple. I just mean the general idea of like single file components being any closer to some underlying platform thing. It's a lie. Yeah, so this is about like familiar feeling, and for a lot of us who've been web dev like pre-React, pre that, we had our set zones, you know. The funny thing is if you view each thing as its own little app or its own little template, I think it just it's funny. I think it's actually the React re-render model, like the functional programming push, that actually is more abrasive, right? It's people couldn't put their finger on it, but it's that re-render over and over thing. Either it sits with you really nicely because you know you think in terms of like immediate mode, FP, you know, functional programming style like that, or it sits really weird with you because you're like, look, I have this DOM, I have this JS. I don't think anything about this stops you from saying I have this JS and I have this DOM, you know, or even, you know, Sol's JSX or whatever. I know this, you're like, oh, what's this if doing in here? But like, what were you going to do? Put it in a handlebars? Oh, suddenly it's way better, you know, you know, whether it's a map function, an if, a ternary, whatever the hell you want to do here, this if is still here. You know, like syntax is so superficial. Ripple pulls the pair that breaks them out. I'll be adding React RTS plugin to SolidUX soon. Bam. That's exciting. Yeah. Yeah. Big props to Dominic. You guys don't know, did a stream with him when they launched Svelte 5. Big part of moving Svelte to ruins. I know people have different feelings about that, but and the current async system as well. A lot of work on that. But like brilliant engineer, author of Inferno, author of Ripple. This guy's been contributing to the space for years. If you don't know who he is, you can follow him on the platforms. He's always true ADM. Dominic's the man. Yeah, I think this is the underlying takeaway on a lot of the stuff. Like the bundler is the like bundler and framework need to know about each other. We've tried to keep it separate. I think the first framework to really make that like present and obvious was probably Quick, but Marco was also right with Marco 6 right on that. Ripple, like we're getting to a point now where it isn't so much about, you know, like Next versus React and like, meta framework. It's actually about how well the bundler can integrate. That's the friction point. So like the funniest thing is the old three separate file thing hasn't existed for a while. Maybe I don't know how to get people back there, because even Svelte and Vue, like, just ignore the only reason the Chrome around it exists is to give you portability and capability. But if you just take what's in here, like I'm looking at Vue or I'm looking at Svelte or whatever, like more or less, I understand you're like, but it has a component or a function wrap around it. And I had to import stuff, but it's like hiding that doesn't mean that it doesn't happen. You know what I mean? Like, this just gives you more control. And it basically doesn't matter. Yes, it's noise, arguably, but this part in most frameworks is very, very similar, other than syntax. If this is show or if this is signal or whatever, like, but it's you know what I mean? Like, structurally, these things look the same. The biggest lie, or not lie, the biggest like this separation now is rerun versus not rerun. React and solid code can look identical but operate completely different. That's the biggest split now. We almost all write the same code in here now. Not everything is the same. React is, because that re-render model is different. I think that's the biggest difference. In my head, I was like, if this is the controversial part. In React, you can write stuff in a completely different way to leverage the re-render model. You don't have to use memo, for example. You can like write stuff inline and do all that. Dan Abramoff had this great example at bottom of one of my articles where he's doing this crazy for loop in the middle of this component and doing all this stuff. And he's like, how do I port this back to, solid, or, this a system that depends on declarative data only? And I was like, the funny thing is, I was like, well, what if instead of us focusing on that for a second, how about if I rewrite your React code the way I would write it in solid? Just get, and of course it was cleaner. Maybe people wouldn't have thought of that. He's like, but what happens if you change this? Now you have to edit it in two places. I'm like, yes, but it's still cleaner. And I think that's the key difference here. And controversial for me to say, but I think the ideal way you would write or structure a React component is the way you're basically forced to write it in solid, which is an interesting place to be, because for like AI and stuff, right? Because like React compiler kind of does the same thing and restructure stuff towards that thing. Eventually what you get to a point is this top section is declarative. You end up with const or variable equals some expression. If you unwrap the loops, you unwrap the conditionals, you do that, you end up with a series of variable declarations that are derived from other variable declarations. It's always cleaner than the mess, and it's always more specific. People don't think that way, so they can't write it as easily. But the compiler, when it hoists and do that, essentially is doing that. It's like, okay, take this calculation, assign it to a variable, then change this. Like, you end up with a series of these variable declarations, which is basically what you write when you write signals. So is it better to let the AI go off crazy and write a bunch of garbage? Or is it just be like, just write the freaking declarations? For people who aren't engineers, they prefer to have less control in order to be guided, more sensory detail. I think AI maybe will hopefully solve this. Re-render complexity, yeah, definitely. It feels like programming threads back and then worry about re-entering code. Yeah, I mean, this is why models evolve. Okay, so I went on a little bit of a tangent here. Glad I did, though, because Dominic here in the chat talking about this pull request. For anyone to check it out, pull request 866. It looks like this is going to be very interesting. Maybe have Dominic come back on stream, talk about Ripple, and talk about this sometime shortly in the future. Although I've got some leave coming up, which means I won't be streaming for a while. in a month or so. I've got a couple more streams before that, so I don't know if I'll catch them before then. We'll see how these things progress, but very, very, very interesting. I think it's a good place to cap up on the compiler conversation because I still got another example to do. But yes, very, very interesting stuff. Because the last example that I want to do is the reveal example. What is reveal? It's what we talked about last stream. It's the suspense list. Essentially, I made an example where you can toggle either together or collapsed, but essentially this example is reveal is a component that's like a context provider around suspense. What it does is it controls the visibility of all loading boundaries underneath it. And I actually have an example where it is nested. So you have a reveal and a reveal with one card or a couple cards outside of it. These async cards are just separate loading boundaries. You see them all over the place. And I have another example where you just have 1, 2, 3. Reveal has two options. It can be together or collapsed or neither. If it's neither, it loads things in visual order, 1, 2, 3, but shows all the fallbacks. If you say together, it loads them all together. If you say collapsed, it only shows the fallback of the current one, like next one it's working on. It doesn't like show all the fallbacks. Collapsed is the thing is if your loading boundaries have no fallbacks, you don't even need collapsed. You could just say reveal. But essentially, what we've done here is these async cards are very simplistic. They're just a loading boundary that just delays some value for the set of time that you set in as the prop. So if you look here, these ones just happen to load in order. They don't have to, but 500, 11, 1700, and then these ones 700, 900, 13, 15. But there's like some internal behavior. Now, who cares? Why do I want a reveal component? Together, there's a couple reasons for it. Together is interesting for that weather app, and maybe we can try that again later. I'm gonna actually switch to together so we can see this again. What together does here is you notice how we have 1, 2, 3. 1, 2, 3. Actually, I need to close this so we can see it better. The nested one's like messing with us a little bit, so it's like losing height. But basically these, remember they were like 500, 1100, 1700. It waits till 1700 to show them all. Nested is interesting because collapse doesn't do anything when together, it doesn't matter. But nested is interesting in that these can independently show first, I think. Doom. Yeah, that's actually a good question about how together should work with collapsed. Right now, this group finishes first and then this group finishes first, so you can kind of control. But it's like, so there is some isolation caused by together here. In order shows all the loading boundaries and just does them as they load in order. Obviously, their times put them in order. So like if they're out of order, what would happen is like, I mean, I can actually show that in a second, but if they're out of order, it can't show 2 before 1. So if 2 finished first, it would actually wait to show it until 1 showed up. Collapse is the most interesting version because you only see the next loading boundary. See how it goes like A and then loading B and then loading C. So it kind of goes A, B, C. And similar for the nested case, it loads this one, then this one, then this one, then this one. It actually kind of collapses along here. So that's the gist of what reveal does on the client side. It's it gets interesting. You might be like, well, why don't you just put these under a single loading boundary? I think the weather app is a good example of it. Like sometimes you might want to add more items to the list later, and you still want those to show up together as well. So like you don't want to and because of the way we never go back to loading, you actually want these to have separate loadable boundaries and not, impact the rest of this. So it's perfectly fine, to say I'm going to load all of these together. The reason is you might not want this nested case kind of like shows this off a bit, but if the loading placeholders were actually cards or something that was like preserve space, this prevents like the weird flicker in effect, right? Okay, yeah. So let's talk about it. Does it perform the rendering after the latest async card is rendered, or I'm particularly hoping it doesn't first render with the link? Okay, cool. So on the client, let me think about because we load in the background. So yes, actually yes, but the more important part was making this work on the server. I didn't want, just because inner 2 finished first, I didn't want to like wait flushing it. So the system, what makes this really cool is we can actually we don't hold the stream on stuff that isn't visible yet. So like if outer 2 finishes first for some reason, like 100 milliseconds, we can actually we can render it on the server, send it to the client, and have it just waiting there. It won't swap into place until the other ones come in, but we actually don't hold up the stream for this. This is important because there was some talk about batch queries, and don't get me wrong, batch queries make a lot of sense when you're hitting one database and you're like, I don't want to hit it 50 times. I want to hit it once with all the items I want. But so something like the weather app. But in a case like this, where the problem with batching or putting in the same async is now everything's beholden to. You can't render, you can't do anything until everything finishes. This mechanism lets you keep these things independent. As I said, not in all cases you want them to be independent, but it keeps it independent so that let's see if I can prove this. I haven't actually tested this. This might fall on my face while I'm talking, but if this last card is now 150, can I prove what I'm talking about? Or is this not working yet? First of all, we just saw it behave properly, right? We saw it like kind of come in and flish. Even though this one finished first, it didn't show till last. But the real question is here. No, what I'm saying is the server side they are erasing and the real thread is relevant only on the client. No. Yeah, so what the real question is, and this is the one that should be interesting, is if we refresh this, what I want to see is, let's hope this works. It looks like it worked. Loading. First of all, the mechanism I'm doing here, I'm loving. I know this won't translate off the web, but you know how I showed you before the placeholders worked by doing, let me see the first placeholder, by doing template and then showing, and then all the way down to the comment with the same ID. That's the fallback. So technically it's not in the template. I just use the template as an ID marker because it's invisible. So I can grab this and then walk instead of like searching the whole DOM to find the swappable parts. I can actually query selector this so that I can do this. But look at the ones with the suppressed fallback. The ones with the suppressed fallback, we still render the fallback right away, but we put it inside the template instead of between the template and this. That way, when it's told to reveal, this all happens before the JavaScript framework loads. So this reveal behavior happens even if the client framework hasn't loaded yet. It's in part of that inline script. It can just grab the fallback out of the template element and insert it in between the template element and the string here. So basically like clone it in. So we actually render the fallback immediately in the case that we detect there's a fallback. But where it gets interesting here, so that's what these are, is outer 2 is the first template. See? Outer 2 is the first thing they've streamed. It's not blocked. Yeah, yeah, exactly. So, and the client, because we can render in the background with Suspense too, should be decoupled too. I need to double check that, but generally speaking, yeah, I care about performance, guys. Of course, I'm gonna make things not blocking. Everything in Solid is blocks the least amount as possible, causes the least amount of waterfalls. That's by design. There's no reason not to be that way, right? But yeah, see, outer 2 streamed first. It couldn't replace itself first. It had to wait for the other ones to come, but it actually was the first one we sent across the wire. So this is great because it means that we're not like picture if like this was the first request was the slowest on the page, like outer 1 was the slowest on the page. Can you picture if you, or like the reason you want this is nested case is interesting, but forget about nested. This is eBay. Header. First, actually, let's look at ebay.com. Do you see something? Section, 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 footer. I know for a fact stuff like the homepage in order streams, it goes from top to bottom because they don't want layout shifts. I don't think they even show loading indicators. No, they don't. We saw it there. They literally just dun 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 dun. Has the least amount of layout shift, and it just kind of like flows in depending on the order. But they can't show this before they show this. They definitely do not want to do that because then you have things jumping around. It just usually the first stuff will come really fast, but it rapid fires down. So if this finishes before this, they'll show this right away. But if this finishes first, they'll wait for this to show before showing both of them. Now, that's why this is relevant here, because this ABC means that if A takes the longest, yes, we won't show it. We won't show B and C until A comes in, unfortunately. But I mean, it makes sense because you don't want it to jump around. But that doesn't stop us from sending B and C to the client, because we need. Picture if these were huge amounts of HTML being sent over the wire. Can you picture just waiting and being like, okay, wait, A, you're finally run. Now send the whole page. I mean, it's fine, but it's so much better if we can send B and C first. If we can leverage it for out of order. Don't get me wrong. In order streaming like eBay does actually buffer it the way I'm talking about. It doesn't actually send B and C first because there is a cost of taking the template and swapping it in. So you know, there is an argument there, but since we don't have real in-order streaming and this is only simulating it, blocking would just be the worst of both worlds. I guess we would literally, you know what I mean? We just would hold it and then not, you know, like we're already doing out of order streaming here. So why would you hold it? It only matters when you HTML is still collection. Yes. But that's what e-commerce cares about. Oh, I think, yes. That's what this nested example is showing. The thing is, I don't have it here. We could wire it up, but we could have typical collapsed and then have inner be together. So we go one, wait for both of these to show it, and that I think that's a more common one where you'd go typical collapsed or like typical reveal on the outside, and then put together on the inside. There is a question, I suppose, of what if you wanted to opt out of the reveal pattern somewhere and just have stuff load in randomly. That's actually a good question. I actually, huh. Yeah, that's an interesting one. I actually don't have an option to do that right now. Once you go to reveal, you're sort of coordinating. Your options are in order or together. But that's something I should consider. Yeah. Yeah. Exactly. So, Anyway, but yeah, that's interesting. What if you wanted to just, huh? That actually impacts the API design. I don't know why I didn't think of this. Because you actually need if you wanted to opt out, you'd have to be like you need a nested reveal that was like not together, not collapsed, like literally like YOLO reveal. You know, like you basically need an opt out version here. That is a gap. Okay, that's interesting. Yeah, that is actually interesting. Nested loading will get you out of it too, but that's not really what you're trying to do, I think. I struggle to think we're big nested worse than the alternative. Yeah, I mean, the only problem is so so what you're saying is that maybe we shouldn't stream early, like just hold two. I was thinking the independence was valuable, but we can't hydrate it early. Yeah, that's an interesting question. Well, actually, I mean, big HTML, not a big deal, but less of it still probably good. Like if the time difference is enough, like if I can send two to the server, like, and the next one's like half a second later, it's better to send it early, right? It might not make a huge difference, but it's probably still better to send it early. Probably not. No, overrides, granular overrides are not great for boundary type scenarios. I think like we need a clear boundary the same way like loading is a clear boundary. Reveal is a clear boundary. Yeah. Eh, well, I mean that's the question. I mean it's just send sooner than later seems like a good thing. You're right in that like it isn't that you're like the compression could be better, which I agree. But like at a certain point, like obviously this is silly because I'm like literally looking at like a single div or whatever, but like at a certain point just it, yeah, that's an interesting question. Yeah, I mean that's the question. I you're like trading one side for the other side. You're like I can make the HTML smaller because I can like compress it better, or I can just send it earlier, and then I'm sending less later. Yeah, this is it's interesting. This might not be. We'd have to measure it. I was mostly focusing on mechanically not blocking. I wasn't worried too much about like what other like the last class optimization can come in. Use an idle network exactly. Like I think it's still probably a win on average enough that I'd want to keep this behavior, but it is a question. Like it's small perhaps, but yeah, I mean this is the real reveal component. it's definitely interesting. On the client, we because of the way suspense works and loading works, like we're gonna still walk into it and render it. We just won't show the fallback or won't like reveal this, show the thing. So from that perspective, it doesn't like there's no consideration. It's just it's all parallelized. So yeah, I think you can like tell that like I think it's going to be hard to benchmark because I think it's going to depend on the situation. But yes, I agree with you that the compression like can make a probably like the compression can make a big difference. It depends on the size of the chunk. It depends on the delay difference. But it like I would err generally on earlier is better. Like not always, but if I was, but if the bottleneck is because the sum chunk is very big, you'll still compress this chunk and get the benefits of compression. Yeah. I hate options. I if we have to, I don't trust people to we'll cross that bridge when we get there. Like I actually want to talk about something kind of related. We made a breaking change last minute. I talked to ecosystem and everything, and everyone seemed to be on board. But I got rid of the initial value on signals, and this is like a very. It's kind of actually where I want to go next, anyways. I think unless anyone has anything else on here, but I want to talk about it, the cost of providing options. Options, like I put it this way, I deleted 1,000 lines of code just by removing the initial value option, which seems insane. But I think this is a case where like the optimal solution, there's no optimal solution covering all this cases, but the difference between the optimal and the unoptimal solution in like is not huge. Like I don't I it'd be weird, it'd be interesting to see if there's like like you could probably create a scenario under certain conditions that it would be, but it's kind of like I think this is a scenario where it's probably beneficial, and at worst case where it's not beneficial, it doesn't matter. Like basically, we can always fall back to compression, giving us a reasonable size, but we can't always fall back to the knowledge of uh, being able to flush stuff early. Indeed, that we stream SEC with broadly, we just send it down when it should be displayed. The longer the stream, the more benefits we get. But the stream, like, we're, I don't know enough if SSE is different, but this is all over the same initial stream, right? Like on HTML, I thought the chunk size is what mattered, not the fact that you're streaming. Like essentially, like we we don't if we send the larger the chunk, the more each chunk can benefit. But the fact that the stream's been open longer doesn't make a difference. So maybe SSE is a little bit different. But my understanding is like the reason why we're having this conversation is because like this is all the same stream. It's just that do we send stuff early so that it's there so we don't have to send it over the wire later, or do we send a bigger chunk later so that we can compress it better because we don't benefit from the compression if we send more chunks. At least that's the way I understood it. Right. But sorry, unless I reread this. Let's start with stream as. You just send it down when it should be displayed. The longer the stream, yeah, I think you mean the larger the chunk. Yeah. I don't think the latency was. I mean, but you get what I'm saying, right? Like, if these are separated by 500 milliseconds, it getting there sooner is bigger than any difference the compression is going to make on time. It's only the fact that we like what we're actually weighing is like maybe if we more like combination of the chunks, like we don't have actual in order streaming, like the JS doing the swapping and all that was where like the overhead differences. Like you could probably optimize a case where JS is not doing the swaps. Right. That exactly what you're saying. You could kind of force it into in order, which is I don't think really an option for us because we're innately out of order. Like we're still swapping it into. I guess we could do less swaps, but we're still going to be swapping it into maybe multiple locations. Actually, yeah, because the loading boundaries can be separated by real elements. Like even if we wait, like these two still get swapped in separately because the div around this and the div around this might already exist. So they're actually getting inserted into two separate places. We're not doing actual in order. If we were doing actual in order, I think that would be more of a point. But this is actually using out of order and simulating. This is like simulating in order in an out of order system, which means that the overhead of doing the swapping is still the same. So that's what that was something that I realized was a design miss as I was talking about it. I don't think the individual loading boundaries should be, but I think that there should be a nesting of reveals that lets a nested reveal opt out of the parent. Like basically say, for my children, I don't care about the order. So yeah, it's hard to say for every scenario, but generally speaking, since we don't actually offer in order streaming, I don't think the combining the chunks is as beneficial for us. Yeah, sorry, I this got really derailed. Sorry. Uh, yeah, I want to switch gears here. I want to talk about. I want to go to GitHub.com. And I want to go to the Solid.js repo. Yeah. I'm going to go to next. What was new reactivity? That one feels like it was a long time ago. It's like not new at all. Okay. And I want to go to documentation. And I want to go to Solid 2.0. And I want to talk about a few of the new things in here. That's where I want to go next. Yes. I can probably shut off this demo. I think this is served its purpose. Is reveal. Yeah, sorry, I'm gonna put this back to this. Because we actually made some good changes here that might be worth committing for the update, like simplifying that code and removing the optional types. Yeah, let's do this. Let's just commit this. Demo cleanup. Or actually, example cleanup. Let's go on. See if I missed anything else. No, I think that's good. Oh, damn it. Whatever. it says ESSR example cleanup, doesn't matter. That's why you get AI to write your commits, fix you from typos. Okay, let's switch over because I want to talk a bit about what's left to do and where things are at, because I have actually updated the RFC documents. I don't want to go through them all in detail. Again, we did that on a previous stream, but these are much more complete now than they were before and serving as kind of a basis for docs. And for this, I am going to switch my views so that I'm not blocking the text. Hey, thanks for dropping in and saying hi. So, okay, talking about the quick checklist, imports, 1x imports moved, batching reads, right? Setters don't immediately change reads, return values become visible after microtask flushes, effects, create effective split. We talked about this. Cleanup is to return a cleanup function, lifecycle, on map replace unsettled, can return a cleanup, async loading is pending, refresh indicators, index gone, use for keyed false, for uses accessors, stores draft for setters, store path exists as an opt-in helper, plain value snapshot replaces unwrap when you need reactive, use removed for ref, merge helpers, merge split omit. Okay. Showing the import differences. This behavior that scares the hell out of people, understandably. I think. Okay, yeah. This is an interesting one. The initial value argument is gone, which is kind of a recent thing. We did it. You can always just like set prev equals 0. We did it so that we could collapse the options a bit. Even though we still pass the previous through, you can do something like prev equals 0 or whatever like this, generally speaking. I don't think many people use the previous argument. And the confusion was that the previous argument was never visible or read somewhere. People were trying to use it like latest, like they were trying to be like, get, like when asyncs in flight, I set initial value. Why can't I look at the initial value instead of looking at the in-flight async? And it's like, the idea of something being uninitialized is super, super important in the way that the system works. You can't have it like not be uninitialized. Having an initial resolve value is important. So initial value was never actually a real initial value. We still have it for stores because stores need to make a proxy because you mutate them like they're an actual like proxy. But for memo signals, etc., there's no initial value. Yeah, talk about cleanup. I think these examples are at least getting a little bit better. This doesn't show the cleanup logic in here. Talk about warnings. Yeah, this throws an error now. If you try and write to a signal inside a computation, it actually throws, not just warns. Yeah, people didn't even know it had a default argument. I used it in the renderer, so it's fine. This is why I think it's okay. The on I'm trying to think if there is actually lots of renaming. I'll get down to it. Some of them, the renaming also usually contained behavior changes too. So let me keep on going here. Actually, you know what? I'm going to just copy this document so people can follow along if they're curious. But yeah, this write now actually throws. Unless we have something, there's an option you can do to get out of it, but generally speaking, you shouldn't do that. Obviously, suspense loaded errored. The basic pattern replace create resource with async create memo or create store for collections and wrap consumers in loading. huge difference. Yeah, this whole section explaining how to replace create resource. The funny thing is what we've replaced it with is so much better. I'm actually really excited about this. We just made refs way more powerful. To be fair, it's different. We don't throw when you call setter in the back half. You can't make that illegal. We throw when you call the setter in the front half. The biggest, you can look at the change log. AI is pretty good at writing change logs. So where was I? This is showing the difference between like showing a pending indicator or do loading. Latest. Refresh pattern using refresh. Actions plus optimistic helpers. These go kind of hand in hand. You don't need to, but we kept store path, which is if you want to use the path syntax with a little bit of difference. Unwrap to snapshot. It does have a different meaning. It's because the underlying part of the store is immutable, so we can't pull out the original object anymore. Snapshot will apply the current changes on top of your object and give you a new one. Merge prop, split props, merge and omit, which is nice and clean. Function forms for create signal and create store. This is wrong. Oh man, you always miss these things. Like, why is items items is not a function? Just items.length. Index is gone. For children use accessors. Yeah, index just becomes that. Which is nice because most people aren't going to bother using index. Column. Same idea. Yeah, I can't believe I missed that. The way to opt out of reveal behavior. It makes sense to make it a reveal with like a different option. The problem is this is going to cause another slight breaking API change. I was using booleans because they're clean and because they're mutually exclusive. Now we're going to have three. We're going to have like reveal together, reveal collapsed, and reveal natural. And at which point you're like, shouldn't it just be reveal mode equals choose string? Do you know what I mean? Instead of like having a separate booleans you have to remember the name of, you could just go reveal mode. I was just, when there's only two, we could kind of get away with not having a mode, and I kind of like that. But now it's, I like the way it read, so you could be like, it could be like reveal natural. I still might do that. Muted false, yeah. Yeah. What's cool with refs is we accept array refs now, so you can apply multiple refs. They get a bit of like the class list treatment where we can combine like spread refs into refs through component trees if you want. Like, so then calling the only difference between the key part here is that it becomes more common for a directive to have like a the idea is you return a ref function, right? Is the key to this, where a directive is now like this. Originally, what I like about this pattern is if you had some code in your component, it would look like this, and then you would just pass this into the ref naturally. Now we've made it so that essentially you can just extract that code into the same kind of separation. I know it's weird to have like L here and then why you're writing it to here. The reason is in this scope here, this is like an effect scope. It's like a place where it's safe to write. You could write a signal here. You can go set signal. This could be set signal in fact. So it's not considered an impure write. Whereas this scope is setup. It's like the same as being top level in a component. So this is its own create primitive descriptions here, avoid imperative DOM mutation at this level. In fact, it'll error at you if you, not DOM mutation, but if you try and like call set signal in here, it will error at you. Apply phase, unowned. DOM writes happen here. New primitives should be created in this callback. Yeah. So like back to your question, it works the exact same way. You can pretend this is the component body, and then this is what you pass to the ref. We did a little bit of trickery with the compiler, like not much, so that like this runs, for native elements it was easy. For components a little bit different because of the way they use getters, but generally speaking, this runs immediately, the setup, like wherever the call site is, and then when the ref function is called, that's where it actually becomes live. So you can view the setup basically as like an untracked top level thing. It's like basically this is just a micro component. It's, if that makes any sense, which as I said, it's very cool because if you originally had this logic in a component, you would just extract the top part into the function and then pass the result of that function into the ref. Does that make sense? Hopefully that makes sense. Yeah. The reason you never want to use Booleans is because of the combinatorics of them. There is an interesting argument though if they're actually mutually exclusive. See, and the funny thing is it's a little bit different with a DOM element, because it's the inclusion. Like you can just go like reveal natural is like the syntax is a lot cleaner than like mode equals 1 2 3. The interesting thing is I wonder if from a types perspective we could actually make them all mutually exclusive. That would be interesting actually. I feel like I'm not telling you to use a bunch of Boolean combinations in your logic. I'm just saying that simply from like an API standpoint, it's actually kind of clean with Boolean expressions. Timing. I mean the generally speaking, your ref is going to, okay, well, there's two different ways, right? This is like the basic example where generally speaking, effects get scheduled after render. So if this is inserted, you know that the effect will run after, like in the same way in your component body. Like I use this pattern in components a bunch where I just go like past like the magic ref thing that everyone, a number of people dislike, is I just pass L to ref and then go like on mount or create effect. It doesn't matter. These happen afterwards. If you want to be more explicit here, it's the reason it's split. Turn L into a signal itself. So then you have element signal, and then just go set element signal here, and then the effect can listen to it. It just, the reason I'm talking about relying on timing here is like in React, they don't trigger refs by signals. They're not tied to state. So for a lot of things, you don't actually need the elements to be signals. They're not coming in and out. Now, I guess if I was making a generic directive that people could use however the hell they wanted to, then there's an argument making a signal because you have no clue what they're going to do with it. Are they just going to call it in the middle of their function somewhere and then pass the ref function in like later or something? Like if people just do this and inline it all the time, then the timing should be right. It's just that like who knows? What if they call tooltip up here and then pass the ref function in? Then your timing is going to get weird because maybe this runs and the L isn't there yet. Like there's this if L check, but the funny thing is you don't even like for the basic case you don't even need it, right? It, the the element will always be there at the point that this runs. Hope that makes sense. Or L changed. Again, similar thing. Make it a signal if you needed to. Most refs elements don't change. If you need it to change, then make it a signal, yeah. So effect function does an executions after, so L is set by the time the effect, yes. Yeah, sorry. We've always been like that, so I didn't really highlight it too much. And the split helps too on it too. Like the effect function happens, the effects happen after rendering, like from the scheduling time point. Yeah. Class to class list, we already saw this today. It was kind of cool, being able to like support because these compose. You can like refs. One the reason I love these patterns that support the arrays is you can always get like props.ref or props. You just spread them in, and these attributes are designed already to flat map. There might be a performance hit if you're like relying a ton on flat map. We're going to see as we convert Cobalt, but generally speaking, this allows composition in a way like you don't have to worry. Oh, combine like they're already trying to combine class list and class and stuff. This just takes care of it. This will definitely be better than what we're already doing. You know what I mean? Yeah. This is an interesting question. We talked about this last stream a bit with Brenly because there's a few things like initial value which blend very well to code mods. Stuff like this class list without spreads, super easy to code mods. Stuff like this tooltip, maybe not as easy. Renames, somewhat easy. It's tricky because AI can do this stuff like very easily. We've already seen that. We've been able to migrate stuff. Like AI has no problem taking this kind of guidance and getting us to stuff. AI is more expensive than code mods for sure. But yeah, like this one, easy code mod theme provider to theme. So this is something that's on the list of research. Challenge for me is I am not familiar with code mods at all. There have been people who started to look research very early on, but I don't know where they landed or what they care. My biggest concern is like, do we hold up the 2.0 release waiting on these code mods to get made? I'm not sure. I am maybe leaning on AI too hard a little bit here, but AI has been very successful. So these are new additions. Let's look here. It's a cool list. Reveal. So yeah, it is replacing it. So, but it's not a pure rename. Repeat is new. Action is new. Create optimistic and optimistic store new. Create projection is new. Is pending. Is refreshing. Latest. Refresh. Resolve. Loading. Again, loading is kind of the loading on prop they're talking about they didn't actually show it because it's not migrated, and I'll show loading on in a minute. Deep store, it's new. Reconcile, diffing function. That's not new. That's a mistake on their part. Function form, it's new. Effect bundle, yeah, this is new. Create effect can actually manage its own errors. Create memo, lazy options, unobserved callback, fires and signal lose subscriber source cleanup. Detailed removal guide, batch to flush. So yeah, this just becomes this. If you need a synchronous, apply now, apply flush. Create computer, create memo, create effect to derive signal. Create computer is used for 3 distinct patterns. The replacement depends on which one. Set doubled, make it derived. Side effect on change, use split create effect. This is not exactly equivalent, but it's better. Derived with write back, i.e. using it to synchronize props, use this form. On helper, is solid one abandoned? I mean, it depends on what you mean by abandoned. It's superseded when people are still working on. There's a 110 branch. You know how we're on 1.9. There's probably at least one more minor coming out, but it's mostly in like stability mode bug fixes. There are certain bug fixes that like we would never fix just because they would structure or break stuff. So I have been a little aggressively closing bugs that I know we won't fix in 1.0, but are addressed in 2.0. In fact, the solid repo has 60 open issues now. I was able to close 40 issues from 2.0, and I think there's more. I there's just what happened with. I was always on top of issues in solid. For the longest time I kept the solid repo in under 40 open issues, but over time I couldn't actually address these issues. It just wasn't possible on solid bones. The part of what makes me so excited about solid 2.0 is I can finally close the majority of the open issues. I think we've kind of fixed everything. So there's obviously still like a few things, and there's enhancements and stuff like people want that, not clear if we can go that direction and whatnot. But like the number of like things that I consider buggy behavior that exist after 2.0 are basically gone. I'll get to the create effect thing. I'm not sure what you're talking about yet, but it's so that we can run the front half before the back half. We can collect all the async dependencies for every single thing in the boundary before we run any side effects. And also because the async is interruptible, like you can like, if you try to put it together, you could like Zalgo it, right? If you were like console log A, like effect A, effect B, effect C, all inside a single create effect body, you have no idea what order those will run. It'll depend on when A, B, C resolve. Whereas if you hoist out into the first function ABC, then you know that they can all resolve before you run any side effects. So it's both locally to make sure that the effect can run to completion, and it's also so that you can make sure that you are aware of all the async before any effect runs. Datastar just got. Are you talking about two-way binding like in Svelte? Or Vue? Whatever. So let me continue here because I don't. Okay, so you still do coding and whatnot and return what the side effect, I wonder. Complex effects. Yeah, we've done trust me, this is one of the most controversial things that like everyone comes in with their like super complicated example of what they're doing with effects in solid, and then we like there's a few enough common patterns that maybe it's worth writing an article to show like people how to deconstruct it. Usually the answer is break it apart. There's only been one case that I'm just like, man, that is kind of annoying. And it's not about conditionals, it's about deeply nested data structures and expecting those to work like stores. I think that's where it gets trickier to be as granular, where people were basically YOLOing it and just were like, I'm gonna write a whole bunch of conditional logic around my store that like I based on the path it will hit some deeply nested properties and not other deeply nested properties. Like it that is hard. Conditionals and breaking that apart logically not so hard, but deeply nested property access and stores is hard. We'll talk about stores in a minute. Like you showed the bug that could hurt having. Oh, you're talking about split effects. Yeah, yeah. I mean, this could just be straight input here, but yeah, I mean, it's what I just explained in terms of separating the tracking from the side effects, discovering all the async ahead of time. Um, Oh, don't get me wrong. Why the split effect's annoying for my? Don't get me like. This is one of the things. And I did a dedicated stream on this. The physics. It's not as many people checked it out, but the physics of Solid 2.0 is an amazing stream in terms of understanding these aspects specifically because it's like I really get into the basic thing is this is reality. Pretending it's not reality isn't going to get us anywhere. So we just got to face it. Um, that's kind of the thing on it. Where are we on helper? This is just showing that into I thought I hand edited this just to be count because there's no see how they short formed on count here. This could just be count here too. It's like they unedited my edits like when they reprinted it. Doesn't matter. But like you know what I mean. Like there's no reason this can't take the same form of just being count value preview. Oh yeah, we supported this multi-depth pattern. I hated doing this. It made the on logic like way more complicated because it had to iterate through. I was like, you could just support this and be done with it, which is what we do. This is like someone was arguing that they still wanted on after 2.0, or that we should make effects like also work like this. And I was just like, man, that's terrible. I know Vue probably does it, but like Vue doesn't. Vue for like this nicely, so you can like write this slightly different. Vue will add like code size and logic branching. I just don't think it's worth it. It's like, is it worth adding 6 lines of code for that? I don't think so. That everyone has to pay for. On also the defer option, we still have the defer option. Okay, so I updated this one. I just didn't update that one. I was trying to show that like the code is almost identical. Anyway, on error catcher, error defector, error option, blah blah blah. These didn't make sense anymore, unfortunately, because like they basically just became boundaries themselves. So I like this example where they're showing catch error around an effect, and the fact that you can now with create effect, the second argument doesn't have to only just be the effect, which is the function. You can also have a separate error handler if you want to handle these errors. If your effect errors, that's still going to go to error boundary. But if you have like the front half, if the error comes from the reactivity, you have the success case and the error case. Um, like if there's something async that fails, you can kind of handle this without like unhinging like without like going to the error boundary. You know, like if you're doing just if this is just doing some logging or something and you're not rendering it, why would you like I don't know what you're doing with your effects, but if you're not rendering, there's no point having it like crash that whole part of your UI probably. You should just have some special handling. Um I'm new. Do you have a planned session for the advanced kernels already done? I have an old front ends master's course. We could look at doing that again. It's tricky for me. I'm not the best person at teaching beginners. I'm good at teaching fundamentals, but there's a difference between fundamentals and beginner. Um, sometimes, it's like I compare. I think about I used to teach guitar lessons, right? And when you teach a beginner guitar, you usually show them a little piece of something you think they can play from a song they recognize, so they can play and be like, "Yeah, I'm jamming it." But if you want to learn guitar the best, you learn your scales. You learn music theory, and it's a different kind of challenge. I'm at a point where I'm better at teaching theory, I think, than I am at teaching beginners. I do have an example of this. Thank you to Dev Egerol. Who's right here. um, Collections. This is one of my like standard things that we do, which is called error counter. This is why this decision came apart. He made this demo and we're like, this is really weird. Oh, did I get rid of it in this version? That's hilarious. It's not there. Oh, why is it not there? It was like there the whole time and then I removed it. I mean, we can add it back. Hmm. I can't remember what he actually originally wrote, but it's like it was something like this. They don't need to log. The first error is making sure that you import all the primitives you use in your example. All right. All right, sweet. So there's a reason for this design, right? Because you hear success, error, and then when I click on it at a certain point, let's get rid of some of this stuff. It's going to error here. Stacklets always add so much garbage. It's going to error at some point. No, just not erroring today. Oh, there it errored. And then we say, oh no, status error, blah, 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 caused by random async error at get phrase here. Now, why did I do it this way? This effect is reading from upper phrase, which is async, that is above the loading boundary. There might be an upper level loading boundary, but it's not there. Basically, we were having this kind of interesting conversation here because we're like, look, you might put side effects that have nothing to do with rendering near where your data is. So wrapping the whole thing in a loading boundary is the wrong thing because essentially the affordance that you're trying to accomplish here is like it should be based on the UI shape. It shouldn't be based on your data shape, right? So the problem was if we weren't going to say, hey, this effect is listening here. Let's look up and trigger the loading boundary above it. It's weird to do the same thing for async errors. Like if this errors, why would you, well, actually, let's make it a little bit heavier. Let's make it cancel error. Why would you trigger an error boundary above this, right? Like, don't get me wrong, if this had bad code in it, like this like crashes in the middle of you showing the error or doing the side effect, yeah, you should bail out. We have no recourse. But if you just fetch some data and that data failed to load, it the fact that this errors would lose like has nothing to do with the UI. Yes, you want to show this error boundary here in the UI, like, hey, this is errored out. But you, if it was here that was getting triggered, you'd unmount the whole app. So like the kind of thing that me and Dev kind of came to the conclusion is that render effects, part of rendering, part of the view, part of things that actually care about the structure should play into the boundaries, but normal effects aren't boundary conditions. They'll be blocked by boundaries. So if they're in a boundary and the boundary like hasn't mounted yet or whatever, they're not going to run. But they're not going to contribute to the boundary. They're not going to be like, oh, because you read this thing here, now this section can't load. They're not a render concern. They are essentially a side effect. So we will, like, if this effect is inside a loading boundary or it's part of the UI, we're not going to run it until it's mounted. But if you have it here and this is mounted and this is doing its thing, it's going to run and it's not going to trigger error or loading boundaries based on the reactivity propagation. It'll trigger errors if it like literally errors out itself, or like, so if you throw an error here or throw an error here, then it'll trigger up because we have no recourse in terms of catching it. But you can basically manage the errors yourself. So you can just go like, hey, do whatever you need to do here. More music theory stuff. Pretty simple rules, especially for us devs. I would say just being able to recall it, you have to know how to apply it effectively. I mean, playing guitar, there's muscle memory, which is a whole other thing that you learn from repetition. But generally speaking, I think that's why I don't know if I'm the best teacher for beginners. Know the problem with try catches? I think you're gonna get to it. I actually made a special try catch for this. It's because we throw async. So I could make a special try catch because you'd want a try catch that ignored async throwing, so like a not ready error. But then you're gonna have to wrap this in a special try catch anyways. And I was just like, why do I have this primitive? With the addition of async, is there a need for debouncing cancellation buffers? Will we eventually bounce everything the same way? No. That's the beautiful thing about this. Yes, you may reinvent it. The same reason why people use RxJS with signals. But I will not reinvent it because I don't need to. I only care about the point at which it enters. If you need to debounce stuff, then you debounce it coming into the system. My only responsibility is showing stuff synchronously. If I can't, I have a pending state or transitional thing where I hold stuff. I don't really care about how you schedule async. The whole key to this system, like this get phrase returns a promise, so this is async. But if you look at this code, other than like the stuff we made for affordances here around loading or whatever, you're not like, where's the async? It just happens that the source here of this data is async that takes 800 milliseconds to resolve. The thing is, the second, this is part of the design, and I talked about this in a previous stream. The second we try and absorb the promises from you right away. This is the difference between, like, say, a lot of frameworks, React, Svelte, or whatever, is like they absorb it where you await or where you use. We try and absorb it way earlier, and because we do that, it's basically like we just kind of push the async to the edges. Like if you want to debounce it, debounce your promise or whatever you're doing at the edge, they bring it in. It's not, it's use an event library that like RxJS and plug it in. It's not really our responsibility. As you could bounce an async create memo and fetch the data with a downstream. Yeah, sure. I mean, go for it. Like, I think you get what I'm getting at though. I don't like to me that's still the edge of the system, because like this can be an async function obviously, and then you're going to do your logic here, but then the rest of the system doesn't care. So like, will you still need debouncing logic? Probably, and there's solid primitives for that or whatever, and you can use those. It's just like, it's just not, it's, we've managed to keep it outside of what the framework has to worry about. Yes. Go like, because we're all about keeping a consistent graph. I mean, the challenge is when you're not using such a strictly derived system, like when you're not doing this, like what I'm showing here, like, and you're trying to like bring the debounce stuff, like you're breaking the graph at that point when you start doing writes, like when it's not purely derived like I'm doing here, like when you're like, I have a computation that's, or when you're writing to setters multiple times, you're kind of breaking the graph's traceability, which is perfectly fine because your source outside is coming from the outside. It can input whenever it wants, the same way that I can click this button as many times as I want. But like what I'm getting at is we don't care about connecting the dots there because it's from outside the system. It's a user's action or it's your event stream. Once it's in the system, we very much want to connect the dots. And I'm actually going to talk about that a bit more in a minute when I get into the next document, the last new document. But yeah, let's continue on here a bit. Produce is not removed. It's the default, just showing that now stores are mutable. You can use the store path. Sorry, create mutable, modify if you store draft. This is a controversial one for people. Create mutable gave you a proxy you could write to directly. In 2.0, create store draft setters give you the same error now, so keeping writes explicit. You know, kind of like actions and MobX. This is the suggested migration. I doubt anyone who uses create mutable will like this suggestion. But Solid's core is not shipping with create mutable. I think I've made that very clear. I know it's controversial, but with our deferred flushing, there's no nice way to basically picture if you push A, B, C in a row. In here, you can say in this scope, we are dealing with the latest value, and we can see that A has been pushed before, and we add B after, and we add C after it. Out here, not in that scope, because stuff's in the past, pushing A and pushing B would be pushing them onto the same index, because the length wouldn't have updated. Not having a wrapper, you have two choices. Stay in the past, which is what we're now saying is the default behavior, which completely breaks sequential updates, right? So that's why the wrapper is important. Or always be in the future, which doesn't work with async. It's fundamentally broken. So someone in third-party land will make a create mutable. They'll do it very easily. They'll use create store. They'll wrap a proxy around it so that every get grabs latest value. So each individual get will grab the latest value, and each individual write will call a set call independently, which is fine. So each write call set, and then they'll do something like they'll probably like if there is a listener, don't do the latest value. So like if you're in a reactive scope, so basically, yeah, grab the latest value unless you're in a reactive scope. That's probably how they would do it, because in a reactive scope you don't want to be tearing, but everywhere outside of a reactive scope you would be tearing. You could kind of almost get to something that's like create mutable. It'll be slightly less efficient. It risks tearing. It will definitely be inconsistent from the like external system standpoint. It's why we didn't go that way. But someone could approximate this if they want to. There's just no way that I could say like, yes, this is a good pattern when create mutable was already like suspect as never being a good pattern. I've said this like a million times over the years. I've just kind of gone now to a place where it's not just that create mutable isn't a good pattern. It's like it also fits, like it's not just me saying it from an opinion standpoint. It actually, structurally speaking, from an actual like structured scientific standpoint, create mutable is a bad pattern. So we have the primitives to rebuild it. It's just not. I'm hoping you do this instead. If you use MobX, you wrap your rights in an action anyways, so it's not too much of a change. People like, it's a good pattern to control rights this way, but there's always going to be that guy. So I'm sure someone's going to make a create mutable. I'm moving to Solid 1.0. What? Didn't you use in Solid Router? No, I've never used create mutable. Never. I've never found there's not a. We have a lazy memo thing in Solid Router. Create mutable. I don't. I mean, you make me want to look now, but I find it very hard to believe that I would ever have found a use for create mutable ever. Router. The only thing I can think of is it in utils? Not in routers. It's top level. It's how'd they come up with like a really clever, not on the matcher, create memo object? Yeah, this is not using create mutable. This was like a lazy prop derived prop thing. This was like my approximation of a projection before a projection. I still like this because it's more streamlined than using a projection in this case, but this was like me trying to create a projection, like a lazy projection. I wonder if I could just swap it with a projection now. Doesn't matter. So yes, no, I create mutable is garbage. Always has been. It's just the wrong thing. Always. To this day on my company, I have to explain to people why they should dereference like to take advantage of MobX. Oh yeah. Like the reads, right? I mean, it's different when you build your whole system around reactive reads than you know to do it. And okay, there is one use case, but it's like a terrible one, and it ties into the split effect problem. It's when you have imperative APIs, and you just like, look, I don't care what it is, just make this reactive. And you're like, I'm going to feed this object into some like third-party library that has no idea about reactivity, and just let it go ham with it. And, it can modify it. We can listen to stuff and hope it updates. And yeah, like that's scary as hell to me. It's not like the setter pattern doesn't let people, you can wrap, like if that third-party library does mutation, you can go like call that third-party library function inside a setter. Still works, like create mutable. It's just like, I feel like at least then you're calling it out. You're like, look, I'm calling set. I'm going to update the store in here, because otherwise you can literally update something anywhere. Like it's just like, ooh, YOLO. Yeah, it's all good, Dev. But But yeah, no. I built it because there is like that edge use case. I'm hoping if we look back to the actual docs here that this can still work for people. I know, okay, there's people who use and depend on Create Mutable and Solid 1.0, large projects like to have that ancestry, like that were like, I was MobX with React, then I switched to Solid using Create Mutable from MobX and React. And giant, huge projects, hundreds of pages of code. And this made it, because MobX already had the grind thing, they just switched the stores with Create Mutable. They kept the code almost the same, and they're able to do a huge migration, and they saw huge performance benefits. Some of the biggest migrations I've seen in history has been because of Create Mutable, especially from people previously in MobX. They just, their apps got so much better without them having to change a ton of logic because they're already kind of set up properly with MobX. So those people, I'm not going to try and make you feel bad about using Create Mutable. I think that being able to recreate this in user space is still really important. I think that if we can maybe get it solid primitives, I feels almost too prescriptive. But I need to get this the hell out of core because it's poison. I'm just saying that like if it lets you migrate to solid 2.0, then I am like, go for it. You know, it's just I can't responsibly recommend anyone to use this from like a greenfield perspective. Yeah, I mean, go for it. The funny thing is that the pat we were talking about this earlier in a context demo where I was just showing it's just like we don't actually need selectors because the reactivity is actually fine grained. So like all you do is you take the setter and instead of returning set state from a store, you just wrap specific setters. It's every to-do MVC example I've ever made generally follows this pattern, but we can stack blitz it right now. And I can do it again. I'm actually going to leave the effect back in here. Whatever. Let's pick an example. Solid 2 experiments. What do we want? Doesn't even matter which to-dos. Simple to-dos. The thing is, see, to-dos store, create to-dos adds 3 actions back. And then how did I implement this crazy thing? I just used create store and then wrote 3 actions and then returned the store and then returned the 3 actions. These actions just cover set to-dos. So like, this is why people don't use stuff like Zustand. Like it's why you don't need state libraries when you can literally just like, this might be a fun exercise for someone else in a stream. Like recreate every React state library just using Solid's built-in primitives, because it'd be dirt simple. This is also why it was kind of interesting when Solid got popular. It was hard to get some win in on the state library because people are excited like XState and XState would actually require different things. XState is actually substantial enough. The state machine itself and the management of that, I think is sufficient. I think stuff like RxJS is a different realm, but like most of like the Jotais and that, I forget who I was talking to. They were trying to make versions for Solid, and then they just gave up because it was kind of like why? Do you know what I mean? Like they're like, okay, here's Jotai Solid, and then it was like, I mean, it's good for a migration tool, but it was kind of like we kind of displaced all the state libraries. Yeah, Suspense isn't it got renamed is a better way to put it, but it got renamed to loading, and because it's not quite the same as before. It only triggers initially unless you use the on prop, which I can show a bit more detail in a minute. But we just, you can view it 99% as a rename. When I say the suspense is over, I just mean that we fundamentally changed how suspense works. Yeah, I don't know. I think every example I've covered on this stream already talks about suspense enough that I probably, or where was I? Yeah. It's not that it's deprecated. We just have transitions are gone explicitly. Suspense we made into a simpler loading component. I haven't tried it with Solid 2.0 yet because we'll talk about it maybe briefly, but they just got it working. TanStack router has amazing TypeScript support, which is really good. Solid router does not have as deep TypeScript support. Mechanically, I'm trying to find the best, simplest way to do routing. So, that's the goal there, while mechanically doing what it needs to. But TypeScript is something we're definitely lagging behind compared to the TanStack router. Yeah, I mean, it's the display stable. I mean, it's been the case since day one, right? Um, it state isn't a problem for us. And to be fair, it's a good thing to control. React's going to want to control more state. You watch. That's the only way you really get a wrangle on async. This one's can go either way. I've cut this because I was hoping to push this a little out. The only reason that the from and an observable helpers were ever core, not solid primitives, because solid primitives didn't exist at the time. I'm just trying to keep things lean. You don't really need it. Like this is unless your observable has an async iterator protocol built into it, and a lot of them do. You can't do this. So this is like an oversimplification, but this is like the general thinking. Similarly, instead of like observable and subscribing to that, you could also just use an effect to subscribe to a signal and write to that. This advice is overly simplistic because like there's like 4 different ways you can turn an observable into an async iterator and all that. Like, and you might actually still want to use like some kind of separate sequencing call setup. I just I don't think it's our responsibility to figure out all the ways to do that. I think that this fits very nice in third-party land. Now that we have base supports for streams, that's an easy like this is something you can do. I think better solutions will come along, and those better solutions can cater to those better cases and don't have to be core. If you need standard for externals, you'll need to build a thin adapter around a crit effect. It's a known gap. The one X observed community doesn't have direct yet. I expect it to move this to solid primitives. Yeah. So yeah, here's the quick renames, even though they're not exactly the same. Crate selector is just gone. I mean, we say it's a rename, but it's the new primitive where I'm at the snapshot because it's different. Not the only one that arguably is like the last. These two are the most like we just rename them for no reason. Equal function is equal. Get listener and get observer. This would just made our language more consistent. Listener was something I picked up from SJS. Everywhere else, internally, all different things we use the term observer. Removals, start thing, use thing, batch, create computed, is gone, on air, produce, now default, create thing from observable, create deferred. The whole enable scheduling thing and like the concurrent stuff, I'm cutting out of the core. We just don't need it, I don't think. There's some talk about adding it back, but after I made the demo that doesn't even work in React anymore, the Suspense's demo, it's not as nice to have something automatically handle it for sure, but I'm okay with where we landed. For those who aren't familiar, this demo involves like a billion triangles all calculating off the next triangle while putting in an artificial delay in. And React used this originally as their Fiverr demo to show that Fiverr is powerful, but if you make this in React now, it's completely glitched and doesn't work because they changed the priorities because they were worried about the transition starving. Given that, I don't care about concurrent rendering from a performance standpoint. It's like you can, if you really want to defer work, just make it async. See? because the graph gives the guarantees to make sure that it doesn't fan out, that everything doesn't update unless it updates together. I just made a request idle callback to resolve the promise and canceled if this memo reran before it was able to complete its work. It's really that simple, and the end result is you get the same depth, super smooth demo, that React made. So like if you ever come across some weird some weird expensive computation that's expensive, and you say want to offload it to a web worker or offload it async, just make it async and call it a day. We don't need concurrent mode or whatever. Like that's why I'm gutting it. It was. People look at the solid bundle size, even though I think it will be bigger with this, slightly because of some of the other changes. The old solid bundle size, almost a third of it was this like scheduling code that like no one ever used. It was tree shaken, but like when you went to like stuff, like it would just, yeah. Index array, map array key false, reset boundaries no longer needed because boundaries self-heal, enable scheduling removed, write signal doesn't need to be an external API, use or just refs with factories. We don't need these attribute boolean namespaces on captures, and then I got rid of almost all the fancy namespaces stuff. Provide okay, cool. So number 8, dev diagnostics. This is a new document that wasn't there when I first published the RFCs. It's because I did a basic DevTools port that's the same as a solid 1.0 DevTools report, but then I noticed we have a lot of warnings and errors in solid, and to clean up in forbidden scope. And what I decided to do, because I was asking AI how to best help it write better code, and what they suggested was that warnings at runtime are ignored generally, like they're not browsing the console or whatnot. And I wanted something also that would work with DevTools. And obviously errors or something, because if something fails, they check on it. But the AI suggested that what I should do is actually give it a diagnostic or an event loop that it can listen to. So basically, you could just dev.diagnostics, and DevTools can listen to this tool too, but essentially AI could listen to it, and then as it encounters errors, it would know how important they are in terms of severity, where they happen in the code, and then be able to use that to help you write better code. I designed the system, even though right now this is just like our simple warnings and errors that are actually already communicated. I designed the system so that we could do waterfall detection, so that we could add more advanced diagnostics at a dev level that you don't have to warn the people about or like be too noisy, but AI could do, where they'd be like, oh, this is caused by cascading. Is this an issue? We're not sure, but at least surface it without like spamming people in their like console with warnings. So this idea is that the framework itself, and this comes straight from Signals, not from Solid.js, but from the core Signals library, could actually provide more diagnostic tools at runtime, kind of like React Scan or whatever like thing built into the actual Signals library itself, so to identify possibly bad topologies in the graph or propagations, so that like, you could just wire it up to be like AI, build the thing, run it, build a report essentially, and then it can analyze that, same way people do with security, but we do it for graph data topologies to ensure that your app was as performant as it could be structurally. And we can do this because we push the async to the leaves. Async is not opaque to us. I talked a bit about this last stream, but because it's in the graph, we can tell when we have async reentry. I had a whole plan about adding the async diagnostics, but I kind of pushed it out because I was like, that's a new feature. We don't need it to be, part of this. But yeah, that's the core idea here. Strict read untracked. What else is there? Pending async forbidden scope, no owner effect, no owner cleanup, no owner boundary, run with exposed owner, dev to subscribe, dev to capture, message node, and then it's right now these are error and warning severities, categories, triggers. Yeah. Yeah, this is a V plugin that captures the browser console and serves something that would be helpful for AI. How do we enable console. Yeah, right now this is a programmatic API which I'm showing you, where there's capture and then there's subscribe. Yeah, this is great for DevTools too. I've kept the current DevTools hook. I'm hoping Damien will have more feedback for me in terms of how we can make this work in the future. Well, the problem is not everything errors and warns. I mean, so for all of these, you're still getting console errors and warnings. And this is in addition. But the waterfall stuff, I was worried was too noisy. So until we can determine it, because I came up with an idea for waterfall detection, but I'm worried that it's still too noisy. But it could be helpful, right? Because like maybe there's another severity. We have error and warn right now. Maybe we can have like hint or like info or something, right? So we can have like things that, like, even with the waterfalls, there's different shapes. We can be like warn because we like think this is a concern, or other things where we don't know it's a concern and we can just put it as info. What I'm hoping this does though is, because yeah, I think our async system is amazing, that we can detect, like, because of the way the transitions are built in, we know that if you lazy load a component and then fetch under it, that you have a waterfall. It might be intentional, but we know you have a waterfall. We can tell if you navigate to a page and it lazy loads the component and then fetches under it. And you might be like, well, that's what I expect. But a better system would hoist the fetching and fetch the code in the thing at the same time, and we can identify that. And I think that's the kind of thing. What if someone accidentally wraps some code in a show that's unnecessary, and the show blocks the async, which prevents the child component from fetching data? You know, it's funny, React talked about this, you know, we should have like async detection. The problem is promises are opaque. They're really hard to see where they're going. For us, we have full visible view of the asynchronicity. I talked a bit about this last stream. That's why I'm heading this direction. I think the warnings in the console are a little bit too noisy. Obviously, if we can identify real things that are real, I will definitely promote them to console. But now we have we can start at this diagnostic layer as we decide how to promote the right kind of warnings and errors. How does solid the just I have no clue. I haven't done a performance benchmark recently. Last time I checked, it was similar to solid. It might have been slightly slower. It probably got slower. The biggest thing here, and I'm gonna go back to performance in a bit once I get stuff a little bit further along. It's funny. The earliest versions were faster than Solid 1.0, and then the latest versions have been slightly slower. Not latest, but like when I switched this latest rewrite, it was slightly slower. Like 0.01, like on it, like not really, like we're not talking about dropping out of like the same zone as Svelte 5 or Vue Vapor or whatever. The thing, and I mentioned this on previous stream, it's hard to compare because the best mental model here for Solid 2.0 is this. Look at React, right? React is over here somewhere. If I keep on scrolling back, we'll eventually find it. Am I getting close? Where is it? React hooks, yeah, right here. Okay, 151. Okay, kind of like just past the midpoint of the graph towards the back half. Now, if we go over here and find React hooks, compiler hooks, 156. Oh, that's funny. I wouldn't expect the compiler to be that much slower. Let's keep on going. React hooks use transition, 188. Now we're getting into like Ember zone, like and knockout, and like what the hell are you doing zone. But my point is, and actually look, Frey is over here too, which is actually another built-in, no one remembers this thing, but it was actually another thing that had built-in transitions automatically. Solutions that have transitions and async first in mind from a runtime level, I'm not talking like Svelte does something really cool where the compiler where they literally look for the await keywords. But I think systems that are fundamentally using transitions for every single operation are going to be slower than ones that do not. In the case of React, we go from 1.5 to 1.88. So I had to kind of adjust my expectations because if solid, where is it? If solid, where is solid these days? I can't, it's about here. It's so funny how this whole area has like grown immensely. Okay, there's Svelte 5, here's solid. We're like neck and neck. Like, everybody's like almost the same here. Like every run, we just hop around. This is a cool one. Inferno jumped ahead of us somehow, probably without making any changes. Like, that's actually interesting. Anyways, here's POTA, which is made by the guy who's been working a lot on this DOM expressions for Solid 2.0. It's up here too, so that's good. There's GVapor, also the same. These libraries are barely determinable. If Solid goes from 1.12 to 1.13, like loses that 0.01%, and this actually we've dealt with this issue, the slower, which is one of our biggest slowdowns. But if we went to here, and was the same as Svelte 5, you probably wouldn't even shut up behind Svelte 5. Oh no, you wouldn't blink a beat, probably, and yet that change would be the same change as I was showing with React going back 30%. Like now everything in Solid is a transition, and the cost is maybe 0.01 on the scale. For me, that's worth it. Maybe it's not worth it for everyone, but for me, I don't care about the JS framework benchmark anymore. It's been like, it's like, why does anyone care about the JS framework benchmark that much anymore? It's kind of funny. Like Solid was like clearly up here ahead of everyone for like 7 years. I kid you not, like maybe not 7 years for Inferno, but because no, but that was about 2020. So, but like it like any of the big frameworks, or like no one, like we were upfront, no one cared for 7 years. Now people care now. So I mean, I don't know. I think it's convenient when it's convenient. Yeah, actually, the interesting story about that. Alien signals is what our signals basis is based off, except Milo found a way to make it faster. It's not the signals that are bottlenecking us here. It's like the transition behavior that's probably our bottleneck here, like the async first thing. Check out this library called R3. It's worth checking out. R3 Milo MG. If not, I can get to it here. But he basically figured out. This is what Solid 2.0 is based on, are based off of. It's like it took alien signals and then optimized it for the projection case, which no one else has optimized it. Alien signals is actually a big part. You'll actually see comments about alien signals in here because literally the source code is alien signals. So if it makes it easier for people, Solid 2.0 is based off a fork of alien signals. Here's R3. You should check it out. Yeah, the question Milo had was, most of the graph doesn't move around that much, so can we do it in one phase? The challenge, alien signals is a very, very, very efficient way of doing a push-pull, like a two-phase thing, where you update, you flush up, you fan out, notify, and then you pull what you need, and then. But the thing is, it's a 2.5 pass pattern essentially. When you flush out, pass 1, pass 2, you pull until you get to the thread of what you got, and then you propagate back down. So I kind of call that like 2.5. Milo was like, can we just make this in a single pass? And what this library does, it's more complicated, so there's more code than alien signals, but what it does is, when the graph doesn't change shape, when it's static, it just moves forward height based. It's basically only if something moves, like jumps height in a crazy way that we haven't detected yet, that it falls back to alien signals. So it's kind of like the Chrome runtime or like a browser runtime where it, with monomorphic or polymorphic fallback, like we kind of like have a optimized case and then we have a de-optimized case. What's cool about what Milo's done is after you hit the de-optimized case, which is like de-optimizing back to alien signals kind of style performance, future runs will be usually still optimized, so you'll end up back on the optimized case again. Because once the height adjusts, then we will run in the right order again, and we won't have to fall back to alien signals. So he's got benchmarks. He wrote the same JS reactivity benchmarks that everyone used, the one that proved that alien signals was the fastest. And he hasn't been very vocal on it on socials because he's been like using this as research paper. He's a university student and he's going to be pushing it. He hasn't been pushing it in the like prime time. But yes, even though Solid probably does not have the fastest reactivity system because of the stuff that I hammered onto it, the core, I think our basis is the most powerful reactive system out there. It's basically like, what if you could do something incredibly fast and then in the worst case be alien signals? They won't, because the trade-off here is that it's push based, which means it's eager. And this is the thing, you don't have to be eager, and we support lazy, but if you're the eager part is interesting because I think the lazy thing is overrated when you're building UIs, because you're building structured data structures that sit and persist in a tree. There's benchmarks showing stuff that's basically, if you're going to be completely lazy, you might as well just stay on alien signals. This will probably fall back to alien signals. But because of async, I'm content with this being eager. Because this is eager, and async has to be eager because otherwise you get async waterfalls. This actually fit the shape. Originally, I wasn't on R3. I was just going to use alien signals or reactively. Like basically, the progression thing is with Milo made reactively, which drastically improved the performance of signals libraries. He wrote an article, and that article was basically at the same time that spawned everyone else picking up signals. People credit it to Solid, the signals thing getting popular, but at the exact same time, like it was like 2022 or whatever, at the exact same time that everyone's like, oh, hey, I should use signals too, like when Preact and Angular and all that stuff, and all the research happened, Milo basically was like, bang, we can make signals super fast. You can find that article still. It's called Supercharging stuff. And that kind of kicked off this thing where like Preact was like trying to make a faster signals thing, and everyone was using his benchmark that Milo made to show how their signals could get faster. And out of that thing was where alien signals ended up coming. They kind of came in a little bit later, and they're like, look, we have the fastest signals implementation. And it was from that whole push-pull system. It was faster than everything else and stayed that way. And that was kind of the common communication. Vue ended up adopting it, so on. And everyone's kind of happy. But then when working on Solid 2.0, we kind of started realizing that that whole push, pull, push and tri-coloring, which is, as I said, I think it started with maybe MobX algorithm, but if you look at Milo, really pushed this kind of approach forward. We were like, what if you didn't? We wanted to start solving these projections, which are really tricky when you have like a change that goes down one specific deep reactive path and you don't want to over notify everyone. And I started hacking stuff on top, and it was driving Milo crazy. He's like, this is terrible. He's like, can I actually solve this algorithmically? And that's where this came about. It was when we were working Solid 2.0, we realized like push pull good, it works, except there's a whole category of problems that it's not optimal for. And I think the React core team actually came to the same thing. If you listen to Joe Savana's talking about it, the situation he was talking about, that he thought a specialized system could be better than a generic system for handling stuff, and talking about the algorithmic tracing wasn't as fast as possible. He was talking about push, pull, push. So we're like, okay, like to be fair, these things happen independently. Milo had already created R3 by the time that Joe gave that talk. So, but it feels like the React team came to actually the same conclusion Milo did. So I was like, and they're very much on the eager side, right? They eager hydrate. They don't. The thing is, if you're going to do work, you might as well do work sooner. That's kind of the mentality, and I think it plays out especially on structural stuff. So we're like, what if we can make React a system that could do that, and that's the gist of this here. I probably should do a whole stream on R3 at some point, but it's like if you look in the reactivity benchmarks, like the R3 either is basically the same performance as alien signals on some tests or better. Like it's probably the fastest reactive library out there. I think after that, the alien signals guy went in and also improved some performance some places. So I'm not up to date on today's thing, but then like any improvement that alien signals makes ends up getting backported to R3 because it's basically a fork of alien signals. So like it's kind of this interesting evolution. In either case, you could say that I am very aware of the best techniques in signals that's going on right now. And as I said, if we adopted alien signals, the work that Solid wraps it would make alien signals slower the same way that it's making R3 slower. I just wanted to get a really solid, pardon pun, foundation to build this async system on, and the end result, as I said, we're going to have to run the JS framework benchmarks again. It might be a couple percentage slower here there, but compared to that 30% React, that's not what's happening. And that's the kind of change we're doing. We're adding something that's so hugely different that it traditionally has been a huge performance thing, and you're just not paying the cost. So I consider that a win. React and Daystar are the fastest signals we're doing. Yeah, I mean, if you do that, then like, well, I don't even. Yeah, I mean that's those aren't signals. That's I mean it's fine. I mean, if you're fortunate enough that your thing doesn't change shape. See, React's in a different category because they re-render everything. So like there's a clear trade-off there. Like they're not dynamic because literally they recreate everything. So like it's fine. Datastar, I'm not sure, is being honest. You know what I mean? Like it's fine. It's just it's like if it works for your use case, go for it. Is it real? Sorry. Yeah, I got sidetracked by that, but yes. Okay, cool. Diagnostics. Let's switch around. Let's get this week JavaScript going. I think. So give me 2 seconds. Oh, before actually that, you guys, I think I've shown what's being cut. The only thing that I haven't talked about, let's quickly do this before I go this week in JavaScript. I'm gonna quickly make a hack MD, because we should talk really quick about like post 2.0 Solid JS 2.0 objectives, because I feel like we got enough now to be like 2.0. I mentioned blocked a bunch of stuff, which is why we haven't been able to, like, it's taken me forever to get to certain topics, and why it's taking forever to clear that issue list down to where I want it to be. But I feel like now with 2.0, like getting featured, like there's still a lot of work till it gets out the door, but I want to draw a line. I don't want to add any more features at this point. I know people want features, but I think what I've shown you at this point is what 2.0 is going to be, more or less. It gives me tons of ideas for upcoming minor releases though, because there's a bunch of things that that are clear that we should do. Actually, the first one that I should mention is waterfall detection. I could do this during its life cycle, but I'm probably not going to bother with this right now yet. We are going to do a performance pass, so I'm not like JS framework, so I'm not gonna count that out. Next one, activity, keep alive. I know a lot of people have requested that. I feel like because we didn't have it in 1.0, I don't need to hold 2.0 waiting for this. I think this is probably the most requested feature at this point. We have all the underpinnings. I could actually literally like go make it today. Like I did it before. I removed it, but I had something activity. I'm just not confident in all the permutations, and I don't want to commit to something until I've spent enough time with it. I built activity, but then I saw that the React one actually manages the DOM in a DOM-centric way. And I think what this means is that there's going to be a core primitive that has to be able to hold reactivity that has no impact on visibility. And the visibility layer has to come in after. So I have to design a primitive that basically pauses reactivity within a scope. It's kind of similar to the way Suspense works, but it has no tie to the UI. What the design of that looks like, I don't know, which is why this is getting deferred. 3, view transitions. Similar. I think this is a very DOM-centric thing. I think this naturally comes afterwards. I think, though, we have the scheduler now that we're not blocked. So I'm very excited about the potential here. I think this is going to take a little bit of work to figure out, but this seems like another thing that this is how I want to handle animations and transitions in that sense. I don't want to add Svelte system. It's crazy. It was one of the it's the reason that Svelte 5 took so long. I think it's an amazing system. I'd rather this live outside of the core framework. So if we can do something with view transitions, I think that's cool. 4, solid meta. I think we should bring the meta tag stuff in core and the resource handling even more core. I don't know what this looks like. I did the most baseline thing for Solid 2.0. This might even be 3.0. Like, this might be the thing that we learn as we go. I'm the least confident on us being able to pull this off right now and coming up with the right mechanisms for managing it. This takes a lot of bundler awareness, a lot of stuff beyond what we're doing. I think 2.0 right now is going to be an experiment a bit on how that works with the lazy loading components and stuff. I'm still working through solid start stuff. When those bugs get past, we'll call it and kind of continue. It's possible that we already have the underpinnings and we can literally just bring meta across as a minor, but this maybe 3.0 territory. 5, server components. Not 2.0. Deal with server components. Sorry, let me just catch up with the thing here. I don't know about guide. We don't pre-compile generally though. Pre-compiling is not the way to go. I talked about this earlier in the stream. I suggest still, even though people like TS up enough, but roll up, plug in solid, preset solid has all the right conventions. The idea is you ship the source directly with the TypeScript separate here, and then it builds the ESM and CJS versions of your client-side bundle. The reason is the same source code can produce server, client, hydratable, whatever, ESM, different bundles. Solid prefers to compile the source, but if you need... I usually like doing the client-side bundles at least, so people with no build can do stuff. More docs. Cute. People are always working on docs. It has the most active people of the whole solid community. Always looking for help there. Docs are hard. Beyond docs beyond what are there already is beyond the scope of what I can contribute to. I'm not an expert. I can't make, you know what I mean? Like, as long as I can clearly communicate what each thing does, like from a reference guide standpoint, that's about this. But yeah, more docs are not on. We'll have 2.0 doc update for the release. That's a prerequisite. Post release, that's a whole other thing. I mean, it's really hard. You know, with animated visuals and everything will be perfect. Yeah, I mean, really hard to. I'll see. I'll see what I can do here. This is like a huge ask because like who's gonna do it? We have like let's say I have 4 people working on docs fairly regularly, but are they gonna do animated visuals? I how do you compete with like Meta backing teams of dozens of developers? Yeah, you know what? Well, I'll see if I can raise funding for this specifically. Like this is, I mean, almost all our fellowship money goes into docs. It's just really hard. Like, I, if I think this is kind of, yeah, they were, although most of them work on React Native. To be fair, I don't know. I don't think that's the state of things anymore. It used to be the state. But but yeah, since it might not be the state now. Google has 60-ish developers working on the Angular and adjacent teams. I think Meta was fairly similar at one point. They're not all working on the docs effort, but it means that you could actually like have developers building doc solutions. Yeah, I mean, if docs are going to be the pain point there, this is a very difficult thing for us to overcome. I'm just going to put it out there because like despite everything I do, I think we would need about 5 times the resources we currently have to actually get to a point where like this could satisfy, honestly. Which it seems a little bit out of reach right now, but maybe not in the future. You know, but the problem is we don't get there without more adoption. So like this is a very catch-22 scenario. Okay. Sorry, where was I? Post solid. Server components. What do I want to say about server components? Have a design, have some ideas of how to do it. I right now it's just a matter of coming up with the writing coding format. I prototyped something a little while ago. We'll see how that goes. But I need to put on hold. The so solid meta should actually probably move down. We should make this one 5. In a sense, though, I think we might be maybe keep alive and view transitions are the same, but we're looking at like so other diagnostics. We have at least a few minor versions on the books already here in terms of features. Well, I mean, why does TanStack have server components? It's not I. Let's talk about TanStack server components in a minute. Let's switch over. I just wanted to. So the way I look at this is what. So we should lay this out better. Solid 2.0. Where are we at? Right. So what's left to do? Performance audit. I have not checked the performance in like 6 months. It's probably worse than I think it is, but let's look at that. Docs. I'm going to give this another separate docs thing, tutorial. Docs we could branch out a lot, honestly, because there's also like migration guides and like a whole bunch of stuff out there. What else am I thinking about here? Code mods. Even before that, first party libraries. We've already got router and meta going, but I think Start, I need to at least have Start working, even if it's not released. This can kind of slide into the RC time period. Where are we? Sorry. Dev tools update. Yeah. Prefactor DOM expressions. We're almost there, but you're right. I am still missing. We've done like a lot of DOM expressions. What I am missing here is, which is a good point, is integrate SLD. And for those who don't know, it's like a replacement for lit. Solid lit. I still have that on the list. I think DOM expressions, you've done a major and weren't. It's very. I feel like we've done like 90% of the objectives there for 2.0. I honestly, other than one or two things that are kind of still up to debate, I would almost consider DOM expressions where it needs to be. I think we're very, very close there. Obviously, we're missing SLD. I think there's a couple open questions, but like, yeah, I'd say like 95% of the work is done there for DOM expressions. I'm pretty happy with that. You might think there's more stuff. We'll see, but very close to crossing the line. Well, see, that's the thing. That's outside of the people won't do that until docs get up to speed, or they feel that at least the same time that they feel stuff's solid. I don't think now that the API is finally stable, I think this is where that push to getting Cobalt and stuff going. Again, these are outside of my range. I can encourage people like Cobalt developers and give them resources. Like, it's all right. Well, I should put testing library in here too. There's things that we manage, and there's things that are in the ecosystem. I can encourage the ecosystem, but I can't control it. I just need to give them enough time. How long do you hold Solid 2.0 release on ecosystem? Not sure. Okay. So I think you can understand. I think migration guide. I'll put this together here. The tutorials are worth mentioning because they're ancient and there's like a specific infrastructure piece. We've moved all the docs, but the tutorials over. Oh, obvious one that's has to pre-thing the tutorials. Playground. Big one. Okay. So there's still a lot of stuff to do. If you notice though, I'm involved in a lot of these, but these are especially these ones. But this is where this is getting beyond me personally. So just this is going to be engaging the community and getting this stuff rolling forward. That when people ask me how long it's going to take for Solid 2 to come out, it does depend on more people than me. I needed to get ahead of it. I need to get things in a good place. This is going to be the blockers. These are not the blockers. You can understand why I want to draw the line, hopefully. Honestly, I have no clue what you're talking about either. What do you mean client-only components? People already asked for client-only components. We have a client-only thing in Solid Start. I'm not really sure. Have you been keeping? Have you been watching TanStack at all? Yeah, the thing is, um, router and meta are already okay places. Testing library is something I'm working on right now. Like this is where I personally am going next, and a little bit here. Uh, that's what I put performance audit number one, but that is not the order of this list at all. Performance audit is after probably around where code mods is. I mean, if I was to actually prioritize this in order, there's different people, but it's probably a bit more like this. That's a better order. There. Technically, this is like Doc's team. They're gonna bug Milo like crazy. Milo's kind of responsible for the playground, so he's probably trying to do final exams right now. Docs, Milo, me, Alex is working on testing library, Renly, also at start, I'm gonna have to bring Attila in as well. This is me and Tito. It's probably the Docs team again. It's funny because like when I say Docs team, I'm like Sarah, like the same people again. Brenly, like there's a whole group of them. Oh, know what I'm missing here too? Damien. I think this is important. ESLint. I don't know who's doing this. Classically, we have our ESLint guy, but he's been busy. Just need to see there. Yeah. And the thing that's not here too, that's probably important. If I talk to David, website update, redesign. He's been waiting for this chance. So I there's more people on docs, less. Yeah, logo, yeah. Logo. Yeah, we talked about the logo too. Yeah, I don't know if you've been watching my streams. I'll talk about it in a minute when we talk about server components. Okay, yeah, but um, this is kind of the where stuff where like what's left to do. You notice it's a lot of meta stuff. It's not like much of it directly on Solid itself. It's a very different list than this one. Anyways, let's switch to this week in JavaScript. I think we're at a good point to switch gears here. I don't know if there's a ton, but I do want to talk about some stuff. So give me 2 seconds while I switch views and stuff. Just give me a second. Actually, I'm just gonna put this on because I just saw I opened my feed and this is what I saw and I was like, whoa, what's going on? This is so nice. Like opened my feed and I saw this. Had a talk with a colleague at work and he said you're a big React guy. As he said that, I realized that I'm not really. If I ever had to choose to be labeled, I would be labeled a solid guy. Solid is such a well thought out framework. I love TanStack, but I have come to realize most of its offerings are a direct response to deficiencies of React. Solid's first class is most of it simpler and smaller, not needed. RCs aren't. It's like people just tell me what I want to hear. Okay, but yeah, let me throw the banner up for this week in JavaScript. It's just funny when I haven't seen this stuff. It just landed right on my feed. So let's do this. I wonder what the responses are. Oh, heart, Brandon. I'm glad that people like what we're doing. All right. Yeah, but that's not his point. Yeah, yeah. This is your use. Make sure you have to end up with less forgetting. Okay. All right. Let's flip around here just because it was very sweet comments. Thank you. Okay. So sorry, I actually do need to. I feel like I haven't posted much since the last stream was April 3rd. So let's just. Okay, there. Bookmarks. Literally these two, and we already talked about this. So we'll talk about this. So there's actually nothing in bookmarks because I'm pretty sure I retweeted that one. So that's fine. And then let's switch to Solid.js. All right. Okay, cool. We ready? Let's talk. This month in Solid, talking about the beta stuff, not too surprising. It's been the biggest thing for the last month since the beginning of March. Beta has now been out for about a month and a half. So making good progress. Obviously, not everyone's jumped on board. I was on the Reddit and people were like, what do you think is Solid 2.0? Have you jumped over? And most people said no. And it's because the docs aren't there. I don't blame them. But it doesn't stop the tinkerers. And to that point, TanStack 2.0 beta support are already going. Like these guys, I haven't even got the solid start yet, and they're already got TanStack going in here. I might have just broke some stuff with the beta the 7 release because we are adjusting a couple things. They shouldn't be huge, but I'm hoping that we get to where we need to go. I feel like I'm done with the API changes now pretty much, and we're just gonna bang out these bugs. So very cool though. You can go and install TanStack start with Solid 2.0 and apparently query and router, and it's working. So I have no clue how these guys did it. I didn't talk to them too much. I think this is awesome though. I know people are really excited about Solid 2.0. The reason we went beta earlier than I might have thought originally. Was one part cursor and AI, the other part was Tanner himself. Tanner came to me and he was like, Ryan, I just need Solid 2.0 right now. Like, I can't wait any longer. And I'm like, oh, I was planning to do this. And he's like, no, I respect that, but I just need it right now. And I was like, okay, fine. Give me a day and I'll think about it. And then we ended up with the beta release. Yes, I talked about this earlier. If you want the short answer is yes. The more nuanced answer we talked about earlier. You will still be able to use something like Create Mutable, I'm sure. Solid is not shipping it. Yeah. What can I say? This is what you want to see, right? Brenly, obviously very involved in both Start projects and the future forwarding, so a big part of it. But Burke, also great member of the Solid community, big guy behind some of the, especially the Start initiative on the TanStack side. So that's awesome. So yeah, I mean, they just tell you how to install it here. Join the Discord, try it. So yeah, no, these guys are on it. Just in case, people always talk about component libraries. Base UI apparently has an unofficial Solid port. Just like giving exposure to people, pointing out stuff that I might not know or others might know. No matter how many times you yes, there's a Solid version of this, people don't believe you. So there you go. Thought this was cool. It's a little game app created with Solid and Tailwind apparently, and I guess probably the Pixie renderer. Just highlighting. See, not much on Solid. Okay, let's go. Let's switch back around and get on the topics I wanted to talk about. Yeah, 10 of end-to-end testing to start fixing the tests after 2 beta. Oh, yeah, but I mean, how many of those bugs are my fault or their fault, right? The fact that they get by my fault, I mean like Solid having a bug versus like TanStack. I mean, this is good. This is finding issues that will actually, help us find those issues earlier. This is the exact kind of testing I'm looking for, So I'm glad that it was able to just come across. Query was the real surprising one. I have no clue how they pulled off Query. I mean, I know how I'd implement it, but I don't know how they pulled off Query. AI apparently. I don't know. This is the biggest change here. I think we might be this is a big change for Solid. Solid 2.0 is a big change from Solid 1.0. Not as drastic in some ways as Vue 2 to Vue 3 or Svelte 4 to Svelte 5. But on the other hand, this is probably the first migration of this sort that can really leverage AI as a first class citizen. I think this is a game changer. We'll see. Is Tanner running a company? You can view it like that. Tanner is very good. You can almost view it like him running a company. He's very good with people. He gets good connections. He knows how to connect the people to the work and the money to where he needs to get it done. I am not nearly as efficient as Tanner at this to make sure that people, can. I do a lot of the work myself. Tanner is very efficient on the work side too, but he's definitely stepped back in recent times to make sure that he can get the right funding, and that's probably something that I should be doing instead of being head down in the research. But research is also where I'm strongest. So yeah, I mean, the biggest thing is because TanStack supports React, their pool is just bigger. Even if I spent my time trying to get more funding and more work for people working on Solid, the pool is so much smaller compared to React. So it's hard to justify spending as much time there when I could just be doing the work. But you know, that's changing. TanStack investing in Solid so heavily, like downstream, like the way that things are happening, is huge for us, as everyone knows. I think we're like so close to cracking 2 million downloads a week. That would have been crazy, like even a year ago. I think we were almost at 300,000 downloads a week. I don't know where we are at right now. Maybe we might have flattened out a little bit. Yeah, we flattened out right under 2 million. We're at like 1.942, and we were at 934, and yeah, we're like just under 2 million downloads a week. When I say flattened out, I mean in the last since March, but there's a little spike there. I mean, like a year ago we were at 400,000 downloads a week. Now we're almost 5 times that. So like, good stuff's happening. It's just, I don't think any UI framework has grown as much as Solid has in the last year. Table, there's probably a port of it. I don't know if it's on 2.0 yet. Okay, so let's grab a couple of the topics. I've seen talk of AI removing the need for frameworks. As an author using AI to assist writing, it feels we aren't there yet. Trying to debug fixed framework code without introducing regressions is non-trivial. To think app code isn't going to be missing edge cases is fanciful. I didn't know how to say it. I tried to say it more politely. That's why I use the term fanciful. It's kind of ludicrous, honestly. I just know this because like the kind of loops I go in trying to debug issues in framework, like where you're like, fix this but break this, fix this and break this, fix this and break this, and it's just a constant loop. And if it weren't for like the immense amount of tests, you're like, would I even know? Picture writing an application where you don't test every edge case, and because you like, there's behaviors you're not even responsible for. They're just emergent, like just things that just kind of happen, timing in your app or whatever, and they're not like some kind of fundamental thing. Like we have a very first principles approach here, because we're like, we have a primitive that does a specific thing, and we need to make sure that under different conditions it continues to still do that specific thing. But picture building an app where it's like not nearly as tight or hardened or whatever term people use. It's so funny. I find myself using different words these days because I'm talking AI. Like I never use the word harden before AI. I know it's a security term. Maybe it's a tech thing, but hardening tests was not something that I used as a term before. Just like I didn't use invariant too often before AI. It's like just talking to them has changed my language I use. Anyways, kind of aside. When you consider all the things that could go wrong, how like you use the application to just build the behavior you want, and you trust that it will generally work. If you were to remove the framework from that equation, the thing that's actually putting the guarantees in place, like who knows what you're going to end up with? People are like, oh, just build it all with vanilla JS. And it's like every single race condition, everything, like I tried to make a test to see how much tokens were, but I think stuff's still too variable. I can't really get a controlled set in terms of like comparing vanilla JS to a framework. The problem is, the challenge here is to come up with a test that AI can generate in a predictable way that isn't, it's the same problem to any benchmarking that isn't trivial, is very hard. To the point that like, I'm not sure if it would show anything yet. So still thinking about that, but honestly, after debugging these issues, I don't know how anyone could assume that they could just like wing it vanilla JS style and expect to have the same kind of confidence in their code. Reason had really good AI. They are really good at happy code path, but edge cases are human job to find. Right, exactly. So, which means frameworks aren't going away, because frameworks are literally there to give you guardrails around those edge cases. Like it's, yeah, it. I worry about DS being lost to a writing code too. They're vibing now that we built tools for robots now reviews. I mean, that's fair. My whole like idea here on the diagnostic system, so there is a readability concern, but I don't think it's the way you might be thinking. See, AI doesn't care if your signal calls a function or uses a dollar sign. Do you know what I mean? Like AI probably doesn't care if you had to type 3 extra characters. Like it's just syntax. People care about that, but AI does not care. What they might care about is structural guarantees, things that like in terms of like I have to imagine AI looks at code that more similar to the way I look at code, where it goes, okay, this is the declaration, this is this. Like it looks at it structurally in terms of like where it fits into almost like a pattern. And different concepts requiring branching and that's where complexity comes in. Typing more characters is not. So I think we will still like things that are good for AI are still good for humans. What we might not care about is superficial stuff, and I think I'm pretty okay with that. Yeah, I don't think so. React becoming the last framework is not going. No, the reason it's for all the reasons. If we already had that Tanner quote, but if AI does React doesn't become the last. I mean, okay, there's an argument that React comes the last framework because you just don't care enough about the output. But at some point, if AI removes the friction, you'll just want the better output. So it's not that there's no framework or React's the last framework. Well, it just the cost of switching frameworks goes down. I don't know. That's why I don't buy into React the last framework at all. Okay, Deb, I'll bite. What is this? Okay, I see where you're going with this. I don't know. I mean, this is a topic. Maybe let me look at it in a minute. Let's go back here for a second. Back to where we were at. Yeah, it's because I switched over to Twitch again. We should be back now. Yeah, it's whenever I switch over to Twitch that it goes. Hopefully the audio still works when that happens. Um, if you put the edge cases into a skill or agent's entity, then it will know about them and not introduce those bugs. When I read this, I was like, I thought it's interesting to treat framework as a skill, like or as like some kind of description rather than actual code. That's interesting, right? Like because it's like these cases are completely independent. My thinking is around emergent behaviors, but it isn't like those don't exist in higher abstractions, and this doesn't preclude abstraction. What did I say? I guess it is like generally everyone needs a framework, not everyone needs a general one. Do we trust AI to make or maintain those mechanisms as they apply to your code base? Because basically, what I'm getting at here is if you don't create the framework, the AI will create the framework for you. At which point, you're the one left maintaining it instead of someone else. Maybe that's where you want to be. I mean, Theo had a great video where he was telling everyone to build them open source so everyone could fork their own version of the software and then like manage it themselves. I think that's cool. And I think for like enterprise customers or something, that's like something very desirable. But once someone forks your thing, the guarantees go out the window, right? Once they start modifying your stuff, then we can't trust it in the same way. So while this is good in theory, if you want to take that step, I think most people will still just default to them maintaining it. Maybe they'll trust the AI to maintain it, and that's what Theo's point is. But I think people still don't want to take on what they don't want to take on, even with AI. They're just, you know what I mean? So like, I guess we'll have to see if AI makes a huge difference here. My point is that like when I first read this, I had to step back and think about this a little bit more openly because like I was just picturing like me going into HackMD and just writing everything I knew about every edge case and every JS framework into like this like 1,000-page thing, and then expecting to fit that into this skill thing that the AI loaded. Like would we just like use up all of AI's context before it did anything? Like is but more realistically, could you come up with some kind of tighter list that gave enough direction without giving all the answers? That's an interesting question. Like, is that what the framework is? I don't know, but yeah, me and Matthew have had similar things previously. I was like saying, like, I wonder if you like use all the context, you know. Here's one. There's a conflict with the statement. Removing the need for a framework with AI is different from maintaining a framework with AI. AI has strict spec to follow. There's an error tolerance when your product specs are flexible. I think we might feel that way because the use of library frameworks to abstract a lot of problems away. But even in product code, when you go into the same area again and again to fix an issue, you get this sense. This effect is multiplicative. The main problems frameworks really solve is reusability, composition, anything else is extra. Web components can solve that out of the box. So there's a web component person. So there's a chance that AI will eventually retire frameworks. With current trends, the prophecy might be true. Web components. Maybe this is a misunderstanding. Composition reusability is simple at the surface. A function composes and is reusable. Frameworks are about consistency, about making it so discrete pieces can be independently authored yet play a role in shared orchestration. Okay, I don't know if he just was placating me, but you kind of see why frameworks are different than web components. Worth pointing out anyway. Let's keep on going while we're on this AI topic. This one's been a little bit troublesome for me. I was trying to think of how I'm going to do coding demos in the future, and then I'm like, but no one codes, so they're not going to like, because I do these demos where I like make it show how really difficult or awkward something or how much code they need, and then I just like usually my demo is like, hey audience, here's a problem, and everyone's like, oh yeah, I know that problem, okay, and they're like, how would you solve it? And you write something overly naively simple, and then you're like, oh, this doesn't work in React or something like along that lines, and then you're like, let's make this work in React, and then sometimes you code it, usually be effective. Other times you might like show the code, and then you're like, oh, this is all the issues and this is the thing. And then at the end of my demo, I'm just like, let's do the same thing in Solid. And then I just write the original code we did at the beginning and it just works. There's variations of this demo. The React compiler demo was like this too. If you think about it, when they first announced it, they showed a simple example, showed why it completely broke in React and like why it was over rendering, showed how to fix it by showing like a whole bunch of like create memo, use memo calls. And then we're like, what if the thing just worked? React compiler, right? It's the same formula, right? Obviously, I find myself using that formula way more than React is because usually they're not doing it against themselves. But if people don't view themselves as the one writing the code, do they feel the pain? So that like me sitting there trying to type stuff out, it's always very painful because I always screw things up and I miss typos, and the audience wants to yell at me like, you know, and it's like, oh, did I miss a character here? I'm like, my bumbling around only emphasizes the impact of this, where you can literally hear the people like shouting from their screens, so to speak. But what if no one codes anymore? Because in a sense, I haven't been writing very much code, so it doesn't have the same impact. They are reviewing it, right? So jumping straight to the screenshot might be fine, I guess. I think it's roughly the same, but with different framing. Teach them empathy for the agent that will experience it. It goes through the same problem challenge space. Give them be a simpler decision to instruct their agent to use better solutions instead. It occurs to me that at some point in the future, my live tech demos won't involve me doing any live coding. That's until the conference Wi-Fi fails. Ask AI for, yeah, some of it is using Gen. The tricky part with CodeGen is for new features. It's not very helpful because you need like rock solid docs and training. You know, like while I make a thing that like the React's training is overwrought, like people's concerned about that. I think brand new things as they first come out, like you still need to give it a little time for things to kind of absorb into the ethos, you know. It's hard because I find myself less about 80 advantage to use simplicity code ahead, right? But who's touching coding line? They only will reach for the most library, never the best one. It's fair. Focus more on selling how the better solution architecture will help devs using AI to output better code that's more reliable. I used AI a ton, but still care a lot of the quality. It's hard to measure, hard to demo in a way that triggers emotion. There's skepticism. Conceptual arguments are lost on people. Otherwise, I think Solid would be more popular. I feel like we spend a lot of time here talking about conceptual arguments, but the people are just like, who cares? Use React, right? because measuring shifts from this is hard to write to this is hard to trust, right? That's a reviewing thing. So I think it's actually better. I tried this recently on a stream when I was talking about the async stuff. I think it's better to actually show the broken code, but make it people think that it's correct, kind of like I do in the first step. So be like, present a problem, lead the audience to simple solution. Even the audience knows that the simple solution doesn't work. Then show them something that looks reasonable, convince them that the code is good, even though it's way more bloated, and being like, look, you added this and this and this and this. And then they're like, oh. And they're like, oh, yeah. So you have to do that. That kind of sucks, but it works. I get you, you know. And then go, actually, guess what? Fooled you. Again, this still doesn't work. Show them all the ways that it's broken, and then go back to the original example at the beginning and show how it's not broken and works with solid. That might be the proper sequence of events. So instead of making them go through the pain of getting to the right solution, stop like at the 80% mark and make them think that they've solved the problem, but really haven't. I don't know. Food for thought. I mean, this is an angle. Obviously, it's easy to reason about, but that doesn't give the emotional response of the pain you felt going through and writing it. But maybe we can trigger that same emotional response by giving people a false sense of security and then ripping it away from them. You know, where they're like, okay, because that's what AI does. You build something with it and you're like, damn, how did it do that? That's great. And then you realize you're like, you ship it and then you realize, holy crap, everything's broken. Async rug pull, yeah. I don't know. I'm just kind of thinking out loud. But I think that like the way we demo is different. And I think maybe that's the new solution. I think it's maybe not actually spending the significant time fixing, but coming up with a justifiable position and then poking holes in it. Well, the thing is, I do that, but then you lose a bit of the impact. There's a difference between you missing a comma and you catching yourself immediately, which happens, like it didn't compile, and you're like, oh, okay, that's fine. That happens in live demos. And you getting stuck and not being able to present the demo. I'm not suggesting like when you can't find the one comment and you're sitting there, you're like, what the hell's going on? I'm talking more of like the natural thing, like this, right. And then when it's part of the flow, people get pulled in because they're writing the code with you in their heads. Well, I mean, that's the thing. I think I have to control that. I don't think I can have necessarily trust AI to make the faulty demo. I mean, I could probably find a demo that AI will make faulty pretty easily, but then like, I mean, maybe that's a trick, and then like, trust on the day that it won't. I think it's better to appeal with some pre-generated code or pre-made code to the human and be like, hey, they don't care or know with AI. You can even fake it and be like, AI generate this and then show them it. It doesn't really matter. The point is that they're now the ones reviewing it and they have to make sense of it, and you make it look really sensible until it's not. Anyways, just food for thought. Yeah, there's a lot of people trying to tell me how to sell solid, and I'm like, basically, and the selling thing or this just doesn't work. You need to tug at people where they feel it, and just telling them that it speeds up development, lowers cost, reduces complexity, better performance, more accuracy, but we've been able to make that statement forever. No one cares. I think this points to fool's errand. The barrier to new programming language has never been lower. How does the effort should focus on onboarding AI assisted development, solid derivatives for tooling, document ecosystem, or world-class data documents AI. AI doesn't change the fundamentals, but I suppose we are at that point where the misuse inefficiency of AI is a bigger problem to solve. I don't think these are unrelated, but it's harder to prove. Yeah. You mean when people don't have to deal with problems, does the problem really exist? If a tree falls in the forest, there's no one around to hear it. Does it make a sound? The problem is people still have to deal with the problem. So I think that's really what it comes down to. We have to convince them that they're still the ones who have to deal with the problem. Not being stressed by hydration errors. That's an emotional response. Yeah. Oh, what do we got here? Okay. Pop quiz for people in the chat. You guys are probably the only one who could probably answer this. What is this a logo mashup of? I'm gonna let you guys guess at this one. Raphael, I see your question. I'm actually gonna pull something from Reddit, which is actually a great answer to that question. Solid duck rocket. But the question is like, okay, so this stream probably recognizes this as the infamous solid duck. So this is the solid logo as a duck, cartoonized. But does anyone recognize where this rocket's from? Oh, we have ding ding ding. We have I saw this in a Discord channel, but yeah, solid star, not start, solid star. Of course, I'm never gonna find it. Data star. There it is. Solid star. Data star with solid JS reactivity. Solid star is an almost drop-in replacement data star with solid JS reactivity under the hood, enabling interoperability between hypermedia-driven front-end logic and solid components. So it's just data star. So it's HTMX plus solid is reactivity system. Wasn't even realized it's a project, but it looks like Katja, who's on the solid start team, was actually a big part of making this. But it's a thing. Yeah, it took me because if you actually look, this is the data star. Let me see if I can find it. Data star. It's the data star rocket logo. See, there it is. But fun. Yeah. Okay, so what we got left? We should talk about TanStack server components. Yeah, okay. Okay, before we do that, I will look at what Dev posted. How does Svelte async work with context? What happens when a parent component fetches some data and sets it into some context for the child component to render? Does it trigger the pending boundary above the parent component or the child component? Apparently, you can't set context after an await. This might be a bug. Not a bug. The error could be clear in this case, but the behavior is by design. Svelte renders things out of order. So the setting context after wait is likely too late. Just put a promise in the context and await it where you need it. Okay, I mean, that makes sense to me. Past async to context is being wrapped in a promise. I mean, the demo is purely demo of the beta criteria. So yeah, so they actually enforce it, which I mean is good in one way, right? Because the challenge here is that I'm trying to see what you were trying to get at, Dev, because the challenge here is if you unwrap too early, you block the whole render tree. This would have been a good quote for my last stream where I spent the whole time explaining the this diagram here, because the problem is here in this zone it's a promise, right? So if you're up in your like top of the root thing, if you keep it a promise, you push this bar down very far, which means you have promises everywhere, but it means that you're less blocking by moving the whole bar down. Obviously, we find this interesting as solid because we decoupled this, which means that we can be colorless and non-blocking everywhere, where there's a definite trade-off. You might not care about this trade-off per se, but understanding this, their recommendation is basically to reduce the blocking, right? So much for having edge in DX. I mean, it's funny. I guess this makes it more real for people. Like for me, this is just obvious. When I look at the shape of the problem, like obviously this is not going to be better DX. So I saw Rich claiming that they have an edge in DX because no split effects. No, I mean, I said the whole last stream. Yeah, it's funny. It's fine. Like, I mean, obviously this is I'm going to show this example again just for fun, but obviously this is contrived, but it doesn't matter if it's context or components or whatever. If you can fetch up here and then pass it through like a bunch of different components so that it gets rendered down here, and these are actually the same components, just accepting a different value, and put the loading around here. So when I load it, what you're going to see is the outside, and these all render once, and then these pop in, like loading, pop, But like this demo is almost impossible to create in an ergonomic way in any other framework, right? Because what I'm doing is as I'm passing it down, I'm actually multiplying and adding to the props. I'm like, fetch this thing, add a 1, times it by 2 or times it by 3, and then stick it in this component and put in a loading boundary. Because this is a number, even though this is async, doesn't matter if it's async, but because it's async, fetch a number in 2 seconds. We take that number that it fetches in 2 seconds. Because it's already a number, we can add to it here in the props. We don't have to worry about it. Like we've already done the await, but we're not blocking here. We're blocking at the end. So we can add it and then take that prop and times it by 2. We can touch it in every single component down the tree until we actually render it, and yet somehow not block anything until the end. The other option, which was, I think, really good, that I really enjoyed. Sorry, someone showed it in their own framework in Retend. Hopefully it's still there. Is essentially what, I mean, they forget about these signals, but essentially deriving it with doing .then as you pass it through, right? So like there's the +1, there's the +2, and then do +3, and then doing it down, there's a ×2 ×3, and then putting it through here. And then they have a special type, right? This could be just promise though. But yeah, I mean, you could do something similar in Svelte where you could like just keep on thenning the promises. You couldn't await them though, because I think the await keyword is special. I think this is the biggest challenge here of overloading the await keyword, is it means always the same as use. Like it means like it's part of the framework. It's not like you can't just use it. Maybe if you wrap it in a function. I wonder if you could just like wrap in a function and make an async function, then you could get away from that. Fine, using .then isn't that bad either. But then, yeah, if you need to compose anything, you would have to like promise chain it. I don't know if we're rewriting the playground from scratch. I think we're just updating it. I think we were code mirror at one point, but we had issues with it. I can't remember why. I think the guys work on it more, but I'm pretty sure we were code mirror originally, and then we switched to Monaco. It's probably for some reason for control. I don't know if I have much to say about this beyond what I said last stream, honestly. This doesn't surprise me. It just comes with the territory. We can, like, I guess it's more ammunition if we needed to care about like the DX here, but for me this is just so obvious that I think we talked about this. Like nothing touches the DX that we're doing for async and the guarantees. Like we've really hit a home run here. It's fine. All right. Let's move on. Let's talk about server components for TanStack. What did I say here? In my early designs, I noted I wasn't sure this is where it ultimately needed to land, but given the state of things and the competition not going to punish this at all, it's a huge capability upgrade that will put RCs in the hands of those who come before. Yeah, okay. So basically, Tanner announced React server components for TanStack, and while I'd say the response is overwhelmingly positive, there was still a substantial portion of negative views where they're like, these aren't the React server components we were hoping for, you know? And a lot of this derives from they were like people wanted like Next.js structure. They're like, I think there was actually a conversation I was having here where someone was like, this is barely RC. And when I see how it's implemented, I was very disappointed. Calling RC without having any of the conveniences is misleading. Maybe it's fine. Okay. When I hear RC, I think implementation that explicitly mentioned on the official React docs. I'm not even saying it's necessarily bad. It's just not what I expect when hearing RC. That being said, I think this implementation is less convenient and more boilerplate, which is true. It does have more boilerplate. We also have a ton of code using Next.js style RCs that we can't trivially port. We need to retrain our devs. I was really hoping for something that lets me port TanStack because I'm not really happy with Next.js. But I also think these primitives look cool. I think they should be a bundler integration that does something similar to Next.js that get rid of the primitives. And I was like, well, they still support use client. You can do that. That's the thing. I'm not happy. And I'm like, if you're happy Next, there's probably no reason to move. I know I wasn't happy with that pattern when work on Solid. I ended up here. The thing, I'm not happy with Next.js, but entirely different reasons. I'm pretty happy with the React team came up with in regards to RCs, and I'd love to see that in RCs in TanStack. Again, based on the official docs, this is what I assume RCs entail anyways. Okay, so this is where the thing. People who are used to RCs with Next are kind of very disappointed. And I wasn't expecting these people to come out of the woodwork, which is interesting. This is more of a testimony on where Next sits than anything, because I thought people, benefit of the doubt, Next has a pattern. Next is a popular framework. People are probably happy with Next at that. It's completely okay for TanStack not to be Next. Do you know what I mean? Like, if you like what Next does, use Next. But there's a group of people that would, I guess, do almost anything to get off of Next, and they're really hoping that someone would just rebuild not Next. And I guess like Cloudflare's vNext or ViNext or whatever is an example of that. But people want an actual maintained project, not someone's like experiment. And so they're hoping TanStack would be that thing. But TanStack has its own identity. So I can see that. I wasn't expecting to see as much of this because I was like because it's kind of like, yeah, as I said, I think this has more to do with Next than it does with TanStack. Sounds like he's actually looking for Waku. Yeah, possibly. But yeah, I mean, the design here is not surprising to me, but it's probably surprising to people outside of our ecosystem because this is the design that we came up on stream the last couple of years, essentially. It's tailored for React here, but you this should look familiar if you've watched my streams the last couple of years. So what is it? Status quo. Most people think RC is the server first way. The server owns the tree. Use client marks interactive parts. Blah blah blah. Small community make streaming, server rendering, co-located server side code feel built from the start, but it also turns RCs from a useful primitive to thing your whole app has to orbit. That's a fair way to put it. The framework ends up owning how RCs are created, where they render, how interactive boundaries are defined, how UI gets composed when data or users change. The part we keep getting hung up on. We do not think you should have to buy in the whole model up front just to get the value of RCs. Okay. What if you could use RCs as granular as you could fetch JSON? In fact, what if the client decide how server rendered UI gets fetched, cached, and composed? He says the client, but he means the isomorphic code base. He means the the code that is outside of the server functions, which, if you think about it, runs in the client and on the server during our SSR. It's not surprising because you came up with it. Yeah, okay. In TanStack Start, the core idea is that RSCs are just the streams of data that you can fetch, cache, and render on your terms anytime the client inside the server owns a component tree. That one shift makes them far more composable without changing anything fundamental how they work. With TanStack Start, RSCs are just React flight streams. That sounds too obvious to say out loud, but that's exactly the point. We do not want to wrap a black box convention, blah, blah, blah. To be fair, the convention is important structurally of server first. It's the same reason islands are great, or web components, well, aren't great, but why web components are designed the way they are with the Shadow DOM. It's because, like, the light and the shadow, you have two systems that basically are meant to stay isolated, and you have one connecting tree. The problems I explained are all structurally based, and that's why the solutions for them are very similar. So islands, next server components, web components all have this kind of almost coloration rule where you can, like, import from one but not the other. Like server components say that you can import client components into server components, but you can't import server components into client components. That's kind of the structural rule around it, and it's for good reason, because it lets them keep the server tree as one consolidated tree. It means you never go back and forth to the server. There's no possibility of waterfalls. It's basically encoded into the system, and the client kind of just sits in these little pockets. This is very powerful because you know what, nothing on the server has to go back through the client to get to the server again. Like what happens on the server stays on the server. Sorry, it just made me think of how much that's like the Vegas saying. Like almost memeable. But this does break apart at a certain point. Because otherwise we wouldn't be having those security concerns that we were having. I'll get to it in a minute. But let's continue here. What does this mean in practice? You can create and return them from anywhere. You can decode them, cache them however you want. What does this look like? Sure, create server handler. So this is how the server function, and then returns an RSC, and then you just call render to stream. Okay, seems straightforward. And then you can read them inside query using create readable stream, and then get them out, and then render them as like query.data. Although I think the thing is, you actually, what if you need to pass props to them? This is passing arguments, but what if you need slots? I guess we'll get to that in a second. Caching. Yeah, because it's just a query, it's caching. See, the funny thing that I think that was kind of discounted is, well, I think the structural part of normal RSCs is really important for serialization. Like, even though React doesn't really leverage it, like, and it's hard because of async. But generally speaking, if you know that the tree is always on the server, and that the only way that stuff gets to the client is through those client component serialization, everything that doesn't get serialized as props into client components can literally just never get sent to the client. And that it's a little bit harder when you're driving all the fetching from the client, because now your context, your like long living things are living in the client, which in reality, some of that stuff's going to be there anyways. It means you're less likely to be able to drop the serialization or the double data problem structurally, which is why the original form is kind of useful. But it is worth pointing out that React ends up double serializing everything because they end up serializing the JSX of the server components as well. So you're like, you have this, you still end up double data encoding because you have it in the props and it's the JSX. So it's like, they're not really winning the way, like, say, Islands and Astro are. So I understand, this is why I kind of like was like kind of backed away, because I was like, I'm probably fine just not using server components because I'm like not getting that win anyways. But what is cool here is that you can just give it a cache key. This is using query, right? Caching. The challenge with RSCs traditionally is when it's one tree, every time you re-render, you're re-rendering this one tree, which means that if you fetch from 5 different data sets, now suddenly you have to manage on the server now a cache, because you don't want to like refetch all the data every time you do everything. Whereas when you have more granular chunks of server functions, your data might be less likely, like you can basically go, I need this piece versus that piece, and the server might not even need to cache, because it's like just like the same way, like you might cache it to the client so you don't fetch something you already have if you treat it like data, but you might not like need a server side cache to accomplish this granularity. Like the problem is when you go and you say, hey, I updated something in Next, it's like re-render the whole page. This is why caching has been so hard in Next.js over the years, and they've had to come up with stuff, right? When RCs become just data, the cache store gets a lot simpler because they're just granular streams delivered plainly over HTTP, handled transparently, right? Because a bunch of people, I saw them, some people responding like, how does this work with React cache and blah, 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 and all this? And it's like, once you start building with this structure, I suspect you're not going to need the same tools, because you already, the whole caching or waterfall concerns are already structurally handled like by you using these client-side tools. We've been dealing with waterfalls and basically caches in the browser forever, right? It's just like structurally the way you build your apps these days. That's why we have route level hoisting and stuff. I'm not saying these are the best DX patterns. I'm just saying we literally build to account for waterfalls. So like, because these patterns are in place, even though the mechanism itself doesn't prevent waterfalls, the way you use it will generally not waterfall, right? This is a very different take than when Next came out and they're like, no more client waterfalls, only server waterfalls. Yes. And it made it sound like not all waterfalls are bad. You know, like they made it sound like server waterfalls were like a good thing. No, they're not. But it was almost like that kind of spin. This system, if you keep the client patterns, which would waterfall, because it's isomorphic on the outside, if you solve the waterfalls on the client, you're also solving the waterfalls on the server. So hence no waterfalls. So structurally, even though it's not the most ergonomic or automatic, you've actually solved for that problem. And caching is a very similar concern, because structurally you're only invalidating what you need to invalidate. Well, guess what? You probably don't need additional server-side caches. I mean, yeah, it's not for stuff that changes often. It's not its strong point. It's actually best suited usually like that architecture when you have things like islands, when you want to do like e-commerce, not for things that are updating rapidly. Of course, you can just put client components on it, but at a certain point, your client components grow, and the mutation story is still awkward unless you add, let's say, like client components have their own APIs. If you have to run the data through the server components, it's like full page again. So like you end up with like 2 different apps, 2 different architectures sitting next to each other, like you do with islands. It doesn't feel as unified. This, however, does more. Query, fine grained control. Yeah, so he's showing like different payloads here, right? Get greeting, server function. So he's rendering one thing and then getting the query, automatic route-based caching, that's fine. CDN caching the get, of course you can do that. Security one-day data flow. Okay, well, it's because this mechanism is using query, he's not using flight protocol back. He's using server functions, not server actions. So they're not using the official React mechanism, which kind of gets back to, I said earlier, the benefit of server components in the next sense is that the server becomes one tree and the client just interlays it. So you never do this. But use server added this new complexity because you can render a server action or like a use server inside a server component, which meant that you have server talking to server, but these are in 2 different requests. So how does a server talk to a server over 2 different requests? And actually, I'm going to put this blog post in here so people can read it if they want to follow along. Well, guess what? It goes through the client. This has been basically the security hole. It was first like originally was about like them not encoding or hiding stuff in forms and all this. But generally, if you're going from one server request to a next server request, and you handling this via closures and stuff, your stuff is going through the client in the middle. Even though it looks like you're looking at server code, you're like, I have a server component with a server action calling something on the server. The bridge between that is a hidden client-side bridge. So like, by treating this as just a data format, they're not completing the loop. And especially if, like, don't get me wrong, everyone's scared to use server or like server function. It's not about the syntax, right? It's not about, he's talking about like use, it's not about the syntax. The fear here is that, like, classically, people didn't like React actually almost pushed it this way. They didn't want you to use server originally inside client components, because think about bundling can leak, right? Like you could what if you accidentally include something from the server in the client side bundle, because it's in the same file and you use it inside the use server, but maybe you don't use it inside your component, and somehow it just ends up in the same file because it doesn't split properly. This is scary. Now, the thing is, if that fails, you know it at compile time. There's no hidden runtime behavior behind that. It's seriously, but it bundled wrong. So that's why you can do stuff like import server only, or like things that throw when it's not on the server or whatever. That pushes it to runtime. But theoretically speaking, this is something that you can tell from bundling. You know this when you build your package. This is not a runtime behavior. So in a way, it's way safer than a scenario where you implicitly have this behavior because you're communicating server to server through the client in a hidden way. So yeah, it's not about the syntax. It's about the fact that the way they encode that communication. So if you had a server function, and this is the thing here. It's not about use server. It's that if you're in here rendering a server component wherever it is, and that server component calls a server function, like your server component's not going to have an event handler to call the server function. Do you know what I mean? Like it can call server function while it's on the server. That's not going to the client. It's the thought that you can make a server component have a client-side event on it that then calls back to the server that closes over. That's the problem. And because structurally you're using basically like React query or whatever, like you're using these client-side primitive tools to do it, you don't end up here. Structurally, it's not about use server. It's literally just the structure doesn't lend to it. Yeah, I mean component to action, yeah. That's not the way people talk about it as much, because they talk about like the full flight format. But if you think about it, it's actually a structural concern. No server components at all, client first, hybrid, server components are static shells, mostly static, fully static. One framework, one mental model, what we saw on TanStack.com, block, page drop. Yeah, no kidding. Lighthouse score went up significantly, page load went up significantly, transfer size dropped significantly. So there's benefits to doing this. RCs are great when the content is when the page is content heavy or dependency heavy. Docs, blog, blah, blah, blah. It's less obviously useful when the page is already mostly client state. Dashboards, blah, blah, blah. That's why we think they matter, blah, blah, blah. Introducing composite components. Okay, now we're getting here, because this is the thing. So how are they doing then? Handler, await, create composite component source. So this one now has props, and then they return the source, and then and then they passed it into a composite component. Oh, that's an interesting API. I need to think about this. And it's experimental. Okay, cool. This kind of next app data, blah blah blah. Okay, so that's the gist of it. For people who don't get it, like the idea here is the arguments, like the post ID, the things that trigger re-render. This is an important split, by the way. The things that actually trigger refetching only happen in the query level. These slots like these props on the component don't trigger re-render, which is important because when you try and just like stick server components in the client, any like prop change or something could cause it to re-render, and then you're like, well, what the hell, right? You're just going to the server causing waterfalls. This separation kind of protects you a bit because you're basically saying like, look, I'm only going to the server to update if like post ID changes. Changing the props, things that are client side rendered, even this, you might be like, how are you doing a render function on the server? I explained this in a previous post, how to do this. But like all of these prop level type changes aren't going to impact you because you can change this, and these are slots, so the client can keep on updating without going back to the server. This is the key insight that we had a couple, maybe about 6 months ago, and that changes the equation considerably, because component re-renders do not cause you to go back to the server. It's only if you like your data or your changes. So what does this have to do with anything? I don't know. This is pretty cool. I to see this implemented. I said I wasn't sure if this is where we should land initially, and what I meant by that is, I just need to get back to my profile. What I meant by that is that we've been following this, but I have basically 4 HackMDs, which charted my kind of journey towards the current solution, right? It started with this one back here where I was talking about the problem with data fetching patterns, right? This is an old thing, but basically the idea was when you have mutations, it changes that loop. It makes that it's a full circle. It's not just like a get. And once you have that full circle, it changes things. So like classically you do a simple fetch call and do a direct mutation, right? So you just be like, it's single flight. You just like send the data in, do some change, get the patch back, so like say updated to do, get the to do back with the updated info. Caching is optional, mutations are arbitrary. But the cons is every single place that you use to do, you're going to have to manually update. Difficult to apply changes to the impact. Yeah, sorry. Always requires manual mutation to apply changes. All data is required to be in the browser, blah, blah, blah. Then there's like TanStack query, which improves on this because now you can automate stuff. But the problem is that it's usually double flight. Like you do the post and then you do the get. And it's also, again, data in the browser. So this is not a bad solution. It's just the multi-flightness is kind of awkward, right? Then we got like Remix, which is also generally multi-flight, isn't as granular, but on the positive is automatic compared to the first one. So in a sense, I put them in a weird order because this one's almost a better version than the Remix version. But it's important because when we get to server components, it's like taking the Remix version a little bit further, where it was like, but making it single flight essentially by using server components like Next style. But loss of granularity, generally full page, cache part of the servers you wish to save work. So what I ended up coming up with was what we have in Solid Start today, which if you notice has only one con. It's the only thing in this whole list. This was 2 cons. This was 3 cons. This was 2 cons. This is 3 cons. I realized that if we combined a couple of these approaches, we could make it single flight by using the router. And then basically the only con is that all the data code is required in the browser, right? But outside of that, it solves every other problem. And that's what Solid Start is today. That's what TanStack was doing. That's Feltkit. This basically defined the single flight mutation router where mutation approach kind of came up with this, right? But it actually showed that like this was actually acceptable in a lot of cases compared to RSCs. It actually had less cons, even though like it was for things that were highly interactive. This made a lot of sense. But then I started thinking more, and I was like, server components actually composable. We covered this on stream before, but essentially not really. So I used this to convince myself that we didn't need server components, But then we start switching around here because Tanner is like, I don't want to use client. I want to use server components. So this was the start sketch of basically making a server function call return server components, and like how this is describing how we would do render props, essentially, and slotting. And then, but how do you solve double data? So like I basically was like, I don't know if this is good. And this finally manifested when we got to isomorphic first, which is where we kind of got that split where we have create server component or whatever with the props ID, which is the fetch, and then we slot through the other stuff by putting it on here. But this is kind of all the preface to understanding the design of this thing. It's interesting to see this journey actually materialize. I think it's really cool what they've done here. The only thing that I think I want to leave on this note here is I was thinking it might be cool. And I don't know. It's funny. We couldn't do this in Solid, I don't think, but I think it'd be possible in React. What if server component would look like this? Get server component, whatever it is. And this might seem kind of crazy, but like this is where you put the stuff you need to like number. This is where you put like the stuff that causes it. So let's call it get user like component. I think just something I kind of thought, because functions don't have a meaning in our encoding format here. I was thinking, what if same solution as TanStack, but what if, and then you do something like just children JSX element, whatever. You're gonna make me do it. I'm just trying to get like TypeScript not to yell at me. JSX from solid JS or something. Okay. Sweet. It types. What if you could do this? Get user component. What is the type of this? Const. What's the type of user? Oh, so I've got to put it ID 3. Or sorry, actually this one would be just 3. Get user component 3. What's the type of this? Oh, actually, what if we could do this? This is it's just something funny that I was thinking about. The types of the components would actually be proper, right? It's user of props children JSX element. So I know this is just like a funny aside. I was just thinking, if I was ever to design this solution, I'd consider this. The tricky part obviously is because we'd have to wrap this in a memo. We would actually like get a function, then calling that as a JSX element doesn't exactly work, or maybe we need like a special hook. But like for something like React, I think API wise this actually works. If you just, because if you said that returning a function from a server function was a server component, like that was what it is, like you don't really care what this is, then from a TypeScript standpoint, awaiting that would give you a server component. This is about the most minimal syntactical way I could see it. And the cool thing is, because you on the server control calling this and passing the fake props in and doing all the rendering, like the render to stream essentially and all that, you can basically call this however the hell you want to manage it. So like there's no need for the explicit like render to stream or whatever, because it's just part of the syntax. I don't know. It just an aside. Is this just weird? I don't know. Just food for thought for people in the future, I guess. But maybe if Solid ever supported server components, I could see it looking something like this. See, our problem is we have to always wrap our JSX and functions to inject reactive context. And this actually gives us the means to do this because technically speaking, we'll both be calling the component on the server to inject the proper placeholders. So technically we can, it's whatever the server function protocol that can actually provide the wrappers. And then on the client, whatever we return on the client side wrapper side of it, we could just, basically the whole thing could be handled by the server component encoding and reading. So yeah, I don't know. Interesting. Okay, cool. I think that's almost it. Oh yeah, right. The last note to end on. After this server component thing, negativity kind of came out. There's pushback, right? Where was it? I think people might not be following the blessed React path of this protesting capability about it. And then Ricky was like, hey, why is one path blessed or another? You know, if you shouldn't do it this way, we wouldn't have demoed it like this originally or allow you to do stuff. I don't know if he was talking about the slotting, but generally he was like, I don't see an issue with this. So started quote treating this to like reply to people because he's basically saying it's okay to use server components this way, you know. But I think this whole discussion around server components and TanStack started up again yet another like, oh, those React developers are just learning what rendering on the server is like, which to me is really comical in a sense for React. You could say this about other frameworks perhaps, you know, like maybe they didn't care, but React was literally built with server rendering in mind. Ricky mentions that back from like the very first open source commit, they were talking about server rendering APIs. But to understand this, you have to go back farther to Fax.js, which I mean is going to be our last little quick shout out. I know I've shown this out on the stream before, but before Jordan Walk created React, he created Fax, and it's called Fax because like it's a very similar concept because actually resumability from Quick, they described it as like a fax machine. Like you fax, like you take a snapshot and then you fax it to the client and then just have it pick up without like having to re-render everything. The Fax.js here means the exact same thing. His whole idea was coming up with a system. And this is where React originally was doing like string diffs instead of like the way the virtual DOM was today. But the original idea here is that you can just render something out on the server and then pick it up and hydrate it in the client. That was the gist of it. That like all they need to do is two main topics are statefulness and event handling. These will be covered further down the README. Okay. So this is 15 years ago. Optional server-side rendering. The reason why Fact.js uses top-level event delegation for event system is so that the interactive portions can work with markup regardless of where the markup was generated. Once you have a component instance generated, the last two parameters of the gen markup method specify whether or not the markup should be generated and returned and whether or not the event system should be used. For server-side rendering on Node.js, just the first parameter true, second to false, change this arbitrarily, blah, blah, blah. But what I'm getting at is this is very early, like, server SSR hydration story with the idea that they would use string diffs. Like this is the like it makes you wonder if React came up with the whole virtual DOM re-render method originally actually to solve server-side rendering out of like, because if you think about it, it probably wasn't the logical solution for how to update things on the client. They just realized that it would actually still work here. I wonder if Jordan Walk's original like inspiration was actually for SSR, and the whole like you can use that snapshot to diff just kind of came out of like, oh, we already have the system. It's actually not that bad. It actually outperforms in a lot of ways some of the current systems, you know, out there. The only other contributors is Jamie Kyle. That's crazy. Just kind of food for thought, you know. I think it's just funny because obviously there's always pushback on this stuff. I think someone was like, there was a response. Yeah, what was it? HTMX, you can just SSR template data point and tag literals. What are we even doing? Yeah, I mean, if things were that simple, if only things were that simple. I I, I think I just think it's funny that time has passed so far along this route that we don't even remember where we started from, and people assume that like it's almost because they've morphed into their own things. People assume that um, these other considerations weren't taken into consideration. Um, it's tricky because when new developers come in, they don't have the same kind of scope or history. But React was very SSR first right from the beginning. Some people mentioned that it was not pleasurable using SSR. I get it, but that's what he said. I mean, it did, but the pain to use in practice. SSR in your component tree is easy, but you need the server fetch, serialize, hydrate, blah blah blah. Was one big proposition next added, but that took time. Completely, the gap is still being felt today. The fact that we need a meta framework suggests we haven't boiled this down enough. I think we are very close to getting there, hump, but it's been like 15 years. Yeah. Catching up with chat here. Fetch and set a memo thing. Why would anyone ever want this? I mean, technically speaking, if you're talking about server components, there is a world where it can remove double data serialization and it can remove uh and you can ship less code to the client. Given all the recent security concerns, RCs took a back seat. Yeah, probably no one wanted to talk about it. That makes sense. You don't need them, no. I mean, but like RSCs are like a boundary consideration, right? Basically, if you can reduce the size of the client piece, then you are reducing something. RCs also give you this actually only use what you actually render things. You stop thinking about data pass around and fetch PTR. Yeah, exactly. Which is nice. The problem is in practice this doesn't actually always map out nicely. But it definitely for like mostly static content. Oh, fax machine. Ryan to Ryan handoff. Did I miss a raid? Oh, that's too bad. I'm literally just finishing up here. Um sorry folks. I'm just wrapping up. You caught at the very end of the stream. Yeah. I I am done. I have been streaming for 6 hours, so sorry, couldn't be more entertaining. Maybe I'll just like pass you on to CM Griffing. So uh, I don't know what he's working on today, but I am literally just finished. We talked about RCs, we talked about Solid 2.0, we talked about a lot of cool stuff. Yeah, but mathematically proving guarantees the solid offer, all of them. I don't have time to get into it anymore. Oh well. Okay. You all have a great weekend. It'll be another couple weeks till I stream. Probably one of my last streams before I go on break. Um, but yeah. Otherwise, yeah, I'm gonna start the raid up for you all. Team Griffing seems to be going, and I think uh, I think I will catch you all on the other side. All right.